I welcome you all to our Certified DevOps Engineer free live training program. This is our roadmap, and according to it, we have successfully completed day 1 to day 6. Now we are moving forward with day 7 container orchestration, focusing on the one and only ultimate tool, Kubernetes. Today is perfect time to level up our game. If you are interested, you can find the enrollment link in the video description and comment section of this video when it will be uploaded like this. We are excited to announce that free Kubernetes certification training sessions will be begin soon. Feel free to enroll and share this opportunity with others who might get benefit from it. We also want to extend our sincere gratitude to each and every one of you for your incredible support and encouragement. It truly inspires us to continue providing valuable training opportunities. Big thank you for that. These are our social media handles. We would love to stay in touch with you. As you know, day 7 is divided into 3 sections. In this section, we covered fundamentals of Kubernetes, including its architecture components in great details. If you would like to refresh your concept, feel free. So today we will cover Kubernetes deep dive, and in this we will focus on everything as a DevOps engineer or Kubernetes engineer needs to know about Kubernetes. Here we will explore all the important Kubernetes objects. We will start with setting up our on single as well as the multi-node cluster. Then we will see the nodes. Okay, to understand this concept of the node is really important when you add in when you add a node into a cluster or removing nodes from the cluster. Then we will create the foundation of the Kubernetes, which is the pod, and we will after that we will create a replica set. We will also understand the deployment, stateful sets, daemon sets, and we will understand what and why do we need all these things. Okay, and there are difference, everything will be in action. Then we will create a volume. In this we will understand the different kind of volume, and we will create those as well, and we will also see how we use them and when to use them. In this, these are the really important things when it comes to a storage. We will also learn about the config maps and the secrets, and we will also create a services. And in this we will see several kind of services which are available we can create in the Kubernetes. So like headless service, ClusterIP, NodePort, load balancers. Of yes, the load balancer, we will see the load balancer, how we can create a load balancer on this local system. We really don't need any cloud setup to understand this concept. Yeah, we will see that. We will also understand about the ingress, and we will also learn how we can manage our or organize our workload using the namespace. Please note that these are not components but the objects that create and manage in Kubernetes. I have selected this based on my own several years of real world experience. These are essential for DevOps as well as Kubernetes engineer. Okay, and beyond YAML files, we will also explore how to create a Kubernetes resources using imperative command as an important skills for the CKAD certification. And finally, we will wrap up our session with a real world project. We will deploy a full application using all these technologies. Okay, this hands-on project will give you a clear understanding of how Kubernetes operates when handling multiple applications. The project includes database in-memory, database, Python, Node.js, and more. So let's dive right into the deep dive section. As we have covered a lot today, so let's get started. Fire up the terminal and build our Kubernetes cluster. All right, so we are at terminal and we are going to spin up our cluster. And for that, let's head over to the Minikube website. Before that, I would like to mention over here all the steps which we are gonna cover today and the resources we are going to create. I will upload it in a better version. All this in this repository. This is our official GitHub page, and inside that we have this public repository, Certified DevOps Engineer free live training program. So inside that there would be a one folder Kubernetes, and I will upload all these resources, steps, whatever you will be seeing in this session will be uploaded over here. So if you want to, or if you want to follow along, make sure to use those resources. So first thing first, what Minikube is. So Minikube is a lightweight. Minikube is a lightweight tool designed to run Kubernetes cluster locally on your machine. Okay, it's especially useful for when you are testing or doing learning, and it's very useful for the development environment as well. Okay, it's a fantastic way to get hands-on experience with the Kubernetes, its simplified setup. Okay, and honestly, I mean, you probably heard it or maybe find it. It's a, and here also said it's just for the local Kubernetes setup, right? But I use this Minikube in full flash in development environment, okay, and save lots of money of the company. So instead of giving a bill to your manager, okay, if you do not have a lot of workload, you may use a Minikube, okay, and instead of giving a bill or invoice or the cloud, you could save, okay, I have saved this much of money. Anyways, that's a fun fact. I use that, and that's why I told you. So I will also show you how you can use it in full flash. Okay, let's go ahead and see how we can install it. So in order to install, let's first see. It says you need 2 CPUs, okay, or more. It's better. 2 GB of memory and 20 GB of read space internal, and yeah, more other information. And you can see over here, I have accessed this, and but in your case, when you're installing, it is really important to have or get very good experience with the tool, okay, that works seamlessly for you. So how we can check the operating system and architecture? So very simply, we could there is a command we learn in our day 1 Linux for DevOps, right? So here, this is the command by which you can see, of course, Ubuntu, and most of the cases we know what we are, but in case we don't know on which Linux server, maybe you are not maintaining in your company, or there is a dedicated Linux team, you don't know, then you can just execute this command. Additionally, there is one more command, okay, uname dash, and this command give you what kind of processor you are using. So x86 underscore 64. So M is over here, release type is stable, and here there are 2 ways. So Debian package, if you want to install using Debian package, go ahead and do with this. RPM, if you're on Red Hat or FrontOS or Oracle Linux or similar system, use this one. So it's your choice. I'm fine with that. Anything, this most of the Linux distribution, this command is generally work. So I'm gonna copy this first command and execute over here. So let me clear my screen first. I will copy it over here. Let's see what happened. And it is going to, yeah, it is going to download this file. This file is very big. Let's touch LRD, and which file it is going to download? Minikube. Okay, this one. So if I run this one, so you could see simply this file is downloaded right now. Okay. Second, in this step, what we are going to do, it says sudo install, and in order to install, there are some of the steps. Let me quickly explain you. So it's simply this file. It is going to move this in user local share bin Minikube. So if I let me hold down it like this. If I say LRD, and if we go over here, okay, so we do not have anything. So let's go ahead and install. Delete, and it will also remove if you want to keep it, if you are doing practice, right? So instead of downloading it again, just remove this part, okay, and play around it. So I'm fine, I'm gonna remove it. And now if I execute this command again, you could see I found a Minikube. Okay, so this long file, right, it installed, it rename as well, right, as a Minikube. And now in that point our installation is complete, right? So now it says start your clusters. So to start your cluster, it says Minikube start. Very simple, Minikube start. Let's see what happened. So Minikube start 1.35 on 35 on Ubuntu 24, right? Automatically selected the Virtualbox driver. Well, we'll talk about this. What about the driver thing is other choices, none as such, downloading VM boot images, and it's, yeah, it's pretty much, yeah, my internet is good. It looks good. It's working. Yeah, very good internet provider. And yeah, I would like to mention one thing in part 1. In overexcitement, I mentioned Kubernetes version 1.35. Of course, that will come, but I meant to 1.32, and I mix that with the Minikube version 1.35. So Minikube version we are using is 1.35, and Kubernetes version is 1.32. So sorry about that, but yeah, I was really excited about the Kubernetes and looking forward to 1.35 version as well, with lots of new features in that. So it says creating virtual machines, and virtual machine VM CPUs too, memories like this, and disk is 20,000 MBs. So let's give it some time, and once it is done, I will tell you what the driver means. So basically, okay, now it's a good time. It says selected the VirtualBox as a driver. So on my system, the VirtualBox is already installed. Okay, if you are using any server, right? So yeah, it was very fast, right? So if you are using on server version, so simply install a VirtualBox. Okay, so it supports two kind of drivers. So driver, let me go ahead and show you my virtual machine, which is over here. Now it's not virtual machine, it's my another machine. So in order to show you, I'm not using virtual machine for this demonstration. I'm using my machine where I install, and I'm using Kubuntu operating system. And you could see here the Minikube, right? So by default it says, yeah, over here. So processor, it's if you see the configuration, right, it says, maybe let's go ahead and see like this, and system and motherboard, sorry, yeah, you could see over here it is using processor 2, and by default it is selected like this, and memory and all this, right? So that's how you create a cluster. So this is one of the driver. Okay, this is one of the way it needs something in background. So when we said Minikube start, and by default, so VirtualBox was there, it automatically find VirtualBox driver and uses that. Okay, so other choices is also mentioning, and you could also see downloading VM boot image, and you could read about it. So now is the thing how we can interact with the, or how we can check with the cluster, right, whether it is spin up or not. So Minikube, and simply say status. So you could see host running, kubelet running. Of course you can also see, so it's a GUI, that's why I'm able to show you over here, but by the command you can check like this. So now our cluster is running. So there are other ways, like it's mentioned, kubectl is now configured to use Minikube cluster. Okay, and there are other ways you can interact with the Minikube kubectl or something, but I would like to show you something different which is applicable to interact with any of the cluster regardless where it is. Okay, and that is, so we will come back on this page and see more options, but before that we need to install kubectl, right? So I will post all this link, and you can, but of course you can also find it on the internet, no big deal, right? So installing a setup, kubectl on Linux. So kubectl we already saw in our part 1. There are several ways to interact with the Kubernetes cluster, right? But kubectl is one of the way we need to interact with the cluster, which is really powerful. Of course other ways are also powerful, but most of the time, or almost always, you are going to interact with your cluster using this utility. So this utility is not just for the Minikube. Regardless wherever your cluster is, you can use this kubectl utility to interact with your any of the cluster. Okay, so let's begin. So here we have something like this, installing kubectl on Linux. So we have package management, using other package management, but I will go ahead and use this, and I will also recommend you, so because these are generalized for most of the distribution. Okay, and we already checked our processor type, right? If you have like this, or maybe you're on Mac or other machines, use this one. I'm on this one. We already checked this, so I will copy this entire string like this. Okay, so, and then I will paste it over here. So again, it's the same thing, right? It is downloading, and that is released like this, and this can, right? So we got something ls-lrt, and we got kubectl, and which is over in my current directory, right? Kubectl. Now next step, it says validate the binary. All right, so validate the binary. It's really good practice to do that, because here these are the values, right? SHA values. If you see, validate the kubectl binary against the checksum file. So please make this here as a practice. Okay, whenever you install, and if you have option, right, use this thing, or use this utilities, right? Validate the binaries. Okay, whether, though it's optional, but it's a good practice in which you know, okay, your file, sorry, so that is a syntax error. What syntax error I'm at? Yeah, sorry, I didn't copy entire command. So it is a good practice. In that way you can confirm your file is not tampered, not harmed, or not manipulated in between. So whatever, so you will get the safe file. It's more on security practice. Okay, so do that, and after that, let's see if we get kubectl. Okay, yes, we got the kubectl. Okay, it means the utility, the file which we have downloaded, it's safe. It is not tampered. There is no man in the middle who do some shady things. Okay, so we got, it's fine. Now the next thing, what we have to do, so install kubectl. So it's a sudo install -o. So it's a simply a root group, and this, and yeah, we learned this in our again Linux day one, but we are not going to do that. Most of the time we do not have a root access on the Linux server in our company, or most of the time in the organization there are there is a dedicated team who maintains, right, the Linux servers. So here we have note, if you do not have root access on the target system, you can still install kubectl in .local bin. Okay, of course, it's your preference, but in my experience so far on Linux system, we really did not have root access. So this was a perfect way to use kubectl. Okay, until unless you are not Kubernetes administrator. But yeah, we will talk about this more in our CK training, how you can configure the utility so every user can use it. But let's go ahead and use this one, right? So it says, yeah, so let me copy this. So these are the three-step process. One, in this we are changing the permission, then we are creating a .bin local bin, and then moving this. Okay, let me first clear my screen. All right, as it's a three-step procedure, okay, and here it says if you do not have root access on the target system, you can still install kubectl to here, that is your local bin. Okay, so let's do it one by one. So in this, first we are going to change the permission, executable permission. If you don't do this, okay, then you are not able to execute this command at all. You will get permission a denied error. Okay, that's permission and all these things we have already talked in our Linux day one part. Okay, next say mkdir-p, and I really do not have to explain you what this -p means, but still I'll explain. We already discussed in very detail. So this will create this directory if it is not there, and if it is there, still it will make sure, okay, to have it. So I mean, it will not give you the error, the directory is exists. Next we have to move in kubectl to this path. Okay, so let's do this, and now we have moved kubectl, and we should be able to use this kubectl command. Let's run the command kubectl, and it says command kubectl not found. Okay, so what's the reason over here why we are not able to execute this command? So if we come over here, you could see, and then append or prepend this to path. Okay, so we have to set this in our environment variable. Okay, so very simple thing. So for that I will open a file. Okay, and file is our vim.bashrc, and in that I will go, I mean it's already at the end, but if not, press shift and gg, you will go at the end, press open, then it will be directly entered into the edit mode, right? Then what we have to do, we have to export. We already talked again in our Linux day one, right, how we can set the path. So export path equals to, okay, and this one, let's copy this, put it over here. We already in inserted mode, export path, this one, and we have to put like this, okay, $path. So that's why it's a add append or prepend. Okay, so that's why, so those other paths should not be disturbed, right? So we have export path. If you see over here, export, this is the variable path equals to this sign, okay, dot local bin and the path. Let's do this. Okay, and now I put like local bin and kubectl. So you can see I can execute this command, but in this case we are not able to. And we really don't want to execute command like this. That's why we have set the environment variable, but it is not affected. So either you do log out, right? Or we in Linux we have luxury, right? And the luxury source dot bash rc bash r and c. Okay, so now it is done. Let's check if we can access kubectl or not. Okay, so everything is set. So kubectl, you could see I'm not getting any of the things. Okay, so ideally, yes, you are done with kubectl. If I run this command kubectl cluster info, and you could see I'm connected with the cluster, right? And here you could see kubectl get nodes, and we know we have only one node, and the which is over here. But I would say go ahead and do one more thing over here. If you don't want to go ahead and do more stuff, that's fine. You can use kubectl in this way, but there's further steps over here, right, which help you, especially when you are starting, right? And what is that? Though it's optional, kubectl configuration and plugins, right? So how you can check bash? Very simple. Go $shell, and I know I'm using bash, right? And here there is a, yeah, you can see install bash completion. So bash completion will help you, especially you're starting. So this will help you to know what are the other option Kubernetes commands. Okay, so go ahead and do that if you want to. I like this way because it is helpful. Okay, especially when you are starting. Sudo apt-get install bash. Fine, go ahead and do that. We are okay. We trust our repository. Okay, so, and if you are on other system, you have this one, accept, right? After that, what you have to do, you have to enable queue auto completion. It is not going to installation. It doesn't mean you can use the auto completion, right? So for that, user, you also have system wide option. If you want to do that, go ahead and do that. I'm going to do user wide echo source and copy this one. Again, we are going to do this. Okay, so what happened over here? Let's see in the bash. Okay, so at the end, these things are added for us. Okay, which we just echo. So we know echo it means and how we can, and these are appending, these are not overwriting. So be careful when you are doing something like this redirection. Okay, so it's over here, and of course I did not make any changes. I'm gonna quit it, clear screen, source dot bash rc, and we are done. Okay, now if I run like kubectl that, so you could see like this, I'm getting more information. I say pods, so it is giving me what are the pod and what you want to do next. Okay, we will use, so that's how auto completion is work. Okay, and you could also realize k is also working, right? So which is, we created alias is also in our with this command. Okay, but I will suggest you in starting use kubectl and try to type it, or use auto completion for that. Don't use k, your choice, whatever you want to do. Okay, so for me, kubectl get nodes, and I'm done with a single node cluster. Okay, and kubectl at not net, so cluster info, and you could like this. And you can also use one of the option kubectl get node dash wide, and you could see more details over here. Okay, so this is about setting up a single node cluster. And so of course I told you, I mentioned initially, we are not going to see only one node cluster, right? So what I will do, I will remove this one, kubectl get nodes, I mean this minikube, right? And to delete your cluster, what you have option, if you go all the way back over here, okay, minikube delete all. If you want to delete all cluster, I do not have all the cluster, I have only one cluster, so maybe like this. And if I say minikube delete, so it knows there is one cluster which is created by default, right? And now if I say kubectl cluster info, so you see we are getting error API server API list get in all these things, so because there is no cluster. So, and if we go over here, you could see there is no further virtual machine at all, right? So this time what we are going to do, we are going to create or spin up our cluster. Okay, so in order to create a cluster, the commands which you have to create, not to create, which you have to execute is simple minikube start. Okay, and I don't want a name of the cluster. I want to give a name to a cluster what I want. Okay, so there is an option of profile, right? So I could say piece of tree and nodes 4, and here this time I'm gonna use driver equals to Docker. Let's see what happens. And it says using Docker driver based on user configuration, exiting this, and install Docker. So Docker is not installed on my system. So what can I do? I can install a Docker. In order to install a Docker, I have command simply sudo apt update -y, and after that sudo apt install docker.io. Okay, I'm fine with that. Let's go ahead and see. It is going to update, and after that it is going to install Docker for us. Okay, all right, so now Docker is installed, and we know we done already in our day 6 after installing the Docker. We have to make some changes, right? We talk already in very detailed, so go ahead and refresh if you want to. So user mode A and G, capital G, don't use always this together. Okay, Docker and dollar user. So user not mode, I'm sorry about that. So user mode, yeah, like this. And in order to effect or apply this things, right, we have a command new grp and Docker, and we are done with that. Okay, so I don't need to run the Docker version command, that's written already, and now our Docker is there. Now I have to, or I want to install or spin up the cluster. So I simply again copy paste the command. Where was it? Here we go. So this one, clear the screen, put Minikube start profile, DevSecOps 3, Node 4, driver Docker. Let's see what happens. So you could see it now. It's started or using, because driver is successfully installed, and using Docker driver with root privileges. Okay, we're testing. We can already seen how we can configure Docker without root privilege as well. Go ahead and check out the documentation if you want to. It's a starting DSOC3 primary control plane. Node is DSOC3 cluster, pulling this pass image, and this time it is pulling a image. Right before it was pulling a virtual disk image. Okay, and creating Docker container with 2 CPUs and this memory, and before it was more, and preparing 1.32, configuring CNI, starting this SOC3 machine 2 worker node. Okay, and so now it's a spinning up on worker 2 node, worker 3 node, and using its version, pulling image, proxy, all these things it is going to do for us. So let's give it a time. All right, so our cluster is run, and how we can check it. So of course we already installed kubectl. So kubectl, let's first check whether we are connected with the cluster or not. We are connected. Okay, and in order to check the nodes, okay, kubectl get nodes or node, all fine, and you could see uh, here DSOC3. Okay, that's what I given a profile. So profile, like if you create a different cluster, so you could, instead of giving this name, or you could say test or dev or whatever, so it will create more cluster for you. And how you can check this, minikube dash minikube, sorry, profile. Yeah, so when we create it, when you say minikube start, so by default it takes as a minikube your default profile. Okay, and yeah, so on and so forth. But here like when I execute this command, kubectl nodes all fine, right? It understand. So here it says role, so it's a control plane, and these are our worker node. So in order to set a role, we have command. It's better to, of course you could do it, but I want to give it a name. So I have a command kubectl label, and I told you the labels are really important in Kubernetes, right? So I will say DSOC3 this node, and I want to give it a role like node dash role dot Kubernetes dot io and slash worker equals to worker. So kubectl label node DSOC3 M02 is our name of the this one. Okay, then node dash role dot Kubernetes dot io. That, yeah, that's very used to it. I know. Knew I made some mistakes somewhere, especially type. So worker WORKER equals to WORKER. That's fine. But before I execute, I would like to show you one thing. So kubectl, right? Describe node. So if I copy this and paste it over here, you could see maybe let's do one thing. SSH. So these are three and okay, address. Okay, so we are over here. Let's go ahead and do like this. So, or maybe it's fine. This command, right? We can copy this over here and see. So here in this, if you see the labels, yeah. So you could see Kubernetes.io. We do not have any labels. So maybe let me filter out the output more. Grab labels. Yeah, that's fine. Clear. And we want to see after. Let's say 10. Okay. Yeah, fine. So just to show you what happened when we change the label, and labels are really important, right? So this is our command. I executed this one, and now let's see what happened. So kubernetes.io, and we should be seeing somewhere worker. Yeah, here node role, right? It is changed to worker, right? Similarly, let's do it for more, or not more, for others as well. So machine 3 and machine 4, right? And so let's go back over here, and this time if we run kubectl get nodes, so now our cluster is fine with one control plane and 3 worker nodes. Okay, and simply we can use this command if you want to get command whites kubectl get nodes. Okay, so you will get more information, and these are the other details as well. What important over here is the internal IP 2345. Okay, so this is our control plane which is running over here. This is our workup, which is which IP is this IP is this, and IP is this. Okay, so very simple. This is how we set up a cluster. So in so far we have created a cluster, we have installed the kubectl utility, we installed the bash complete auto completion, right? We saw how we can see the nodes, and additionally if you are adding up the nodes, so when you say kubectl get nodes, right, and if they are not, or if you want to see what's happening with the nodes, so simply describe. So kubectl describe, let's say this node. Okay, so here all these events where you will get the more information what is happening for this particular, if something is not happening properly or not working properly, or if you want to troubleshoot or something like that. Okay, and now you could see the kube proxy, kubelet, and yeah, node controller is also registered, right? And similarly, if we see get nodes, and let me describe this simply softly. So here you could see kube proxy, kubelet, new controller, and yeah, starting kubelet. But yeah, go ahead and see like this. Okay, so this is how we set up a cluster. Next topic we are going to see is the Kubernetes pods. All right, so our next topic is to creating a pod. Right, before creating a pod, let's see what pods do we have already in the cluster. So to see the pods, we already know this command, kubectl get pods, no resource found in default namespace. Okay, so there is, we will talk about the what are the namespaces means. That is also one of the object, full fresh object in the Kubernetes which we can create inside the cluster. But there we have another command, kubectl, not kubectl get pods dash dash all name, right? All name spaces. Is the spelling correct? Kubectl get pods dash dash all name spaces, right? So when I run like this, so here we could see some output, and these are some outputs. You could see the namespace is already here in kube system, right? So this is the namespace, and we get the pod, and we got all these pods, right? So we have DNS, etcd, right, kinnet, and we also have API server, controller manager, the proxy, and yeah, scheduler, all these things. So these are the pod, and this is the kube system, the namespace where all this component or the required component for us to run or function the cluster, those are already created like when we spin up the Minikube cluster. Okay, so these are the important or main components which you see. So don't ever go in this namespace and touch any of the things until and unless you know what you are doing, right? So that's how we can see the pod, right? We can also see other details as well. kubectl get all, so you could see, and if I say dash a, so dash a is also one of the option. Instead of typing this long dash dash all namespaces, you can just type dash a. It's a kind of shortcut. Yeah, so you could see services here. We also have services. We also got the DaemonSet, right? Deployments, replicas, and all these things which we are going to create shortly, right? So that's how these are the initially when you do not have any workload, when you set up a cluster, you have all this information. So make yourself familiar with this. These are your interview questions when you do not have any workload, or maybe you will be asked when you set up a cluster, what are the components or how do you see the components, right? So and how it is being created. So everything is created inside the Kubernetes cluster is the in the pod, right? You have this default namespace, this is the service, right? kubedns is also one of the service which is created, right? DaemonSet is also created. Kube proxy is also as a DaemonSet. We are coming on that and see why, what is DaemonSet and what is deployment. But I would say make yourself familiar, make yourself with the ports, and that will help you to answer in interview if the question will be asked. Okay, let me clear the screen, and now we need to create a pod. So in order to create a pod, we can create objects in two-way in Kubernetes that we already talking our previous part one, right? So one way is to imperative way. Imperative ways are good, okay, especially when you're writing CKD exam. So it's really good to have very good understanding, good grip on that imperative command. That will save your lot of time. Okay, so in order to create a pod, kubectl get pod. So at the moment in default namespace we do not have any pod, so I will say like this, kubectl run my first first for pod. Okay, and image equals to nginx. So this command looks very similar when we learn this the containerization, right? How we can create our own container. But in Kubernetes, we don't create containers, we create pod, and inside the pod is container is created, right? So let's go ahead and execute this command and see whether it is going to work or not. So let me a little bit zoom. I think this is enough. So we do not have to make a zoom again and again. So kubectl, now if I run this command kubectl pods or kubectl pod, you could see my pod is running at 16 seconds, just before the 16 second. Okay, now if I run command kubectl describe pod simple po, and I copy paste this name, and we have so many information over here, right? And what so many information? So of course, this is name of the pod, and namespace is default one, which we are working on. Okay, service account is default, and node is tsoc3 m3, right? And start time is this. Label is run my first. Annotation is nothing. Here, you can find the information about the containers. We will also create a multi-container pod shortly, and after that, here you have more information. Which image are you using? Right, and we know if we don't provide any tag, it means it is the latest one, considered as a latest one. Okay, then we have conditions. So yeah, initialize ready, container ready, pod schedule, and all this true. Then volumes, API access, and yeah, there are so many things over here. But important thing to note as initially, and here, so successfully assigned default my first port to tsoc3, this one. So you could see default scheduler. So we know, we already talked in our part 1 of day 7, right? What scheduler does. So this is a job to assign, right? To schedule the port to a available node, right? Which is done. Then some of the things, kubelet. So of course, kubelet is the agent which runs on the worker node, and here we could see, okay, and CRI is also that instruct, and then follow the kubelet instruction. But it says successfully pull this image and created container. If anything goes wrong, you could see in the events. Okay, we'll simulate that scenario. Okay, so this is how we create. Okay, so this is one of the way. Second way, this is with the command. So that's why in part 1 I told you why I put, or I gave a name, my second container, right? Not container, my second pod, right? So for that I have created already YAML files. So let's go ahead inside that and pods and use those, right? So let's first understand. And now we are going to learn about the declarative. So declarative and imperative is simply, or I would simply say, okay, you can create pod with the commands. You can create pod writing a YAML files. Okay, so declarative, it means you are writing YAML file where you are um, declaring, right? Okay, this is it's kind of declaring, it means you're declaring you will, like that. So my second pod, okay, this is the YAML. And if you see, okay, that is also we talk in any of the YAML, we have 4 mandatory items. First thing is API version. Second is kind. It's what we are going to, what object we want from the Kubernetes. So we are informing Kubernetes, I want pod. That's why we have mentioned, I mentioned over here the pod. Then we have metadata, where we provide a name and the labels. Then this is a specification, and here the containers information. And you could see this is containers, right? Because we, in this section, we specify many containers, as many as we want. But ideally, until and unless it is really necessary, run one, I mean specify one container in one pod. Okay, I have given a my second pod container, and image is again nginx, and the container port is, and again if you see the ports, it means here in this field we can define multiple ports as well. So all these things we already learned in part 1. We talk about the YAMLs basics thing. It did not make any of the changes, right? I will, so that's why I'm quitting it. I will provide this YAML in the repository after making annotation in that. So in order to create, right, so we have command kubectl and see its autocompletion, kubectl create -f, and file name is my second pod.yaml, and it says pod my second is created. If I execute, kubectl get pods, and now you can see before I had first pod, now I have second, and I want to see, okay, that we will see later. And of course, if we describe this pod, so we get the same kind of output where name and labels, all these things. But let's go ahead and see that kubectl describe pod, or I could also say simply po, that also works. And the same information we have over here, right? So name, namespace, priority, service account, notice, start time, labels, annotations, IP, container details. Again, my second pod container, right? That's why I given it the name. And these are the conditions, these are the volumes. We will also see later today what volume means. Then we have node selectors and toleration. These are again advanced topic, which is at the moment out of the scope. Otherwise, this is gonna we are learning forever. But that we will see in CKID certification training when you start. And again, the same events, and you could see successfully assigned this to this three and this one. And yeah, it's pull the image, it's pull this image, and in this second created a container, start with container, and our container is ready. Get kubectl get pods, right? And yeah, so this is how we create a container using a YAML file. Now I would like to show you how we can create multi-container pods. So my third multi-container pod YAML file. Let's open this. So it's everything is same. API version, kind is pod. We are going to create a pod, and P is capital. Okay, caps and caps. Metadata name, I did not select any of the label. That's fine. Then we have specification in container section. Container section. We have two container, right? And here we have one container which is Nginx, and second is a sidecar container. Sidecar container. Okay, so basically this container, inside one pod we are creating a two containers, and I told you last time these are array, okay, and we put in a sequence. And for you, the assignment or the exercise, make changes of this pod, okay, and some of the commands which I'm gonna tell you, then execute those commands, so you will understand between why and where we need to use array, where we used to need map or dictionary, okay, or map. Okay, so this is how we define. So in container section, I have defined first container, nothing special, just put nginx code. Here the same thing, okay, but here I have put a command that's we already learned in our when we learn the container, right? Day 6, how we can do in the executive command. But here command, it means when inside the container in Kubernetes we write. So basically it's a one-liner shell script, nothing else, right? So we are executing this command. So shell, it's a kind of course we know the shell, it's a command, right? We discuss in the container, but still it's a one-liner script, right? We are executing inside this, and we are using image which is busybox, right? So it's echo, it sleeps for 5 seconds, okay, and again back up, and while true, so of course it's a forever true, right? And again it's echo, hello from sidecar container, I'm alive. Then again let's go to goes to sleep and do the same stuff. So let's create. So nothing special in the YAML except you have to mention additional container configuration in this spec section, right? Let me exit it. Kubectl create dash f, right? And I said my third multi-container, and it is created. And now we know the command kubectl get pods, right? And now we could see, and there is one more option if we continue on to see what is happening. So it says container creating, and now it says running. So okay, when you're doing something, right? So and if you want to watch continuously what is happening, so you use -w flag along with the command. Okay, I use this to show you. So when I executed this command, it says container creating, and after that it says running. And if you notice the difference over here, it says ready 1-1, and here it says 2-2, right? So this is again an interview question I mentioned in part 1 as well, right? What does this mean, ready 2-2? So it means in your pod you are running two containers, right? And here when it says 0 of 2, it means no container was ready out of 2, and here it says 2 of 2 of 2 containers are ready. So until and unless your containers are not ready, your pod will not showing a running status. Okay, so let's describe this and see. Let me remove this. Here we go. Kubectl describe pod. And here, if we see the logs, better to see like this, not logs, the events. So first we see that what I talked before in container section. Okay, you can see the nginx container, sidecar container, and here you get the port information, right? And here, especially in this section, right, that's how it works. Command sh-c while true do echo hello from sidecar container, right? And here, if you see, successfully assign this to machine 4, right? And or I would say that this is the name of the node 4, and here it's pull in, okay, pulling image. So of course image is already there. It's created container, okay, started container, that it's put image for busybox, then it's create and it started container, and after that your pod came into the running status. Okay, there is one more thing I would like to show you over here. Yeah, so you could see the status, okay, while something happening with your pod. Okay, so here you can see the status of your pod, what is happening. Of course, if there, when you execute a command kubectl get pod and it says 0-2 or 1-2 or what, so you know which container you have to go and see the status. Okay, in events you will find the information about that, but if you did not find anything, then what will you do? You have command kubectl logs, right, and simply read. So my third multi-container pod. So why not, let's edit this. Now we copy the pod name and kubectl logs, right, like this. So here it's, of course, it's an nginx server, and you could see the logs of this one, right? So but I created two pods, sorry, two containers inside the pod. I want to see a specific pod of one of the containers. So then how would I do? So to do that, we have a command, and how we can do that. Okay, so simply we use the same command like this, and after that we have to we have to say -c. Okay, it means which container. So I want to know sidecar container. Okay, kubectl logs and this one. But I want to see something else. So logs, I want to follow thread. So you could see hello from sidecar container. It print this message and keep on going in a sleep state. Okay, and again it is going to go. That's how you can see a log. Okay, so when you do not provide, okay, anything, so multi-container pod, so we got this one, right? And if we want to see a specific container pod logs, so in that way we have to provide a name like this. So kubectl logs, this is the name of the pod, right? This is the name of the container, and that's how we see the name of the container. I mean, not the name of the container, logs of the container, right? This is one way we can see the logs, right? Now I see Control C and kubectl. One more thing I would like to show you over here. So what is kubectl? That pods. Okay, so we want to see where our containers, I mean, our pods are running. So when you execute this command, white, I mean, -o means output, and we want a white output. So this first and second, these are the pods which schedule on this node. Okay, which is, and this one is scheduled on this node, machine 4, right? So that's how you can identify where your pods are scheduled. Okay, so this is about the pod, and if you want to access the pods, okay, so we will see that later. But one more thing I would like to show you in box. Yeah, so kubectl will come on that later. So that's all about the pods, how we can create a pod, how we can see the events, how we can describe, okay, and another thing, how we can create multi-pod containers, okay. And I told you in this one, Vim I third, right? So when I share with you, so change this position, okay, first to put the sidecar container above, then nginx is below, and execute the command logs and see what happened, okay. So one thing I already told you, when you do not provide, okay, any of the container name, then by default it gives you the output or logs of the nginx container, okay. And when you provide the container name, then it will give you the specific container logs, right? So that's a part on the that's it on the pods. So here one more thing I would like to show you, kubectl get pods. Yeah, another thing on this, we have seen how we can create a pod. Now we see how we can delete a pod. So similarly, you can create a pod. So the second pod we created with the file, right? So kubectl delete pod, okay. And which pod? First pod we want to delete, and the pod is deleted, okay. When you are preparing for security exam, okay, just use dash force to make it faster deletion, okay. Another way to delete a pod, kubectl delete dash f my second pod.ym, okay. So you can also simply create like this, or when you use delete dash for your file name, all the things, okay. So that's why it is very handy, right, and very useful when you have something file, okay. It's just I guess 14 15 line, maybe yeah, 14 15 lines, right. So when you have very big configuration file, so or when you have multiple objects, okay, you mention in one file, then simply you do not have to worry, simply delete dash app and the file name, and all the resources will be deleted automatically. You do not have to go ahead and see delete one by one, okay. So this is how we do the delete, right. And of course you can also delete a pod, kubectl delete pod, this third, right, which we created with the file, but using imperative you can delete it, no problem at all. So it will take time, right. That's why I said use the when you are in hurry, but that will not the graceful shutdown, but when you know what you're doing and you want faster output, simply use the force option. So it is deleted, and let me do one thing. Okay, so now we have seen so far everything about the pods, not everything, but just to get started. But yeah, most of the things which you should know, right? So as we saw, there is a limitation with the pod, right? I have to create first my first pod, my second pod, my third pod, though the same images, but I have to do it manually. If I want to scale, there is no scaling option available with this. And when I deleted a pod, right, if you see like this kubectl, and the pod is already gone, it is not recreated automatically. So these were the challenges. So self-healing and scaling was the problem, right? And of course you have to do manual management. So for that we have ReplicaSet. So now that is our next topic. We are going to create ReplicaSet, okay. All right, so now let's see the features of ReplicaSet. So of course now we already talked this in our part one, right, but there are some limitations. So limitations are manual management of the pod, right, self-healing, and auto scaling. There are other features as well, but these are the most important one which we are gonna see now. So in order to see those features, let's first create a replica set, and before that we will see what do we have in the cluster. kubectl get all, we know this command, right? So we do not have anything in the cluster, but if still we know this is also one of the command to check whether we have any replica set or not. So no resources found in default namespace. Okay, so let's first create a replica set. Okay, so before that, here we have one file, or let's go ahead and make a set. Let me clear the screen. All right, so here let me open the file first and explain you before creating our first replica set. Okay, so this is the YAML file. Okay, YAML syntax and everything we have discussed in very detail in part 1, but still let me quickly walk you through, and also we will see all the important thing in action again. So again, we know API version. Well, first item, second item is kind, where we define replica set. Yes, that's what we want. In metadata, we can define many other things as well, but we are fine with the name, my first replica set. Here is the specification, that is the fourth item. And in this, right, in this we have replicas. So replicas means simply we are saying how many number of copies of we want to run. Okay, so here we want one, so copy of the pods. So replicas, it means how many pods we want. So we are telling replica set we want only one pod at the moment, so create and maintain one pod. Okay, we will come on this very shortly. Then we have template. Okay, here whatever we have written in our pod file, okay, everything we have put in over here. Let me quickly show you. It dash dash pod, my second pod. Okay, so if you see the from up to here, metadata, right? So metadata, name, label, labels, right? And container name is this, except here I have put this thing, okay, additionally. So this is, okay, this app, my second pod, and this one. So whatever you mention in selector, it must be appear over here. Okay, otherwise replica set will not able to identify which pod it has to manage. It's a short answer. We will go more deeper into, and we will see actually in the action how this selector mesh labels work. Okay, so let's first create the replica set, and for that I'll go to my terminal and cd is replica set, yeah, kubectl create -f. Okay, and we have already this file, my first replica set. All right, so our replica set is created. We know now the command kubectl get replica set, and we can see the replica set kubectl and get pods. And now we know we have this pod. Okay, and in part 1 we discussed, okay, replica set manages the pod. So let's see one by one, this one and this one, right? So first let me describe kubectl describe. Okay, this command is useful if you want to see what do you have in the configuration. Okay, and also you could see the image events when you are creating like pod or replica set, so you can check if your pod is not coming up. Okay, if you are creating pod via replica set. Okay, so kubectl describe, and I have given this name, my replica set. Oh, sorry, I forgot to put one thing. kubectl get, not get, kubectl describe replica set. Okay, so we have to mention what we want from the what we want to describe. So we want to describe, right? So this is our object replica set, and here if we see my first replica set default, and here is the selector, right? And there is no label, so this is intentionally, will come on that why it is not here. And annotation replicas, you could see one current, one desire, right? So desire, it means whatever we have defined in the YAML file. Okay, and here the pod status. Okay, here pod status is completely different. It says running, waiting, succeeded, and failed. Okay, and pod template. So now whatever we had mentioned in the pod, okay, all three labels we have mentioned, which are over here. You could see these are the labels, and container is the name, image, and here out of this we already discussed this, right? Node selector, it's okay. Volume none, 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 all good. That's okay. But here the thing, if you see normal, I mean type is normal, but in message you could, and then the from, right, 17 seconds ago, replica set controller. Okay, so this event is, or this message is from replica set controller, and it created a pod, my first replica set, this one. Okay, so remember always, I mean, when you create a replica set, so replica set automatically create a pod for you. Okay, now let's describe the pod first and we see what happens. I'm clear and kubectl describe pod, and this is my pod. And now we see, compare it one along the way, side by side. Okay, quickly. So of course, this is the name, right? Default name is a service account is default. Okay, this is the time and date it is created. Level, again the same thing, you can see right here the level is this one. Okay, and second, next thing here, okay, this is about the annotation. We do not have anything in annotation, and if you see over here, control here, controlled by replica set, this one, and that's why in the name, okay, in any pod name, prefix is like my first replica set. So that's how it knows, okay, which this pod belongs to, or this pods belong to which replica set. Okay, so this is the one of the way, that's how it is made, or it is already mentioned in over here. You can also grab this and find which pod is it managed by which one. Okay, next in this, okay, here if you see in the event, and you could see successfully assigned, and here we have default scheduler, and we know that scheduler is the task of the scheduler, right, to assign pods to a node, and in this case it is assigned to this node. Okay, this of 3 machine 4. Okay, and these are some of the other events, so we do not have any of the error, right? So it means our pod is working perfectly fine, right? So let me come back on this screen. Okay, and now so this is how we create the replica set. All right, so now first let's see scaling, then we will talk about the scaling factor. Okay, so in order to show you the scaling, okay, there are two ways. Either I could create it via scaling up and down via the command. Okay, but let's go ahead and do it on very simple way, which because our file is already open, right? So over here, so let's create a replica equals to 10, and I'm not exiting from the file. Okay, we will see more stuff soon. Okay, so I have changed the replicas to count to the 10. Okay, let's go ahead over here and let me open that again and clear it. kubectl, right? So at the moment we have only one pod, so I just put a watch, so we would be able to see what happened when we make some changes over here, right? So let me clear this screen, then kubectl create. Okay, that was the command we use, kubectl create, and we have made changes to number of replicas. It means number of desire, right? Desire thing should be 10. So desire thing here, thing is here the pod, so we should be able to see the number of pods equals to 10. Equals to means number of pods we should be able to see over here. So my first replica set, oh my god, what happened, what I did wrong? So it says error from server already exists. Okay, error when creating my first replica dash set.eml. Okay, replicas this already exists. So by using the create command, okay, you cannot create a same resource again. Either you could delete this replica set and you can create it again, but that's not what we want. So in Kubernetes there is a way to fix this. Okay, so instead of using create, okay, we use, and that is more useful, and that is actually the command we use. Okay, so instead of creating the create, you could also create, like I already showed you how you can create resources using this. But in our case, or in actually production, right, you always use another command. I mean, like, of course it's your choice, but that is more handy, and that's why we have this thing. Okay, so but before that, let me show you one more thing. Yeah, kubectl cat replica set. Yeah, my first, and here we are taking output as a YAML format. So you can see here in this part, metadata, right? We have only this many details. Okay, so now let's see. Let's change this, and we will see what new information we will get over here. Okay, there is no annotation part. So let me kubectl apply dash f my not second first replica set, and now you see. Okay, so not this one. Of course, these are the 10 pods gonna be created right very soon, and all are running. Okay. So let me first move like this, remove the watch flag, and we have 10 replicas of the pods. Okay, all right. But what happened over here? This is we know why, because we already changed the number of replicas over here, right? And we know when we do this, but we were not able to do with the create command, but we are able to do with the apply command. Okay, so here there is a warning. Let's first see this warning, then we'll come back on this screen. It says warning, resource replica set. My first replica set is missing the kubectl kubernetes.io last applied configuration. Okay, last applied configuration was not there, so annotation which is required by kubectl apply. Okay, so when you use kubectl, so let me show you in action instead of just send you like this, right? So you can read this, but I wanted to show you, I would like to show you over here. Okay, so this part, annotation in metadata, this was not there before. If I scroll a little bit up, yeah, in this, right? So sorry, I should have been open it another terminal so we could compare this side by side, but I know now you're not a kid anymore. You can quickly understand, right? So this is in metadata. We did not have anything before, and now in metadata, right, we have this one. Sorry, annotation, right? This was the last configuration. Okay, and we will come on this. What is this very shortly? I mean, not very shortly, but yeah, again. So here you see everything is managed, right? API version, client replica set, metadata, annotation, name, my first replica set, default spec, and replicas are 10, right? Sorry, on this, and here, right? So you can read it is basically the same thing, and that's what it is. It was referring, right? So this one, kubectl dot kubernetes.io last applied configuration. So this is the last applied configuration. Okay, we applied for the 10 pods, and this is happened. So when again I change this again, so now see there is no error at all. It says unchanged. Okay, and how this command is useful in you when you are actually working in production system. So when you create a I mean, this applied to not only replica set, this will be applicable for our further objects we are going to create. Okay, so when in your production system, when you have many YAML files, right, when you are going to create many objects, so whatever objects got any changes, or you made any of the changes in any of the object, so those files, right, those files can be updated accordingly. Rest file is not going to touch at all. Okay, and how it is? So this is because of this annotation. Okay, that's why it says unchanged, right? So now let's see. Let me show you one more thing over here. So again, we put a watch, right? And instead of 10, let's do it like this way, 3. I'm not putting it again, right? And this time I'm gonna apply again. So consider this, you are doing it. Of course, I just It's not CI/CD or pipeline session, right? That we have already saw in very detail in day 5. Yes, there is a dedicated session for that. So, but here I wanted to explain you the concept. You can also execute same command via any of the your automation server. Okay, and you can include this command in automation, and that's why this command is there. So now this you could see before it was saying unchanged, and now it says configured because we change something in the configuration, right? And that's why instead of 3, right, we got how many? I mean, instead of 10, we asked replica set, okay, our desired thing is kubectl get replica set. So before our desire was 10, right? So that's why Kubernetes, not Kubernetes, of course, at the end Kubernetes, but here we are talking about replica set. So replica set manages, I mean, the created or maintained desired state with the current one. And now we change the configuration, and configuration, it means this one. Okay, we change the replicas, and that's how this is work. What is work? Scaling. Okay, that was not possible in the Kubernetes. Okay, and we already talk about this. This is a high level object, right, which is wrapped around the pod, and that's why when I describe it says replication controller created a pod. Okay, and we also saw in a pod description manage managed by, right? So let me cancel this, remove this, and now if we see, we have number of replicas 3. Now what happens some case, just to let's simulate the scenario where self-healing we need. Okay, because of any of the issue your pod got restarted, okay, or crashed or whatever happened. To simulate that, let me delete one of the pod. Kubectl delete and source, not sorry, resource the object. So as replica set promised, okay, it provides the self-healing. So when I delete the pod, okay, we should be having a new pod over here. So let's see. Okay, let me do one thing and we see. So yeah, if you see over here, that's how replica set works. Of course, I will show you over here, but you see, initially, we ask to maintain it to the desired state 3. Then you could see when I delete it. So, I mean, of course, I do not have anything to show you at the moment. Okay, so consider this was happened in your production, your pod got crashed. Any of the reason, okay, bad reason, not the good reason. Okay, so in that what happened, it was constantly monitoring it. And then it found out, okay, current state is 2, but desired is 3, and ready is also 2. Then what it did, it spin up new, okay, replica. And now you could see the ready was also not 2. And at the end, it maintained everything until and unless all these things value, I mean, all these values values match, then it is not gonna stop. Okay, then after that it says, okay, are you happy now? Yes, now we are happy because desired current, everything is fine, and also our pods are ready to. So when we run this command again, kubectl get pods, so you could see now this one, right, 77 seconds and 88 seconds. Okay, so this is how this is it maintains, I mean, not it maintains, and this is how replica set manages the pod. Let me quickly show you once again, and then we are done. So you could see ready was 0, right, and current was 1, then 3, and ready was again 0, then 3, 1, 2, 3, right? So this is how self-healing is maintained. Okay, so this is the way. Now we have changed the configuration, and when I do it like this, yeah, open. So I'm just kubectl get replica set, my first replica set in YAML. So we should be able to see the configuration, right? So kubectl last applied configuration, and what we have changed. So we changed the replica set to 3, which is, so that's how in the annotation part kubectl, and by which, right, it is maintained the configuration. And that's why it says meshed, unmatched, configure, changed, or yeah, like that keyword it provided. Additionally, one more thing I would like to show you, kubectl get not get describe replica set, okay, and my replica set. And if you see in the events, right, you find, okay, when we make any changes in the replica sets, okay, scaling up or back, that can also possible via other things, but I just to simulate the scenario, okay, I did manually. Okay, so created, and all this created by a replica set. Okay, and when you describe, so when you are, if you're following along, so copy any of the pod, okay, and describe that and see what you see in the instead of replica set controller. Okay, and here if you see, so again replicas, so that's how it is maintained, right? And now the question is how replica set knows which pod it has to maintain, right? I told you the selector, okay, and this is by I would say intentionally I did not put any of the labels, so you will not get confused with the labels and the selector. So when I go over here in the pod section, we have labels. So this is happened, I explained it in part again in more detail, but let's quickly see it again over here. So selectors are different than the labels. Okay, selector means select whatever. So of course those are the labels, and that's why I said you must, if you are very good with the labels, you can play around very easily in Kubernetes. Okay, so here selectors, so here match labels. Okay, so in selector, so we know select means what, right? So I don't need to explain it's what it's a meaning, right? And match labels is again, so in selector item, okay, in spec item we have selector, right, which see here whatever you mention must be include in the template of the pod. Okay, if I remove this one, okay, from the template, no pod will be going to, I mean this will be then often how this replica set will identify which pod it has to maintain. Okay, so it identifies using this one. So in order to give you the demonstration of it, okay, let's verify this whether I'm saying the thing is correct or not, right? So what I will do in this file, okay, let me edit this file and put this label in this pod. Okay, so mm, where I can put the labels over here, right? And label is app colon my move, right? Second, okay, and if we come over here, you see kubectl cat pods, right? We have only 3 pods. We do not have my second pod. So what we are going to create, we are going to create a pod which should name my second pod. Okay, and here I am putting a label in pod file. Okay, not in replica set file. Okay, so here consider, I mean I put the same selector label, right, whatever I have put over here. Okay, so app my dash, and of course come on, the second pod. Okay, let me save it. I did save, and now we are going to apply it. kubectl apply dash, and you know it's the same file, the location is this one. Okay, let's copy this and I put it here, but I will also show you something over here, so let's watch it. Okay, so replica set will try to find a pod, okay, with this label. And this we have put this label now, and let's see what happened. And also, okay, I come to that. So now see, here it says pod, my second pod created, and here container status is unknown. Let's see what happened. So first it was in pending, container creating, and let's see. Okay, container status is known. That's fine. Here, let's describe the replica set. Replica set, replica set. Okay, so interesting. See, replica set controller. So it has deleted the pod instead of creating a pod. But right, this is happened 38 seconds ago. But we saw the pod here in on this screen, right? It was created, and we also saw over here itself, right? Pod was created before. So what happened? Why this happened? Right? Why replica set cheated us? Is it? No, it's not. Okay, so basically what happened over here, right? Okay, so before I explain you more, let me do one more thing. Okay, I will share this file as well in a in a repository, so you will know I have reaching the, I mean, put it in a previous state. I've removed the selector. Okay, but of course I do not have this option in pod. So just to show you everything is based on the selector, that's why I just copied this and put in a label. So in pods we have to put this in label. In replica set we put the same thing in the this section. Okay, so I have changed it. Now let me do it again, and now this time, okay, we said replica said you do not have any rights to touch my second pod. Okay, so don't do it next time, and don't dare to. And this time what happened? Yep. So you could see my second pod is over here, right? Let's do it one again. Undo the changes, save, and we know how to undo. We talk in part 3, but I just use U. That's it. Okay, so before applying, right, it has created, and now if I say unset, so it says configured, and you could simply see it has just again deleted the same part. Okay, no wonder at all. And I can do this whole time. Control R. What I've done. Yeah. So I can again delete this, save this. I can apply it again, right? And again, my pod is going to create, and it soon it will show over here. This time, let's do something crazy. kubectl pod. Okay, kubectl. But yeah, what crazy? If you delete, then of course it is gonna be created again, right? So remember, that's how the pods, I mean, replica set manages the pod. This is really important thing in Kubernetes, and many people get confused on this. Okay, when you find, as I mentioned, part 1, when you find the example on the internet, you will find everywhere is the same. Okay, so that's why I put in level as well. Can it be anything? Yes. Okay, mesh level. So mesh level, I have shown you how it works. Okay, and this is the way we can create, we understand, and not we, I mean, of course we understood, but replica set identifies which pod, and I showed you in the demonstration, correct? So these are the things with the replica set, but we know, okay, replica set does not have the rolling updates feature, right? And it also does not have the revision. Okay, those are really helpful when you want to maintain. When we talk about our Git and GitHub section, right? Day 3. So we saw the versioning is really important. Of course, this file you can check in your repository and you can maintain the versioning, but I'm talking about inside the cluster. Okay, so let's see those what happened when we create the deployment. Then what happened? So quit all. Okay, we have cleared. Now clear the screen. Yep, it's gone. Let me show you how you can delete the replica set. kubectl, of course. You are not kidding anymore. Delete -f my second, sorry, my first replica set. Okay, so this is deleted, and now kubectl get all. Okay, so still we have second pod running. Okay, kubectl delete pod. or simply we can copy it from over here to over here. Okay, so when you find this repository, okay, resource will be in this folder ReplicaSet. Okay, this is already created over here for you. Okay, my second pod, and I put it over here, my second in a level of the pod. Okay, so just to show you how you add it. Okay, that's why I changed the in that file, so you will find in this same folder. Okay, next we are going to see the deployment, but before that I will show you a key difference, right? Because we use kubectl create and kubectl apply both. Kubectl, which is create, is a imperative command. Okay, you can directly create a resource with that, and we saw already it fails if the resources already exist. Okay, and kubectl apply, right? Kubectl apply, APPLY. Okay, and your resource name, not the resource, your object file, of course resource file. So it's a ensures, right? It's a declarative command. Okay, it ensures the cluster matches the desired state, right? And we already saw there was annotation in the file which is maintained by the Kubernetes. Okay, so of course you, by the time when you will work in production, you will get to know what you should and which command you should, but I always use apply. Otherwise your pipeline will throw you exception or error, and then it will get failed when it will not able to create a resource. And of course why do we need to create again? It's already there. We just want to maintain the configuration, and that's what we do in production, right? Once we set up, and rest of the time we maintain. So enough on the replica set. Now we are going to see the deployment. Now let's create the deployment, and for that we have, let me go to deployment or deploy directory, clear the screen, and we know how we can check kubectl get deploy and no resources found. You can also type, if you're like me, deploy. Okay, short form, but no, but it's your wish. So kubectl get deploy, we do not have anything additionally. If you want to see kubectl get all, okay, we have only this. So guys, you may be wondering why I'm typing again and again the same commands and showing you, and there is no resources in the cluster. There is, right? So that it's not like I'm telling you, okay, it's a proof there was nothing and we are going to create, right? You know, but my intention over here to execute this command, when you finish with this, these are the very frequent command we use day to day, and you will be very savvy with those commands. That's my motto. That's why I'm executing the command again and again. Okay, that's enough on that. Let's see and create the deployment. So again, there are two ways we can create a deployment. So first, let's see the command. Of course, if you're going to write CCAD, right, or community certification, you must be very, I mean, you must have very good command over the commands, right? Or I would say the imperative way. So to create a deployment, right, kubectl create again, right, create, create, and what we want to create, deployment, and I want to give it a name first. My first is always a special, my first deployment, and here you have to give the name, right? It's the same as what we creating a container, okay, in which we're talking about day 5. So let's create this kubectl create deploy. So is the same command, right, we have been using. So we create a pod, we create a replica set, right? And now this time we are creating a deployment. So kubectl create deploy, and what we want to do, we are gonna give, or we want to give it a name. Okay, in your production system it's a different thing than whatever your application, okay, or I don't know your use case, so give it a meaningful name, but just it's our first one. So I have given name my first deployment, and I have to provide nginx is as an image, right? Let's see. Okay, so as usual, right, we know kubectl get and deploy, right? So you could see 1 of 1, right? We did not mention any further details. By default it has created this, and we talked before in part 1, right? Deployment manages the replica set. So kubectl get replica set. So we also got a replica set, and replica set manages the pod. right? So we did not provide. By default, it considered replica as a 1, right? So deployment 1 of 1. So you could see deployment, right? So as I said, deployment manages the replica. Okay, they don't directly manage the pods. Okay, and I'll prove you as well, and prove it means I will show you how you can check this. Okay, if you already working on it, you know where to do, right? I believe you guessed it. Where we gonna check it? Okay, and here you could see everywhere. My first deployment, right? Here also we have my first deployment, but we have here one string. Okay, and which string is like this, and this string and this string is same, but here we have my first deployment, and this is the hash value of the pod. All right, so let me show you over here. First we describe the deployment. Okay, and clear the screen, kubectl describe sorry, not replicaset, deployment.apps, and that's why we used auto-completion. So I just put a tab and it has given me all the information, right? So here, okay, we will come on that other things as well, but first we will see, you could see the deployment controller, okay, and scale up replica set. And which the replica set is my first deployment, and from 0 to 1 replica set. Okay, so when I describe this replica set, so now in the event section, okay, replica set controller created a pod, my first deployment, and this is the name, right, which is, or I would say the prefix for the pod, and this prefix belongs to replica set. Okay, and now uh, let me do one more thing as such. Okay, and here when we describe this pod, right, so we already know this, but still it's better to have, right, understanding. Okay, so here describe pod and my pod name, and here we go, right, short of it, and successfully assign default my first deployment, this. So it is not deployment, remember, and how we can know default scheduler. Okay, because the job of scheduler is to assign pods to a node. Okay, and this node where the pod has been scheduled. Okay, so don't be confused with the name my first deployment, right? When you execute the command like this here, right, when we execute the command kubectl get deployment, here you could see the deployment name. Okay, and then based on that deployment you got this one replica set, and based on that replication controller created the pod. So here you could see in the event, right, and again, yeah. So deployment controller, so now you know we have different kind of controller as I mentioned before. So in this case we have the responsible controller is the deployment controller. In replica set, so replica set controller, okay, it is not replication controller, right, it's a replica set controller, and here the scheduler, because pod is created, pod cannot create itself, right, and that's why, because and this is how, and this is the way we could say the pod is the lowest level object which is wrapped around replica set, right, and that's why replica set created a pod. And as I said, replica set is also, okay, intermediate, or I would say the next level object, and which is wrapped around the deployment. Okay, so that's how it is work. So this is about the explanation on how the deployment works. Okay, so deployment doesn't manages the pod directly, it instructs the replica set perform the things. We learned this in our part 1 with the manager as a deployment controller, team lead as a replica set controller, right, and the pods are actually teammates. Okay, these are the analogy we understood in our part 1. But one thing I told you, okay, deployment provides more functionality, okay, which is not possible in the replica set. So how we can check? Because when I created, right, this was the command, and when I created this kubectl create deployment, I did when I created this, I did not mention about anything, right? So Kubernetes is awesome. That's why I said it is one of the ultimate tool which provides awesome things. Okay, so Kubernetes added those things for us. And how we can see this? So there is one more thing. Kubectl get deploy apps. So we have this. So though here we do not have any replica and any YAML file, sorry, YAML file. So what you can do when we see this, get this one as a output YAML. So here, right, so you can see here you can see the labels, right? These are automatically created and in spec. Or I will show you more better version of this. This is one of the way. So add it. Okay, there is another command. So far we will be using kubectl get. This time we will use the kubectl edit deployment app, but we have to provide. Okay, always remember provide the name over here. Otherwise, it is gonna be open all the files for you. Okay, so by default, if you don't provide anything, it's considered okay. You want to see everything, right? But we want to edit only this deployment. Okay, and in our case, we have only one. And now you could see it is more better to see, right? In YAML. And that's why I told you initially learn Vim editor. I simply open this file, I mean this YAML files on the other editor as well. But if you're going to write exam, okay, or if you're doing debugging on server, you do not have your favorite editor. So make yourself familiar with the terminal, how you can edit. Okay. There is no fun in that to open VS Code. Sorry, not VS Code. I'm really sorry. There is fun, but in editor, because you can simply open and see, because you have syntax highlighting, so many stuff. Okay, here you do not know, you don't have anything. You need to know where you need to look for. Okay, of course you may be thinking it's a boring way, but this is the way and powerful way to work. Okay, let's go ahead and see here. Okay, the API version, apps v1 kind, it's of course the deployment metadata annotation, right? Here we have revision. Okay, so which was not in the case of ReplicaSet. So that's how we will also we will come on that, the what revision means. But yes, you can see. Okay, then of course label, name, namespace, revision, version, UID, spec. Okay, these are fine. Replicas is over here, and revision history, limit is trend. Here again we have selector, mesh level apps, my first deployment. Okay, you could see over here the my first deployment, right? My first deployment. So when you create a resources using command, right, it everywhere is the same. But I explain you now, you know this label means what, right? And selector means what. Okay, though it's the same thing. App equals to this one, and here is also app equals to this one. And if you go in a template, right, here is label. So you know this label and this label must be the same selector. Then replica set no, okay, which body it has to manage, right? So that's why I explained those things. But if you see over here in replicas, revision, selector, and then the point which we are talking about, right, is strategies. So strategies will come, but I would like to show you something over here. So rolling updates, right? So which is not possible with the replica set. So that's why we have this option. So when you do rolling updates, so max search, max unavailable, we will see this in action. What happened if I tell you, it really doesn't make any sense. Okay, by default these values mentioned in percentage, right? I will show you that. So this is the rolling update strategies. Okay, we could simply copy this and put in your own YAML file as well if you want to. And here is the type role. So these are the default strategies. We did not define, right? And but it is automatically mentioned. I mean not mentioned, added. So this is how Kubernetes perform when you create deployment. It added its feature automatically. So it got covered for you. you really don't need to wait. Okay, and if you see the template, so it's the same, right? Here you see this is a auto file created by the Kubernetes, right? Let's make our own deployment file and see, because maybe these are so many information over here and maybe overwhelming, but this is how it looks. Okay, I did not make any changes, but of course if you want, for example, in replicas, right, instead of this, if you want, you can say 10 replicas and save. And if we see, okay, keeps here that now you see it has updated, right? Now it is updated because I edited, and that's why it says like this. So we are good with this kubectl. But if you want, I can also show you like this kubectl that ReplicaSet. Okay, pods are fine. My first deployment. Okay, if you want to scale back that down, there is another way to do that. Okay, in case when if you don't want to open, right? And of course in exam it takes time to open a file, edit a file. Okay, initially when you are getting started, it seems very easy to open a file, but when you are time bounded, it is not at all. So for that you have a command, and really we do not have to mug up the command, right? kubectl scale. And if I open this document, let me use the yes, so we can go one by one. And here it says set a new size, right, for deployment, for replica set, for replication controller, or stateful set. Okay, and the scale also allows user to specify, read this definition, what I'm interested in over here. Thank you very much, Kubernetes, for providing this amazing document. And this document you can use in finance, right, because it's on your system. So here it says kubectl scale replicas equals to 3 and replica rs dash name of the your replica set. Okay, and here is also the same. You can also without making any changes in your file. Okay, and this applies all these objects, okay, which is mentioned already over here. So go ahead and do that accordingly. Okay, but we have seen on the deployment, so I'm showing you how to use this. Okay, and kubectl scale current replicas equals to 2 dash dash replicas equals to 3. So what it does, if the deployment name, this one current size is 2, scale my scale to I mean the port to 3. Okay, so current size if this, then it is scale one more. And multiple replication controller, so in this you could also say replica set this one, replica set this one, and you can define. Okay, so that take a time and play around it. Okay, how you can do the changes in your replica set, sorry, not replica set, in your deployment. Okay, so I can use the command, right? By the command I can change the number of ports set to 1, right? So what can we do? Let's copy this command. Wait, right? Ish, don't want to execute this command. Wait, okay, so kubectl get deploy. So kubectl scale and replicas equals to, again, yeah, 1 is okay, or whatever you want, you can provide that. And access deploy, and my first deploy. And it has reduced down to this one, kubectl. And if I describe, okay, so it has scaled back down. Kubectl describe deployment, or deploy my first deploy. In the event we will be able to see scale up the, and it is done by the deployment controller. Okay, scale up replica set my first replica from 0 to 1, 1 to 10, and 10 to again 1. That's what we perform, right? And here we already discussed about. And here if you see, one desire, one update, one total, one available, and 0 unavailable, right? This is about the replicas because, as I said, deployment manages the replicas, right? And in replica, if when you describe it, you will find something for the pods because replica set manages the pods. So I'm go ahead and do that. You will find information. Okay. So that's how this scaling. But of course, scaling was also part of the mm, what to say, scaling was also available in replica set, right? But here we're talking about the replication controller. So let me show you how, sorry about that, not replication controller. So here we want to see about the rolling updates. So let's create our next deployment using the rolling update. And so for that, of course, I have already created a file in advance. So I will open its real, and this time we have my second deployment dot YAML. Okay, so I let me first create this as is. Okay, and let's go ahead and use a default way, right? So in YAML, of course, API version, first item, second item kind, third item name, and this time we do not we don't put any levels over here. Okay, again replica selector, we know the selector concept, and template and labels my this one. Okay, so of course templates is exactly the same, right? We don't define replica set in deployment because it is automatically done by the, so that's why deployment is high level object. So let's create the first kubectl, and I'm going to use apply. You know, if I use create, then what happened? So kubectl apply dash f to my second deployment, and if I run command not go kubectl get deploy. Okay, so we have deployment 1, deployment 2. Okay, we have both the deployment, and simply I can change, right, the not change, so it's vim, and I open my second it's a number 2, sorry. When I open it, okay, and if I go and say 20 replicas, let's say, so same thing, we'll do it over here. Exit it. You don't need it anymore. When we need it, we'll open it, and this time we want to watch the pods, right? Keep ctl like dash f number 2 my second, and yeah, container running, and here you could see the configure. Right, so 20 replicas been created and all are up and running. We can also see like this. All right, and I already explained you what this means, so no need to do it again. So 20 out of 20 our ports are ready, up to date, right, available now. So I'm just doing dash w option, right? So this is not a way, okay, this is not a way to see the rolling updates. So actually rolling updates are happening over here, but it happened very fast, right? And if I kubectl add deploy, okay, and my second deployment this time. So what happened? Of course, now we know the annotation, but you see, this is strategies, right? These are right over here. So here strategies, rolling updates, max search, unavailable, type rolling update. So if you copy this one, okay, just copy from over here and come back to our YAML file. Okay, so we just copy it and open. So I already created a file for that. Okay, and which is this one, my second deployment and rolling update. I will give it a name, but number 3 is a file. Okay, and then Simply you have to provide in specification, and that's why where we talk in part one, we said what is, so we want to let know, okay, we mention in specification what our object should look like, what we want to do, right? What is our desired thing. So here, instead of um creating, instead of having the default thing, we just in specification, right? Here you find you could see the replica is one selector, of course, as is, and my second pod. Okay, I have given it a name. If you want, let me open it, that file. Second one, this is the third one, right? So name is my second deployment, my second pod, right? So it's the same. That's why since beginning I'm using the same, so you know, and you can back and forth refer those if you want to. Okay, so now we have new thing, right? One second. Okay, this is three. I'm sorry about that. Yeah, I explain here, but those are the things. But here the template. Okay, here, so in spec, okay, it's under the same selector. Okay, so let me give you a quick trick if you are adding something new. Okay, so instead of selecting the indentation over here, simply go ahead, spec like this. Let me show you, and paste like this. Okay, and after that you do not have to do much edit. That's a quick trick, a quick tip. Okay, so I already put it over here: strategy, rolling update, max search, and all this. So what it means, so this configuration, right, is strategy. Okay? So let me first close this file, which is we don't want it anymore. Okay, because we are discussing this one. So a strategy, so this entire strategy is type for rolling update, right? So we'll talk everything one by one. So this configuration defines a rolling update strategies, okay, for updating pods in deployment. And here's what each part means. So first, rolling update. Okay, so rolling update here. So this specifies the update should be gradually or gradual. Okay, replacing pods one at a time instead of stopping all at once. Okay, so this is a strategy which says, okay, don't stop all the pods at all. Okay, do it as we say, and how we say. So this is the next, make search. Okay, so make search allows at most one extra pod to be created temporarily, okay, beyond the desired count during update process. So here I mentioned one. So search, it means whatever is your desired state. Okay, so it will, I mean, whenever you have rolling updates, all the times in your cluster you will be having plus one. Okay, whatever desired state. So our desired state is replica set one, right? So maximum we would be having two pods in a cluster. And why this is important? Okay, by default you saw it 25%, but if your cluster, this happen, okay, I face this thing. So if you have 25%, when you see, if you have 1,000 pods, right, and 25% is how much? Okay, so that's why how we define this. So just quick thing, we will be seeing more in our Kubernetes certification training. So based on your, how would you decide? Should you put 1, 2, 10, or why? Okay, of course, it's crazy if I say put search, max search is, let's say, 100, right? So you have add extra pods to handle the request. But if your your cluster is not capable of handling those many pods, right? So those pods will not come up, and other resources will also not get created. Okay, so that's why based on your, what is your cluster capacity, okay, based on that, put this file. Okay, so it's okay to have one max search. Okay, so always, always, okay, in your cluster you will be having 1 point, so you are replacing one at a time. Okay, no harm, no rush, but again it's up to you what you want. Okay, and max unavailable is 1. So simply what here I mentioned. So only, it means only one pod to be unavailable at any given time during the update. So in our case, we have one pod. It means only one pod will be unavailable, but it will also ensure to create one additional pod, right? And of course, we know the type is rolling update. Okay, that's what our strategy, and that's what it does, right? So one at a time, and this is how it maintains the strategy. Okay, so this strategy ensures a smooth rollout by preventing downtime. Mention, I mean, make a note or note this word downtime. Kubernetes replaces old pods with new ones incrementally, okay, rather than shutting everything down at once. So that's the beauty of the Kubernetes. Okay, your application, it provides zero downtime. I could say zero downtime if everything goes fine, right? You have thoroughly tested, or ideally, Kubernetes is only the tool, as per my understanding, which provides a zero downtime. Okay, so we have put this over here. Let's apply this and see what happens. And here, um, okay, kubectl apply dash 3. Okay, so I just given a name. The file is the same, nothing changed. So you could see, and this happened very fast. Completed, right? But it configured over here, right? And not describe kubectl edit deployment, my second. So here you could see, instead of percentage, right, we have max search one, unavailable one, and all this thing, right? So this is the rolling updates, but of course you may be wondering why we are not able to see the rolling updates. Okay, so this is not just watching a ways to see a rolling update. Rolling updates is a different thing, and we could see those in using the command. Okay, and how we could see that? So let me first close this and show you as well. Not sorry. So second pod and first pod both have one desire, right? And ready. So how we could see that one? So for that we have command kubectl. Let me explore. Find this kubectl rollout. Okay, status. Sorry. Okay, and status of what? Deploy. Sorry. Deploy my second deploy. And you could see the deployment, my second deployment successfully roll out, right? Let's do it again. So instead of replica equals to 1, and we should be having replica equals to 10. And let's put it 20. Why not? Plus 20. And apply it again. And now my second deployment configure. Still right status. Okay, sorry. I edited this file. This file, which file? Let me see which file I opened first. Okay, 1 second. Okay, so I think I didn't do any of those. So let me clean the screen first. And 3, my second deployment rollout updates. And here, so I did not, I think, change. I don't know where I made. While I did, I will see where did I make changes in which file. So let's 30. Yeah, okay. That's why we have in memory. I mean, not memory, the powerful machine. So I changed the replica set. Okay, this is our max search max. So max search is again whatever is desired plus one, and additionally, and one pod will go down all the time. Okay, save it and keep ctl apply this one, and apply. Okay, configured. Let's hopefully it should see. Okay, we are able to see something, and you could see. Okay, so that's how you could see. Okay, 5 or 30 or something. Okay, this is the rollout status. And now if I run it again, so it says successfully rolled out. Okay, so that's how it works. And one more thing, it happened very, very fast, right? And what happened when your application, okay, takes some time? So for example, I mean, we are just seeing the demo, but when you are actually working, so to warm up your application to come completely up, okay, it should take some, or if when you want these changes to be made available. Okay, so there is another thing we you could mention. Okay, so for that we have already created another file. Okay, let me open that. Same but with the ready second. So here minimum ready seconds. Okay, so here of course replicas. Okay, so here is a 10 and our replicas, it's okay, 10 is fine. We will also scale back down. So minimum ready seconds, right? So this minimum ready second means that newly created pod must stay in ready state. Okay, we talk about ready state, right? At least for 10 seconds. So before being considered available for a service. So when pod is ready, so it should be stay ready. I mean 10 seconds. So for example, what happens sometimes when you have multiple containers or when you have multiple pods, then it has some dependencies or it is trying to ping some other pods or something like that, or I don't know the reason, but in that scenario, or as I said, if your service, or simply you could say to consider that is rebel, you have to see, okay, what other pods or how many time it takes to warm up your application. Okay, and depending on that, just consider this as a I mean whatever seconds you want, this value in seconds. For 10 seconds I just show put a 10 seconds, it could be anything. Okay, and this setting is really really useful for ensuring that a pod is truly stable and ready to handle traffic before Kubernetes routes request to it. Okay, and if you don't set it, what happens? A pod could be marked as ready too soon and potentially cause issue if it crashes immediately after start. Okay, so that's why it's a trade-off. You have to define or decide what you want to put it over here. So I just put 10. For me, it's fine. So minimum, this one is 10. Okay, let's quit and apply this. ctl apply and app 4. Right, and now we can see the status rollout status. My second deployment, it says rolled out. Okay, so though we have changed the replica sets, okay, in order to see this rollout. Okay, let's see this. Okay, so let's truly see what rollout means. So let me, I mean, in this file we talk about minimum ready seconds, right? And here, if I go over here and let me change the image. Okay, so currently we are using image nginx. We know how we can check it, so we can describe and we can check it over there. So let's see if we have something like this. If we have something kubectl, not this one, sorry, 1 point okay, let's go with the very old 18 and apply. It's a configured. Now you can see, okay, because of the time, okay, we could see it right over here. Slowly it's going, and if I say kubectl pods, So you could see available 9. And yeah, we got this value 11, right? So it should not go above 11. Okay, and it should not come below 9 because we asked, right? So max surge is 1, so that's why we have value here 11, and unavailable is 1. So out of 10 we have only always unavailable 1, that is 9. Okay, so now you know if you have lots of pods and instead of creating maybe 10 out of 10, right, it creates 20 pods, for example. So that's not good. So, but I think default strategy is okay, that's completely fine. And now, so it is over here 11/10, 11/10, then 10. So that's what is our desired state. Okay, we want 10 and all pods are rolled out. Okay, that's how we see the rolling updates. So I showed you how you can use it, kubectl rollout. Okay, and if I go ahead and let me clear the screen first. Not bad. That was, and what was this second, right? And this is my kubectl describe, right? For this one, and I want to grab okay, so 1.18 was the made a change over here. Okay, that's the image is over here. Now so now I don't want this, so maybe let's consider accidentally, or maybe my new version of Alias is not supporting it all, so I have to do rollback, right? So very simple. In Kubernetes there is a command kubectl of course rollback, and before what we were using, once again, rollout, right? So this was the command for the rollout, and for that kubectl rollout, simple undo deployment, and my which deployment, second deployment. Okay, so I just put it like this and it will go back to the row immediately. See how fast is this? Only 1 second, or yeah, whatever the time which took to execute this command. Okay, that's how the undo rollout. So this is the rolling update. You can simply roll back to the version to a specific. So for that I need to check the port first. Let's give it some time. I forgot to change the ready second time, right? So it wait. Okay, yeah, almost there. Great. So we are all set. That pause. Okay, here we go. We got the port, and here in describe. Okay, I simply remove this one, my second deployment. Okay, we got new one, and now image. So previously it was engine X. Okay, and I put a change in my, if you see, right, this file, fourth one. Okay, 1.18. Right, so that's how you can simply do a rollback, and command is very simple, right? We can also see nginx 1.18 was the latest version of our application we deployed and it didn't work, so we can simply execute a command to undo the rollback. Okay, kubectl rollout undo. Before we were using kubectl rollout history deployment. Okay, and this time we are using undo the deployment and name of the deployment here. It's very simple. I don't believe I don't think anything is easier than this, right? So here, the thing, this is about the undo the rolling update and undo the deployment. Okay, now I would like to show you more commands which are very, very handy, and you must yes, you must know those commands, okay, to view the rollout history deployments. So yes, we already saw this command, kubectl rollout history and deployment. So we have two deployments. So that's the thing I was talking about, versioning. So you could see the revision, right, 2 3, because we have made changes over my second deployment. We didn't, right? So that's how you can see the rollout history of the deployments. Then if you want to see what happened in particular deployment, so simple, you can copy paste this command. The type, yeah, it's available, so I'm just doing it. Kubectl rollout history, okay, deployment, and let's say this one, my second rollout history, of course. Okay, so that's to see a specific deployment, right? This is, you can mention. If you don't know, simple execute this command, kubectl rollout history deployment. You will get everything. Then grab one what you want and copy paste like this. Okay, so this is to view rollout history of a particular deployment. And if you want to see what happened in this revision, let's say 2 or 3, let me make it like this. So more, see the more details, like so 2 3. So simple, kubectl rollout history, deploy my second deployment, and dash dash revision. Sorry, not equals to dash dash. Sorry about my keyboard. So revision, okay, revision. So how I remember this one, revision, and we'll give the number, revision number 3. And here you could see the pod template, okay. And if I give it a 2, you could also see, right, 1.18. So in 2 happened this one, in 1 happened this one, okay. And if you see, or if you want to, let's say this, when we do undeploy, undo the deployment, so by default Kubernetes went back to a previous version that deployed, okay. So from the here you could see, let's say let me make some changes over here first, and I'll tell you what, I'll show you what I mean. So instead of 18, of course it's very old, right, version, so 28. Let's see if we have 28. I need to make more changes in 30 seconds. Not 10. Okay, 1 is okay, so it will be faster. Okay, I think, yeah, I should also say change the other details as well. But anyways, you get the point. Okay, let's see, but it is faster, I believe. Reload history, my second deployment. Okay, I execute the same command, clear the screen, and this one. Okay, so before we had 2 and 3, now we have 4. So I can simply check number 4. Okay, so if I do undo the deployment, then Kubernetes will, this is a 4th version, it will go to previous one, right? And that I don't want. What if I want Kubernetes to roll back to a specific version, right? I can execute the command, and by which you can check it, right? And so far I don't need to give you proof, right, that way, because we have this source this way, right? If I go like this, you could see 18 version, right? And 4%. I mean, the 3 is the Nginx latest one, right? And if I go ahead, so let me show you why not. Not this, right? Okay, so undo the deployment. Let's do undo the deployment by setting deployment and see what happens. It's a rollback. Okay, you describe the pod and get the details if you want to, but I would like to show you something different. Oh, sorry, it happened twice. Let's see. Let's see. See. Okay, so now you can see two, right? So I undo, then undo. I mean, when I change this one and undo, so it switched to this one, and I undo, then it switched to this one. Okay, and then 5 and 6 we have, 3, 4 has gone. Okay, if you make more changes, because all these three have the same details. Okay, so let me quickly show you 2, 18, and we do not have 3, right? We have 5 is the latest one, and 6 is the 28%, right? So that's how you could uh, see. But here the thing is, if you don't mention, then Kubernetes will, of course, it's a policy, right? But you also have control if you want to move to a particular changes, right? Or if you want to roll back to a specific version or revision. So for that, you have an option, and to use that option, how you do it. So it's the same kubectl undo. What is the command? Undo. Yeah, undo the deployment, kubectl, right? Rollout, undo, deployment name, and from here you know which revision history you want. Okay, so let's say -2 revision. Okay, equals to in our case. Okay, let's go to 6. Current template already matches revision 6. So, okay, so do it to 2, and it has done. So it is gonna be make changes over here, and if you want to see again rollout history, do it like this. Okay, and if you want to see, I told you how you could see this, right? So it's very simple, right? Doing the undoing the deployment or to a specific version by which you can see, and you really don't need to remember this. So I want you to only remember this one, rollout. How you set, I mean, test it, kubectl rollout dash. And if you see over here, use favorite, manage the rollout of one or many resources. Deployment, DaemonSet, StatefulSets. Okay, and now it's also proof it doesn't roll out feature. I mean, it doesn't manage the rollout for the replica set. So that's why we mentioned this thing, right? So, but that's how you know. So here the point is, you say roll back the previous deployment. So I did the undo undo the deployment, not deployment. So kubectl rollout, undo deployment, rollout status. You could also use this with the DaemonSet. You could also restart deployment. Okay, you have to use like this. Okay, this is your object name, and this is the, I mean, this is your object, what kind of object, right? And this is the name of your object. And you could also have selector. So see, the selectors are really powerful. Okay, you could also use resume, restart, status, undo, and other things as well. Okay, so this is the thing, and as it says, you can manage the rollouts of one or many resources. Okay, and here the daemon sets and stateful sets. But yes, so daemon sets, and that is our next topic. So that's enough on this. Okay, so make sure do the practice. Okay, I just use it engineers, go to the repository. And one important question for you over here, when I open a file over here, right, this one, so I just put a name, Okay, just change, give it any random, okay, any random image tag over here and see what you get in the events. Okay, and use it for others as well. Right, so that's your the practice questions on this. So I have shared a lot of information on deployment. So now we have really solid understanding about the deployment replica set pod, deployment manages replica set, replica manages pods, and that's how we you have. And in actual production, we really don't create a pod directly. We always use deployment, okay, for the application if we have simple application. And to do the rollout and revision history and all these things we have saw already. Now it's the time to demonstrate. Okay, so let's create DaemonSet, and for that we have already in over here. And what do we have? Kubectl that all. We have lots of stuff. So what I will do, kubectl delete -f, and all these are deployment, right? But you could also execute this command like this, okay, but it got something for us. Okay, fine. What happened? Error while deleting. Okay, my second deployment 30. Yes, no worries. Because ultimately the command got executed, but yeah, as I said, these files are the same as our second deployment, but with just some of the changes, right? So that's why it showed you like this. But anyways, it worked for us. So get all, and but still we have first deployment which was created by the declarative command. So kubectl delete delete deploy. What is deploy? Not very. So it has deleted. Now we have our cluster is clear. So next thing, DaemonSet. So DaemonSet is very helpful. Okay, so these are similar to, I would say, the deployment. Okay, but there is some difference. What difference? So there in your deployment, you have to mention the replica set. What if you want your application to be run on each and every node within a cluster, right? So for example, if you have 1000 nodes in your cluster and you want application should be run on every 1000. So DaemonSet is a special way of or a special object in Kubernetes which ensures to execute on each and every node. Okay, so Kubernetes mention a pod to execute on each and every one pod. Okay, so let's go ahead and see this. It's a YAML first. So my first DaemonSet, right? And here is the same thing. And here is the same thing. API version apps-v1 as of now. Find is DaemonSet metadata, okay, spec selector, again the same, and template. My second pod is of 3 environment, levels are same, and I'm also using the same image. So nothing special in this. It seems very similar what did we have for deployment. Okay, so let's see, we deploy it and see what things, what we will get. kubectl apply -f in my first DaemonSet. Okay, and let's see, kubectl get, I should execute this command over here, or here is also fine. Node. Okay, so we have this many nodes. Okay, and now if I see kubectl get DaemonSet, okay, so you could see it says desired 4, current 4, ready 4, operated this one, available this one. Okay, node selector none. So there are more options as well. Those are part of advanced. We will see in Kubernetes training, but this is fine. Right, kubectl get DaemonSet. Oh, sorry, not this one. We don't want output like this. Okay, now here, so it's a 4, and if I open, right, this one, this one. So anywhere I did not select any of the replicas. Okay, and but it says desire 4, current 4. So somewhere it is maintaining the replica sets. kubectl get all. Let's execute this command and see what happens. So my first DaemonSet, and you know the same thing. There is replica sets are not created, right? It is directly DaemonSet. Okay, and if I execute the pod kubectl instead of all pods, okay, and dash o and white, and let's do like this. So if you see on this, let me clear the screen first. So you can see, right, dsoc m0403, and also everywhere it is executing and different pod, right? So this will ensures your pod, at least one pod, or not one pod, is at least on one of your each and every machine, okay, and each and every node. So when this is helpful, when for example you are installing, of course, one of the use case when you want your application to execute on each and every node, okay, you could use that. But where I use it to install agents, monitoring agents, right? So because it will take reduce the overhead, okay, whenever new nodes will be added, automatically new pod will be created and for that particular node, right? So that's how you can do. There are more applications as well, but I use Diamonds honestly for that one, right? You can search on the internet, you will find. And I, but here the point is, DaemonSet runs on each and every node of your cluster. So if you have something use case, so how to find a use case, right? So of course, this is decided by the team. Within a team, they said, okay, this is really really critical, and we want it to be running. We really not rely on the one of the pod, okay, even on one of the node on the cluster, and run this application. So you have to decide what you want to do. For general applications, you use the deployment. When you have this kind of use case where you want to run pod on each and every node, use this one. Of course, I could Google it, or I could search on the with my AI, and it gives you a lot of use cases, right? But that's not my point to explain you. But my point is, when you have your requirement where you want to run your pod on each and every node, use the DaemonSet, right? And this is about this, but we are not done. Okay, and if you go on the official documentation, I will also put the link when in resource kind of resource section for all this in our description when we upload this session video. So we are not done over here, right? Let me go this one. Okay, kubectl, not kubectl, yeah, of course kubectl, kubectl get DaemonSet. Okay, now let's describe it and see what in kubectl set and set. Okay. And now, of course, ultimately we know the smallest unit pod, and that's why DaemonSet controller. So now we are introduced with new DaemonSet, I mean new controller, which is DaemonSet, right? So ReplicaSet controller default, that was the scheduler, not the controller, and deployment controller, it's a DaemonSet controller. And here you could see desired number of nodes scheduled, 4, okay, and current number of nodes scheduled. For if you have one node cluster, you will be able to see this value 1, and number of nodes scheduled with up-to-date pods. Okay, so 4, and number of nodes scheduled available with the pods, yeah, and number of nodes misscheduled. You will get everything and pods status like this. So this we already talked several times, but here this is the important thing I wanted to mention, right? And yep, this is the event, right? So I think that's uh, enough on this, but I mean this part. But one more thing, kubectl, let me add it. I did. Yeah, did it. But you guys are amazing. You always forgive me. Thank you very much for that. So back to the point. Here, if you see update strategy, right? So we saw this rolling update strategy works for DaemonSet, StatefulSet, and deployments as well. Where is this strategy? Where we find mm, where update strategy. Okay, So you know update strategy rolling update, and it has max search equals to 0 and max unavailable is 1 and type rolling update. So why it has max search 0? So simply DaemonSet, right? Uh, max search 0 makes sense because DaemonSet work differently than the deployment. Okay, go ahead and read about it. Okay, I already answered before, but I would like you to explore more over here. Okay, and these are the status, right? Yeah. So this is about the DaemonSet. Okay, and if you would like, let's open in this file quickly. And my first answer. Oh, sorry, we are not here. We are here. So, or what was the file name? Dash dash deploy second part, right? This was the name. So simply you could see here the kind is this one, this one, this one, and of course in deployment we have to mention replicas, which we really do not have to mention. Okay, and rest of the things are as is. Okay, there's no change except we do not have to mention replicas, and we have to change kind. Okay, and of course I need to name because it's a deployment over here. Okay, very similar, no extra thing over here. I told you the use case, and this use case depends. Okay, so this is about one thing, not one thing. This is about the event set, right? And let's quit from over here. Let me clear the screen. And our next topic in this category is a stateful set. Okay, so let's go ahead and create a stateful set. Let's go to the yes, yeah, stateful set. Okay, so as name suggested, a stateful set in Kubernetes is used for managing a stateful application. Okay, those that require stable, unique network identities and persistent storage. Okay, and there are some features which is provided by the stateful set. Okay, so stable pod names. So stable pod names, it means when you create a pod, each pod gets a unique persistent name. Okay, so let's say pod 0, pod dash 01 or dash 1 or sequentially. Okay, this remains even after scaling and restarting. So when you have requirement where you need a static name of your pod. Okay, so we saw so far whenever pod created, it has kind of random name. But if you have some use case where you need a static pod name, use stateful set. This is one of the feature. Second feature is when pods are getting created, so they created sequentially. Okay, and that ensures proper initialization before the next one start. Okay, so order, graceful deployment and scaling. So this is another feature. Okay, and ordered update. So rolling updates happen in order. It means one at a time. Okay, meaningful pods are updated one by one instead of simultaneously. So this makes sure one pod, and of course in every case the name is always remains there. Okay, and there are some more feature, but we'll see that in action. But when to use stateful set, right? So this is ideal for the application, especially when you have database instances, right? So MySQL, Postgres, or Mongo, or etc. You can use when you have distributed system like Kafka, Elasticsearch, Cassandra, in that case, and apps that need stable networking identities, okay, and persistent storage. So, again, I will put the link of this official documentation and read about this if you want to, but let me show you the features in action, how this not daemon set, the stateful set works. Okay, and then we will talk about more. So in order to create this stateful set, in this folder kubectl. Okay, and as usual, let's see, do we have anything? Okay, kubectl delete, sorry, daemon set, and our daemon set name is this one. do not have anything in the cluster. Okay, so let me first create kubectl apply dash add my first time set. Okay, so before that, let me show you this file as well. Okay, so yeah, there is something in there. So we will discuss this later in when we have this well, service object part. Okay, so of course API version, okay, kind, metadata, name, spec, replicas is one. At the moment we want one because we will see those in action. Okay, and of course mesh level selector template is and for this demonstration to show you the features. Okay, I told you this is useful when you have use cases where you want some uh, static name of the host. Okay, some database where you need some persistency. Okay, so but just to show you demonstration, we will be using another database image for this, and we will see that in project one. But just first let me show you the features. Okay, so I think so far now you are very much familiar with the YAML. Okay, and that's why since beginning, and so now I have maintained the this formatting. It means the same thing, so you really don't get confused at all. Okay, so that's why I told you initially, these are the one of the four important items you need in each and every YAML. Okay, so let's go ahead and create this first. Here we go, kubectl, and let's see kubectl get STS, stateful set. It's one nothing important in this, right? But let's describe it. Kubectl describe stateful set and hit enter, and now we are introduced with new controller, stateful set. Guys, please make a note of this one, okay, from the events. So in your interview when it will be asked, so you can give at least 5 6, okay, or I don't know how many you remember, but make yourself familiar, okay, and note this controllers, how many controls are. If you will be asked for what is a controller in Kubernetes, so you can explain. As I said in discussing part one, so you can explain and you can give this example, right? When we create deployment, we have deployment controller. When we create replica set controller is there. Okay, stateful set is there. DaemonSet, stateful set controller is there. DaemonSet controller is there. Just give it a name. It really gives a very good impression to your interviewer. Okay, and not just an impression, because you know that's why you are telling, right? Honest thing is that it will really get in, stand you out of the, sorry, from, I would not say crowd, okay, from other person if they don't know, but it's better to have more knowledge about it. Okay, use the proper terminologies, and you could see over here when we describe it, right? And here we have first stateful set, right? It's the same selector, right? It's label none, right? But import status is also the same. Running waiting this template is the same, and this one, right? When you do later on hands-on or follow along with this, so when you roll up and down or scale back in, then just check, right? This labels. Okay, go ahead and see each and every pod. Okay, and make, so that will be your practice. Don't say, okay, I do not have enough practice question. Scale up 100 pods if your system support, and go and describe each and every one, each and every pod, and see this, and then you will become very much familiar with all this thing. Okay, so this is a pod templates are same as this, and here you could see pod my first stateful set dash 0. Let me show you the pod now. Kubectl, here the screen, kubectl get pod, right? So we have one name of the pod. Okay, then as I say, when you have the use case where you need a sequential naming of your pod, you can use this. Okay, now let's scale up, right? To scale up, what we can do, or maybe okay, get pods, Okay, that we will see that later. Yeah, we will see that for sure. So I'm gonna scale. So of course there is a replica option is there, but this time I'm gonna use command scale and sts StatefulSet and my first. And how many replicas I want? Replica REPLICAs replicas. Okay, 20. Fine. Are we good? Kubectl scale sts my first. Okay, done. Now let's see. Enjoy the show. 4 is created, 5 is created, and creating, not creating, and running it. Yeah. Then 6, 7, how many? I did 20. Okay, noise. Let's see whether my system supports or not. Okay, so we do not have, still, should we wait for 20? We have 19 number. No, of course. So here is the thing, right? It starts with 0. That's why it's not. So we got this thing. This thing, it means we got the pause. But what there is another thing. Here we just got like this. So we don't know when is created which pod. So simple, I can execute this command kubectl add pods dash dash dot dash by equals to, okay, dot meta data meta dot creation timestamp time is stamp. Really kubectl pods. Okay, anyways, I don't know, use this. 1 second, dash dash sort dash by metadata. Ah, my god, metadata dot, sorry, that's a very bad habit. But luckily it worked, and now it is also um, learning for me, right? The creation, there is a dot in between, so you could see 0 to up to 9, right? In this sequence, of course, we can also see the age, right? We can, but it's your preference. My preference is like this. I wanted to show you. Okay, so in this sequence, it is got it has scaled up, right? Or however you want to say. Now, as I said, so first feature is sequencing name. I mean 0, 1, 2, 3. When it is scaled up, it is scaled in sequence. Okay, and when it is scaled back down, so it goes in a reverse direction. So let's do it and see it how this happens. So instead of 20, 10, 10, let's put it 11, and let's see now what. So here you could see the it has started terminating from 19, then 18th one, right? After that it terminated 17th one, then 16th, then 15th, okay, and so on and so forth in reverse order. Okay, and if you want to see in reverse, you could see, I mean, of course, sorry, this is the same one doesn't apply over here, but here the thing is it has deleted, I mean, yeah, it deletes the created pod in reverse order. Okay, and when I say scale back maybe let's say 15. So you could see again it has started creating 11, 12, 13, 14 like twice. Okay, and now so your content is running, and if I say go ahead and delete, I need only one. So see 14, 13, 10, 9, 8, 7, 6. So I used Nginx image, that's why it's showing this much fast. Okay, but in database when we have so many workload, so this is more specifically designed for it is not only for the database but the application where you need a strict, okay, persistency. We'll see in later when we are going to create, take an example of a database, then we'll create it. Okay, so this is the way you can do. These are the important feature of the stateful set which I wanted to show you. So far I have explained you pod, replica set, deployment, daemon set, stateful set. Okay, and how you can scale up, scale back down. There are other ways, but these are the manual things, and I think these are the, as you are starting, that those things you must know, right? Correct. Okay, so these are the things. But what happened here if we say kubectl cube cube, come on, let's do it like this, kubectl get right? So kubectl delete, and it's deleted. So now it is going to recreate again, right? And this can be happen, but what happened when I mean, of course, I showed you very simple file, okay, right? But what about the data when we talk about the stateful set, right? So I said when you need a persistence in the data, right? So in that case, when it is deleted, right, all the pods, right? This pod has gone. The new pod, I mean, of course, it's a same name, but the new one. If you want me to do one more thing, so there is a command kubectl exec, right, dash RT, and let's give it a name, and let me create one file, or let's go inside. So we are in the terminal, I mean not terminal, the pod, right? And we can check host name. So yes, this is our host name, right? And do it for other pods which we created before. Go and execute the command host name. Okay, so I came up in one of the uh, mm, use case. In my developer friend, he asked me, okay, is there anything I need something, because of we could not make any of the things at service level. So then suggested, okay, stateful set. So the reason behind this, because he wants to, so these are more work in a sticky manner, right? So it is maintain the stickiness. Okay, so if your application is sending a request, so from front end to back end, okay, and if you want to persist the connection, okay, from where you are getting the request. Wait, so I don't remember, it was a very long time. So this feature was introduced at the time. It's that much long. Okay, so maybe introduced. I don't remember exactly what happened, but yes, there was one use case he asked me, and that was the Java based application. Okay, I cannot tell you more. So okay, back to the point. Here we have the host name. Now I say touch. Okay, right one. But simply instead of touch, I could say echo help, not help, hello from this one. Copy paste and put it like this. .txt. Right here we have this file. This is my first this one, and if I copy, I got hello, right? So here my point is I have just put it like this, and instead of this, if okay, no worries, let's go ahead. So here I let me delete this part again. Kubectl delete or right, so it is deleted. And if you see, so it's again 3 seconds picture. Now if I go ahead and see, so you can see my first this file, right? So though the name is same, but file has gone, right? So what are we missing? Okay, so we are missing very most important. I mean, of course everything is important, but now what we are missing a storage. Okay, so that is our next topic. And might be if you're wondering, when we created a pod, why don't we have storage? So we will see everything in action again, and I will try to answer your questions, okay, doubts which you have. But volume is really important topic in Kubernetes, okay, and there are several ways to create a volume. So we will see what PV, PVC, etc. things in our next section. So let's go ahead and see the volumes in action. So to understand volume concept, let's go to the directory. In the same K8s cats dash YML, okay, we have a directory volume, and in that we have manifest file or YAML files. Okay, so volumes concept are same what we saw in our container section, right? Day 5. And we also know why volume required. So in containers are ephemeral, right? So when they die, everything we lost the data, and that's why we need something that provide the persistency. Okay, and persistency, it means stable storage. Okay, we need a stable storage. That's why we use volume, right? So when our container restarted, pod in case of Kubernetes, pod restarted or deleted or recreated, right? So data stays even after that or those. Okay, so that's why we need a volume. And in Kubernetes, of course, it supports many kind of volume types, okay, or type, I could say the types of volume. So we will be seeing in this demo, right, empty directory, host path, and persistent volumes. Okay, so I know it's hard to imagine, so let's see those in an action. We know why do we need volume. So volume is simple storage. Okay, so first, empty directory, so temporary storage, okay, that lasts only while the pod is running. So emptyDir. Okay, let me show you first the YAML file. Empty empty dir deployment.yaml. This is the file. Okay, so here if you see, we have volume mounts. Okay, so up to here there is no change at all. Okay, except the name, of course. But what else? What new things came up over here? So inside the container, okay, this is name port, and you can also put this over or right after the containers. Okay, so here first you have to define a volume. Okay, so you have volumes. So now I believe you already understood volumes means, yes, we can define multiple volume over here. Okay, so this is a pod section, right? Part. So in that, I just said a name temporary storage, so you remember. Okay, this is, of course, we are defining a volume, but this kind of volume is temporary. Okay, and then whatever name you gave, okay, this syntax, whatever I'm explaining over here, this will remain same throughout the other volume concept. Okay, so regardless which kind of volume you are creating, right, you have to create volume, you have to mount volume inside the container. And additionally, if you want, you can mount the same volume, right, inside multiple container as well. Okay, so there are so many other stuff as well. We will see that again in when we start or when we have Kubernetes trainings, but it's a beginner's one then. So you should know you have to first define volumes. Okay, then again you have to give kind of name. Here we are saying empty directory, and that's the our process you have to provide. And whatever name you are providing here, this should match with this one, because here you are defining volume and this volume is mounting over here, right? So what you want to mount, this volume. So this name and this name should be matched. So that's why here we say volume mounts. We already talked this in our day 3. Sorry, not day 3, day on Linux for DevOps, right? And here is the mount path slash data. So this slash data, okay, which is a path, okay, inside the pod, right? I mean, inside the container, but ultimately we don't manage the container, right? So this is the YAML, okay? There is no change. I mean, nothing new. That's why we spent a lot amount of time to understand this fundamental. So deployment, okay? Because in production, you're gonna most likely you're going to work with deployments, and that's what DevOps do. Even as a developer, or maybe if you have responsibility, right? You're application developer or doing testing, you should know how to read the code at least. So it's no big deal, right? If you're a developer, it's a cup of tea for you. Others as well, it could be for you as well, but no worries. Let's come back. So again, two things, right? Volumes, which is in container, okay? So this volumes in under the spec, okay? And this container, in this container has the same, sorry, this containers and volumes have both have the same indentation, okay? Then this volume, this is inside the this name, okay? It means my second pod container, right? This volume we are mounting in this container, right? So let's go ahead and create deployment. kubectl apply, then f, then empty directory, and then you will see what we have. kubectl get pod, okay? So yes, we set one replica, that's why we have one pod. We also know this command kubectl exec-it and emptyDir pod dash dash and bash. You can also use sh, okay, but I like bash, so that's my preference. Let me show you at least. So okay, you see the difference, right? Here I have more option, right? I could see where I am, but here I have only dollar prompt. So yep, your choice what you want to do, right? Here also actually I'm over here, but I have more, I'm more comfortable with it. If you are good with, I mean, I'm not saying I'm bad with assets, but it's your preference which shell you want. So you have to provide the shell. We will also see how we can execute the command directly over here. Okay, then ls dash allow, and what happened where it is on. So yes, this one, right? You could see. Maybe let me clear my screen and yeah, data. So that was we mentioned, and that the path we mentioned on. If I open this one, PD that's for volumes, okay, and empty one. So where I have, right, so I have mounted this temp storage, right, and inside this slash data. Okay, so this is how we do the mounting of the volume. So here we have slash data. Now let me type something, echo, correct, hello mtdir. Let's copy this like this, and slash data, got same name dot txt. Okay, hello emptydir, and we are done. we do we have something here, data, yeah, we got the file. Okay, and now what happens if I exit, right? So what I was referring over here, that's we will see later how we can execute the command. Okay, so now our pod is there, kubectl let pod, right, and our pod is there, right? So now what happened, though we have created a volume, right, and so our data should persist. But let's go ahead and delete kubectl delete pod. Right? So this pod has deleted. If we see, we got a new pod, right? 13 seconds ago. Let me clear the screen first. Okay, so first let's see the pod kubectl get. Okay, we got pod, right? Now we will be executing the command kubectl exec dash it, the pod name, not exe, empty, right? And okay, this is the different pod than the before one it has created, right? And this time we are gonna execute a command. So for that, it's the same concept, nothing new, whatever what this same concept we learn in container, right? Day 5. So but here the thing is, this dash dash is simply specifying or separating the this Kubernetes kubectl thing and the commands which we want to execute on the pod, right? So bash, and after that there's dash c flag, okay, for bash. So here we have to provide a command. So we want to provide a command ls data. So first, before reading the file, let's see do we have file or not. So it means we do not have file, okay, inside it. So pod gone, everything is gone. Okay, all right. So you might be thinking, then what is the point of volume, right? The thing is, volume is not only just for providing a persistent storage, that is also for shared the storage. So when you have use case, right, where the multiple containers wants to share same volume, right? So for storage among the containers or between the containers, then you could use this, and at one place you can provide your data or store your data and can be shared among multiple containers. Okay, so that's the use case for this one, and that's how we create empty directory. Okay, so let me go ahead over here. So we know where we are doing what, right? So kubectl, and one more thing here, kubectl describe deployment. Yeah, so where you will find what. So before we did not have we did not create filling volumes, right? So if you see the mounts, this is what we mention in our EML. We can open it here again. Cats volume, right here, mount path. So if you see this one in the container, okay, and volume is inside the your pod template, okay, a temporary directory that share pod's life cycle. Okay, so here you can check, this is the temp storage and this is the name actually. Okay, so just I given a name, you can give any name or whatever or however you like. Okay, so that's it. There is no more thing over here to explain you, so let's go ahead and see the next one. So next we have host path. Okay, host path, so like empty directory. Similarly we have host path. So host path, right, it's like this, host and path. So host path, they connect spot to a directory on the node. Okay, so there is, so instead of having empty, right, before we create emptyDir, right, here we create a path like we did in Docker, right? We attach local place, okay, into the container. Similar, we can also use host path when we create a volume as a host path, right? We can connect pod directory to the node directory, and we know node, it means simple kubectl get nodes. I'm talking about that node, and the data persists beyond the pod lifecycle. The pod lifecycle, it means when pod restart, dies, or whatever bad happened with the pod, right? Because data stores on the node. Okay, let's see. Deployment. So again, API version, this one, kind this one, metadata in the name, host path, deployment. Okay. And replica selector app equals to my second pod. Okay. This is how, where, I mean, this helps. Okay. Which pods are just to manage. We already discussed this. Then labels. Okay. Again, if we come over here in this section, right, in this spec section, so we say volume mounts. Then here I set host storage. Again, it's a name, and this name is exact same what I've given to the volume. But here there is a slight difference. Okay, here nothing, no difference at all. Okay, here you set volume mounts, you name host storage, and here the mount path. Okay, so slash logs, right here. So again, mounting we do inside the container, and here we create the volume, and in here we are doing, or we are creating volume as a, or volume type as a host path. Okay, if you want to see the difference quickly, I can open over here. Here you could see that I have given a name, and here I simply said empty, and D is capital and E start with small letter. Okay, emptyDir. And here, of course, I have what I want to do. I don't want to create emptyDir. That's why I said host path, because I wanted to create like this. And what is the path? Var log nginx. And what kind of type is directory or create. Okay, so we will see that later. What I mean, later means shortly we are coming on this, but first let's see what how we can create this, right? So let me come over here. I exit it already, and this time that's the flaw. Okay, so we have empty directory, that's fine. Kubectl apply dash host. Now we have two deployments, right? And we are waiting for it, so it will be again ready. So now it's ready. So again, now we can, what we can do, so as host form, okay? So it says host path, and it should be available on the node, right? So if I go and kubectl get nodes or get pods, even better. Okay, dash o and byte. So let's see where this one is created. So on machine 4. So we have this host path, right? This pod is on this node, right? And we said host path, that's why this path, the which we mounted, right? You could see over here, var log nginx. Okay, and this will be created inside the pod. So let's see on this node. So our node is this one, DSOC3 and 4. So how we can do SSH over here? Let's see right now. Why not? So Minikube here, Minikube SSH. Okay, then if you are not using any of the profile, okay, you haven't given any name, so you don't need to provide this. Okay, I have given a name, profile DSOC3, and my node name. So my node name is this one, DSOC3 and machine 4, right? So here I am in the node. I can check host name if it works. Yeah, it works. It worked. And here again, let me show you. Okay, this is the host path. Let's see, ls lrt, right? So we have nginx is right over here. Then of course we have other things as well, but inside nginx we do not have anything. Sorry about that. Let me go ahead in Minikube SSH. So this is where, right? This is our command, right? How, that's how we see, or we do the SSH into a particular, right? Then here, if I see, okay, so, and it's the fourth time I'm checking it over here, var log nginx, right? Var log nginx, right? So if you see over here, ls dash and then var then log, and inside that we have nginx, right? That's fine. So we do not have anything. Right, so this time what we are going to do, we want to see, okay, now we have created this, and we want to execute a command, or let's say some of the changes happened inside the your pod. So how we will see that? So let me clear the screen over here and run the command kubectl get pods, and yeah, over here, and this time let's execute a command kubectl execc-id and the pod name. So this is our pod name. Let me put the pod name over here, right? So again, bash, we are inside the this one, and here if we see ls, we should be able to see some the log where yeah, here we go, logs, right? Oh god, is it, yeah, that's what I use, bash. We have logs, and here we go, right? Logs directories over here. So let's quickly see echo, just put any, so this is host path, so host path, okay, testing message. Okay, so simply just to simulate, okay, when we have application stores the data, right? But here we do not have any application. Host path path right? So is the correct? Okay, host path testing test that testing. Okay, and now we are done. So if we see over here, so we got one file, right? And if we want to cut it out, simply var log ng command var log, and then inside host path, okay, testing message. Now let's come out from this one, and let me clear my screen first. kubectl get and the pods. Okay, now I'm gonna delete kubectl delete pod. Okay, I'm not deleting the deployment, I'm deleting the pod. Okay, and when we deleted pod, the new pod will become up because of desired and current status. Okay, which is, and that's why we create high level object deployment, so which is over here. And now we simply know how we can execute a command, right? So kubectl execc-id and the pod name, then separator, then shell name, and the C command. This time dash ls, and where the log, it is in logs. Okay, here we have log, and here we created a logs. Okay, all right. So let me see. Okay, yeah, this time sometimes happen. Maybe logs. Okay, so yeah, that's a correct. What is correct? We are trying to find something, and there was nothing, right? And that's why, like, we did not get any output directly from for the next. Okay, but we have already data over here, which is stored, right? And one second, let me execute it, and let's check where it is scheduled. Oops, kubectl get pods. Oh, wait. Okay, so this time this is over here, right? And very simple, right? So now what happened? If you see, I need to not exit. Okay, this time I have to, instead of DSOC3, I need to go to DSOC3 machine 02, right? And here again the same var and log and nginx, and inside that we do not have anything. But if we go back on this one, 04, okay, for log engine, and we have the file over here. So guys, this is the limitation, right? This is your limitation of this host path. Okay, so if when we, let me show you another thing as well, how you could still, if you want to use it, so you have to restrict your pod to schedule at any particular node. Okay, so in our case, the pod initially scheduled on machine 04 or node 04, right? So kubectl describe pod, right, and host pod. So here there is a option node selector, right? So here this is the field. So when it is none, right, it means by default Kubernetes can schedule the pods on any available node in the cluster. Okay, so play around it, how you select the node. So change your YAML, right, and in spec you put node selector, right, and find the selector. We will see it in CKID trainings. Okay, so it is not the right time, or it is out of the scope at the moment, but if you are impatient, right, like me, so go ahead and explore that, and then see, then again, right, deploy the pod, and you will see the storage, the persistent storage can be executed inside your pod. Okay, and this is limitation, right, when, because it is host specific, that's why it is called host path, right? But of course, but I told you the way how you can restrict or how you can manage your pod is always getting or will be scheduled on particular node. Use this one. But when you have so many, right, so who cares, right? We want something where whenever I want, my data should be there, right, or regardless wherever my pod is running. So for that and those kind of things, so we have another solution, that is another volume types, that is persistent volume. So far we have seen emptyDir, and host path, but that has limited use case, but you could have the volume when you want to test. But for long-term storage you will use persistent volume. Okay, and for persistent volume you have to create PV and PVC. Okay, so let's see what those are. Let me see what do we have. And kubectl. Okay, sorry. Okay, so we do not have anything, and you might be noticing or thinking why I'm deleting all previous resources. So guys, it's better to do this, and if you don't need, clear it out, so your system will can perform better. Okay, I don't want I get any of the lags during session in the recordings, all this. Okay, that's why, and it is also not too much workload on the system. Okay, so that's why I'm doing that. Okay, so let's go ahead and create the persistent volume, right, which is ideal for long-term storage. Okay, and that's what we need in real life. Okay, all right, so we have deleted everything, kubectl cat all, right? Of course we do not have anything. So now we have already seen empty dir host path, right? So empty directories for temporary storage, and that lasts only while the pod is running. And host path uses a folder, okay, from the nodes file system, so it has limited use case. And I also told you how you can uh, use it, so go ahead and do that. And now is the another volume concept that is actually very useful and which we use in production system environment, right? So persistent volume, and that is for long-term storage. Okay, and so how, so long-term storage, it means, I mean, of course, long-term storage means if we want something to keep for longer time, okay, which is not in other testing, for testing purpose, right? So for that, we decoupled the storage part or our data part out of the cluster, right? So as I mentioned in part one, so everything you can get back except data. So data is always very crucial thing, okay, among everything, whatever you deploy in the cluster or maybe anywhere on the cloud or even on bare metal, right? So there are multiple solutions for that. So let's first see and create the persistent volume over here. There are more things, and definitely we will when we have this Kubernetes certification training, we'll go more deeper dive into. But of course, this is the concept which I'm going to explain you. You can definitely use this concept. I mean, you could get the concept and use the persistent volume if you are using already, or if you have planned to use Kubernetes in for your development or production systems. Okay, so let's go ahead and create. So in order to create first volume, so what we need to do, so here I have application, right? And application is like this. So Vim on PVC deployment. Okay, first, so here PVC, it means, let me clear the screen. So PVC, it means persistent volume claim, right? And here is my deployment file. If you see over here, 4 items, right, which are mandatory: API version and kind is deployment. We already discussed this several times, right? But what is new thing over here? So again, we are talking about volume. So we need these two terms, volume mounts and volume. So we need to create volume, right? That is, or we need to define a volume which is over here, and we have to mount it somewhere, right? So mount is a access point, right? So here, persistent storage, this is the name, and this is also the same, right? This both names should be matched because our volume will be called with this one, right? And persistent, and the same volume we are referring over here, and we want to mount this volume inside our pod or container, right? Slash, under the file system or slash directory, we would be having persistent data as a directory, right? Here's the same thing, except here what we are going to do, it's this persistent volume claim, right? And so we are claiming the persistent volume. Okay, so it's a different or another way to access the storage in the cluster. And here we have claim name, so it's simply my PVC, nothing special. So my PVC stands for persistent volume claim. So I just given it a name, persistent volume claim, and nothing special over here, right? So let's go ahead and deploy it first. Kubectl apply dash one dash pvc dash deployment.yml, and our deployment has created. We could confirm it. Kubectl get deploy. Okay, so it's taking some time, right? We already discussed this, okay, in our pod section, right? So it means our 0/1. So I mean 0/1, it means we have one container, okay, inside our pod, and no container is ready so far, right? Or I would say our pod is not ready. Let's see the replica set. Kubectl get replica set Alias. Okay, so we have desired one, current one. So replica set was created successfully. Okay, now let's kubectl describe. So describe, or first we see the pod, that pod, right? And it's okay. So we have only one pod, and you could see first time we got the status pending. So what happened? Let's describe kubectl describe pod, and pod name is PVC. See how useful autocompletion. So here we say warning failed scheduling. Okay, so it is, and what is the default scheduler? G0-4 nodes are available. So persistent volume claim. Okay, my PVC not found. Preemption node are available. Okay, all these things. But here the important point for us. Okay, it says persistent volume claim not found. Okay, and if we see, wait, let me open it once again very quickly. Let's one PVC and the deployment file. So you could see over here, right? We have given a name, persistent volume claim. So claim name my PVC, right? So same we have over here, persistent volume claim. So we are claiming some volume, and it says my PVC. Okay, name of the volume is claim, what we are claiming, my PVC, and it says it is not found. So that's why it is giving us a warning, and it says failed scheduling. Let's see what happened in the deployment, right? Kubectl describe, and here you could see, so normal scaling replica set, okay, deployment controller scale up replica set PVC 0 to 1. So replica set was created, right? And if I describe this kubectl, let me clear the screen first. Kubectl describe replica set. Okay, so this is our replica set, and here you could see replica set also created a pod, right? Successful created. So what is my point here? Why I'm showing you all this thing? So ultimately, where you get what? Okay, so when you see the event of the deployment, when we saw, right, we did not find anything, right, even in the replica set, but where we found in the pod. So ultimately you have to go and see the what, the pods, okay, pods event, then you will get more updates, okay, exact what is happening. So here we found, so what we need to do, we need to create a persistent volume claim now, okay, and for that let's see the first of the file, okay, one PVC, and this is the file is created, I'm already there. Okay, so again it has the same thing, API version, kind, metadata, right? And what we want to create, because it was not fine, right? So we want to create persistent volume claim, then metadata, and here I have given a name, my PVC, and in spec, right, we have access mode. There are others as well, but this is most of the time well suited for in most of the cases, right? We'll talk this in more details later on, right? And of course, when we have this CKD certification training program, when we start, we'll talk this in more details. But here, what we want, resource, and we want to request storage of 1 GB. Okay, so that's how we create a persistent volume claim YAML. Okay, I will also put official the link, okay, of the which document if you want to refer, right? If you have use case, if you want to refer, you could go ahead and refer those. Okay, if you go to the documentation and search for PVC or persistent volume, all this thing, then you will get so many links. All are useful, but which one you need to follow, right? So in order to save your time, feel free if you want. I will put that link in the resource section of our description. Let me exit, and now we will create. So first of all, we will check kubectl get. Okay, it's a simple PVC. You can write persistent volume claim or simply type PVC, and you could say there is no resources found in default. Okay, so we will create one, kubectl apply -f one.pvc.eml, and again it's the same. I did a spelling mistake, typo, right? So let me correct it and first clear the screen. This time I will type it again, kubectl. Why should I use autocompletion? I should use that. PVC, right, -YAML. And now it says persistent volume claim, my PVC is created. So before I show you this, let me show you one thing, kubectl get pods. And now our pod is running. Okay, so before status was pending because it was looking for something which was not available. So let me quickly describe you what has changed, right? Describe pod and sorry, PVC, this one, and yeah, you could see default scheduler, and then its preemption is not helpful for scheduling, and then after that it found, and then it assigned, right? It assigned to DSOC3 M3. Okay, so this is happening right now. Let's see what happened with our PVC. Okay, so I will explain you more. So now what happened, my PVC, and it says bound, right? So it is bound, and here we have the volume, right? This is the actual location where the data is reside. Okay, and capacity is 1 GB, and this is the access mode we define in your YAML, read write. Okay, and storage class standard and 67. Cool. So let me describe this as well. So let's describe PVC and then my PVC. So what happened? Name, right? Namespace, storage class render, bound, and volume is this one. Levels, of course, you could use levels over here, but we didn't do anything. Then here, if we come, access mode is over here. Volume mode, file system used by. So PVC, and who is using this? This volume, right? And here, if you see, of course, if you see over here, persistent volume controller. So we are introduced by another controller now, and which is persistent volume controller. So this is again one more add-on for your interview. If if your interviewer asks, simply can also say about this, and then interviewer will, out of curiosity, ask you a follow-up question. Okay, tell us. But remember, if you speak up about this, then you must know how to explain this. Okay. So waiting for volume to be created either by external, and read about this, all these things, right? And normal provisioning succeeded, right? And successfully provisioned volume. We see this one, right? And same we can see the volume. So this is our volume, right? Now, so now our application is persistent, right? And it really does not have issue. So what I will do, kubectl get pods. Okay, so now let's go ahead and see whether, right, our file has created or not. So less one dash pvc deployment, and here we will see, okay, we want this side more space, so let's go ahead and use this. Why not? Kubectl, what I was planning to explain, yeah. ctl get what, yeah, sometimes it happened. Yeah, I wanted to explain you about the pod. So kubectl get pod pod, and this one, and this time we want output as a YAML, right? And here we could see volume mounts. So our volume mounts, and volume name is persistent storage, right? We what we claim. Next thing, where is our volume? It should be in spec. Yeah, here is the volume, right? Or maybe let's not go in YAML format, it's too long. Instead, here the screen first, kubectl describe, DESC, I misleading describe. So here is our volumes. Okay, so these are the volumes details, and type is persistent volume claim. Okay, and here we have mounts, the same information, but these are a little bit smaller. And one more command you could use if you want. So there is a command like this, edit and control E. Let's see. So by default, you get in a YAML format is the same, right? But a lot of information which is added by the Kubernetes. Right here you will find the volume mounts. Okay, so we will see, we are coming on secret part as well, but here this is a mount path for secret and service account. Okay, just hang on this for some time. Okay, so how you could see volumes is the same name as we have given over here. Okay, so my this one as is, right? This and this same volume mounts, and volume mounts you could see inside the container, right? And all the volume, and here we have given the same thing, right? So same thing is there. So mount path, so whatever our volume is mounted inside this one. So let me copy this, and let's come out of this file, kubectl exec. We know this command, right? exec-it, and the pod name. Now we are separating our commands, right, with the Kubernetes bash bash, and we are in the pod, and we should be able to see kind of not kind of exactly this directory. So where we are, so we are in slash, and inside the slash we should be able to see persistent data. Yes, here we go. We have already this one. All good, no worries. I was testing this before, so that's why this file is there. But yes, when we do this first time, we won't get this file. Okay, so my plan is to create and show you this file. But yes, so I would say it's already verified. Persistent volume is working. My file is still there. But let me show you if you do not have the file. So you could say like this test persistent volume claim. I could also copy from here, right? Or simple PVC, it's okay. Test PVC from pod. You do whatever you would like, okay? And here we have PVC, not this one, pvc.txt, right? So I have content, put this content, and let me put number one. And now if I read, so I told you before, right? This, and when we have this, right? So this is redirection, right? So we are taking output of this and putting it somewhere, redirecting it somewhere. So that's the difference. Okay, so let me first read this file. What do we have, right? And if you use like this, okay, so from pod, I mean, I wanted to say give you the message as a number, so consider this a test PVC from pod, and this is the message one, and this is the message two. And now we will see pvc.txt, right? We have two, this one, right? So always careful when you are using, and you if you don't use this, then further text will not append, that will overwrite. So it would be go like this. Of course it's not Linux one, but it's important when you are working with Kubernetes, you know what you are doing. Okay, and now if I cat, so that's how everything is written. So I showed you, right? So now we have updated the message, and let's cat the file again. All right, so let's go back over here and exit from here. Sorry, we should exit. So kubectl get pods, and let me do one thing, kubectl delete pod, right? So we are just simulating the use case where pod got deleted, restart, crash, whatever happened, and in that case we will be losing our all the data, right? So this is the just a simulation. So now pod is deleted, and let's go ahead and see the pod. 1 minute. So we know, right? This is the replica set till here. Only this is changed. This is our new container. Sorry, new pod. We are in cd persistent data is there now cat. But first, let's see what do we have over here. So we have pvc.txt in over here, right? Now let's read this. If we find both, and here you see we have something else. So that was the previous content. Okay, so what happened? We have put this message how our data get altered. So let me come back on this screen and quit, and so kubectl this one, kubectl get pvc, right? And it says mount and all these things, and let's describe pvc. I mean, of course I do not have more pvcs, so if I say, it will describe like this. So let me use this, like, that's what we want to read. So there is nothing in here, it's all as we had same 12 minutes before, right? So all good, used by pvc deployment, this pod and everything is there. Let me exit it. Kubectl get pods dash o and wide, like this. So it says dstock3 m2, right? Let me delete once again. Kubectl delete pod, right? pvc. So this time it is created at this location, right? So let me quickly check it again. Kubectl exec, kubectl exec that it and pvc bash. And here we have persistent, and then we have pvc.txt, and this time we have something different. So what is happening? Why we are getting different one, right? So here the thing is, everything is fine. There is no problem at all. So what actually happening over here? So if you see this one, right? If I go back over here and let me do the SSH. Okay, so let's go ahead and see the where is our actual data. So for that we have command. Let's go to the actual node Minikube ssh dash dash profile. If you have given any name to your cluster, right? So this is the profile, and after that I have to give a name of the node. So I have the soc3 and m03, and I'm in. So basically by default we have in here empty data and persistent data. Right, so let's see. We have persistent data test one. Okay, so this is I think also older one. So sorry, I did not check where we have created what was our the first, I mean this part when we deleted, right? So that, so let me do one thing. Let me echo it again. So echo test PVC, but again it is not going to work out, right? Why? So let me tell you the reason over here. Let me first remove this so it won't create further confusion. And rf dash mnt, whatever is here, we don't want permission commands to do. We are done. Good. And we do the exit. Okay, so on this point, okay, let me come out over here, and if you describe what we want to describe, pvc, come on. Okay, so here we have the pvc. So what's wrong over here? Okay, I told you a persistent volume, this concept is for long term, right? But when you have, if you have single node cluster, the concept I showed you, definitely it's going to work for you. Okay, there is no change at all. Okay, if you have multi-cluster, right, so it's the same thing, and which is defined over here. So volume, right, kubernetes.io is storage provisioner, and here we have a storage provisioner minikube host path, you could also see. So basically when it creates actual, or I would say the physical location storage, okay, where it stores our volume, right? So in that case, right, it uses a host path. Okay, and whenever you have a host path, so every time you get the different thing. Okay, so different thing, it means your pod is scheduled on different node. That's what we saw over here, right? Sometimes it is m02, m03, right? And these are our kubectl get nodes, right? So these are our nodes where the pods get scheduled, right? So it is done by the scheduler. But here the problem, this problem, because host path, and we already saw the limitation of the host path. These are best, or these are limited to the node file system, right? Because ultimately it is created somewhere on the node itself, and when pod gets scheduled on different node, then we are not going to have the same data again. So if you have single node, this concept will work. If you are using, okay, some external storage, right? So in production, actually we do like that, we decouple entire storage out of the cluster. So for that we use, maybe you are using on the GCP disk or AWS kind of out external storage, right? Or Azure, or maybe NFS or something, right? So in that case you don't have to do that. But in Minikube, so there are two possibilities: either I could delete or recreate a cluster with one node. So how will you do this thing persistent in Minikube? So one thing I told you in host path, right? That is a node selector. You could do that, and there is another way. Let me clear the screen first. And all right, so our pod has created. Okay, let's go ahead and do it once again. And kubectl exec. Let's do like this, dash it, and this is a pod, and inside this we will go to bash. We have our directories mounted instead of touch. Okay, let me do the copy pasting is again very. Okay, clear the screen. PVC, but we are not inside the directory. So say persistent and PVC text one, right? And we also want to see. Oh God. Yeah, and now you got something. It's a kind of performance pressure, right? When things doesn't go as you want, then you feel, oh my God, it's not working. Why it's not working? But I'm damn sure this is gonna be work this time. Okay, and Now, I mean, we already read this several times. There is no fun in this, but still, we would be having this one, right? Okay, so this time I'm gonna delete kubectl, delete the pod, and pod is PVC. All right, so this pod is again, let's see where it has created. So it has created over here, and now it's a new pod, right? YBM or something like that. If I go over here, persistent, we are here, and we should be seeing our file. So thank God file is there, and yes, our content will also be there. Okay, so this is how this work. So we ask, right, always create a pod on this node. So if you are using Minikube in your development environment, right, we are the people to saving a cost until your application go live. Did this I used this before? Yeah, it's not any shame, right? It's good to save money until you have something on it, but it's your choice. So I just give it the example. If you have something like that, use the file like this. Okay, so how? This one, I will, of course I will also put this over there. Okay, and we put this affinity. So this is one of the way. Another way, it's not selector, I told you. Okay, so try both. So that is your kind of hands-on or practice thing, right? You will be able to explore more, you will learn more, right? So try it at home under with supervision. Okay, it's very dangerous, don't do it alone. It's a we heard that in science practical. Once again, to make sure um, whatever I have shown it's working, kubectl delete pod is PVC, and yep, over here. So this time we will not go inside the pod. This time we will create a command. How we can create? And we have persistent persistent htdoc. Why I have given this long name? So PVC is there. Wow, pvc.txt, correct? And we can read the file as well. So we got the data, right? So this is how we do the claiming, persistent volume claim, right? We are claiming or we are using the volume, right? As long, I mean, now we have deleted several times the pod, right? Still we are able to get the data. But now the thing is how you can access these volumes, right, in Kubernetes. So we know in Docker we had a command, Docker volumes, Alias or Docker commands, right? That's how we see the volumes. But here things are other way around. So what actually happened? Let me tell you. When you create CTL, right? CTL get PVC, right? When we created this, it says status bound and this volume. So actual volume is this one. So how you check this? So to check this, you have a command kubectl get pget, not pget, kubectl get persistent volume PV. And now you see, right, is the same as what we have, and it says bound. It means when you see the status bound, it means your PVC get, I mean, created successfully and got the lock. Okay, we already described this one, my PVC. Okay, and here we have access mode, the same, right? Read write this one, and here reclaim policy is delete. So what it means, when you delete your PVC, okay, your, I will show you this as well shortly, your this storage, this volume will also get deleted, but we really don't want that, right? So that's why we have a reclaim policy. You can define it. Okay, you don't, if you want to recycle it like pen drive, right, or like hard drive partitions. Let's keep it simple, the pen drive, right? When your work, for example, you have made a bootable pen drive or maybe one of the Linux, your favorite distribution, and then later on you decide, okay, let's go ahead and try another one. So you format the pen drive, or not another one, you, if you need to use pen drive, so you recycle that, right? You don't just throw the pen drive, right? So here it means the reclaim the policy. So how we want to use this one? Okay, if it is free, reclaim it. Yeah. So we will see this more detail in Kubernetes administrator, because the PVs are actually physical location. Okay, and these are created and maintained by the admins. Okay, those who are Kubernetes admin. So it might be possible, or it may be possible, or it is possible there is a dedicated team where I work, in one of the organization where we had a dedicated team, right, for the Kubernetes cluster admins. Okay, so there my role was to Kubernetes application developer. Okay, and but I did both things, admin part later on. Okay, as I progress in my role, I also did admin part as well. Enough about that story. Let's come back to this point. So I was showing, I was telling about this is created by the admin, and now we are the admin because we are the owner of the cluster, right? So how actually we will see where these volumes are created, how we access the actual data. So for that, simple kubectl. So see, this command is very, very nice. You can use it with everything. Everything, it means all the objects which you create. So describe PV and PV. So I just put a tab, right, and it's auto completion did its magic. So let me clear a little bit this one and also this one, so we can see both the things parallel. kubectl describe PVC, and we have only one. That's why I didn't give a name, right? So I don't want to go into the events. Here we do not have any events, right? Nothing happened. And okay, so yeah, so here is a name, right? This PVC and this 1 2 3 or whatever string is there, an annotation host path provisioner identity, right? And here again the host path, right? This is the provisioner. So that's how we know, or this is the proof, right? I'm not telling a lie, right? We want to prove, right? It's not like I'm saying so you should follow. It's a proof over here. And one thing, right, it is the source. So where is the source? And you could also see the reclaim policy claim and who has claimed it. So that's why we created persistent volume claim. So claim will go over here, right? And path, it says like this. So my PVC and this path. And we know, right, what we know, we have created on this our DSOC3 -m4 node. So Minikube SSH dash profile. I have to type profile DSOC3 and I have to give it a name. Profile equals to the DSOC3 and 04. Yeah. And what happened? I have already copied this path. I copy it once again and let Alice. So you see actual your data is getting stored here. So this is the actual location, right? So though it's created in time, but still when our pod dies, right? We already saw this again and again, we deleted and still we are able to see that. And let's see the content as well. So over here, pvc.txt and the same content we are getting over, right? So let's exit again and kubectl describe PVC and all this. Okay, so there's nothing. I explained you several times. These are, so don't be afraid. PV and PVC. Okay, you create PVC, PV, the volume is automatically get created for you. Okay, now thing is, I was talking about kubectl get PV and PVC. So I was saying, like, if we delete about, I was referring this one, delete, right? Reclaim policy. So it means when I delete it, okay, when I will be deleting this, or I will be when this PVC, I'm talking about PVC, what we created. Okay. So when we delete this PVC, okay, and which is over here, one dash my PVC.yml. Okay. So I'm talking about this one, this file, this thing, right? My PVC, this one, persistent volume claim. When we delete this will automatically get deleted. Let's see in action. Kubectl delete PVC and my PVC, and we know we are not, it is not gonna be deleted because why? Because yes, because it is being used by the deployment. Kubectl delete deploy. Okay, and when we delete this, what is gonna be? So this will delete, right? So let me delete this one, and you see now when I run this command again, no resources found. Okay, so this is how you use volume. But maybe you notice something over here, right? So not one thing, actually there are many things, right? So what happened over here? Let me see. First thing, host path is this one. We don't want Kubernetes. I mean, of course we are thankful to Kubernetes, right? But we want this because we know whatever, if your node get restarted, right, we talk already in our day one Linux part, whatever inside the temp directory, right, when we have our, because it's a physical location I showed you, right? So when your system get restarted, temp, whatever inside you have in temp will be get deleted. So we want somewhere something persistent, right? So let's consider you have somewhere NFS server, okay, or you're somewhere you're storing any of the cloud, public cloud outside of the cluster, okay, but not in the temp directory, okay. So we have option, right? It's not like that Kubernetes always create PVC. So we have option, we can also create our not PVC, persistent volume, right? And that's what we want. And here another thing, this is a random name. I mean, yeah, of course it's a random name, right? Persistent volume. And it's really hard for us to remember if you are an administrator, and if and you have thousands, then how? But every time you cannot go ahead and describe and see, okay, which is, and I mean, of course you also have it over here, but I also need something meaningful name. So because it's a physical, so it should be named like, okay, persistent volume, let's say fronting, let's say. And if you have multiple database, so maybe it should be named like, okay, Postgres database, Mongo database, or SQL database, or whatever, right? Something like that. So how we would do that? So in that, we should be able to create our own, okay. And additionally, one more thing, when I created the deployment, okay, let me show you once again, right? So for that we have let me first delete everything, kubectl, so I don't want to again mess up, right? So kubectl delete, and I told you it's better to delete one.pvc.eml and volumes. Oops, sorry, not this one. Next file for that, volumes, and this one. Okay, so everything will be deleted, but it's already PVC deployment is not found. We already deleted, so that's confirmed. Now we are going to create our own persistent volume. So let's create our own volume. Okay, that is persistent volume, and we will create then persistent volume claim, and then we will claim that persistent volume in our deployment file. Okay, we will see this everything in action. And for that, I have already prepared a file, the YAML file, to save our time and to save myself as well. Okay, so first thing first, what I was referring, these are not in here. So these are in volume multi-node container. Okay, here, right? Remember, in this folder, we have volume, and inside this volume multi-node cluster. When you're following along, so you won't mess up. So let's open this file first to PVC and the deployment. But yeah, right. Everything is same except here I have given a PVC deployment, right? I mean, name is also same, and we are using the same, right, which we had before. But what is the difference over here? Here we did something different than before. So basically, I just changed the name to claim, nothing else. Okay, so we already saw how we use the claim. So we are since beginning, not since beginning, beginning of the volume part, when we are speaking, we're talking about. So again, this name should be the same, and this is the actual mount path inside the our pod or container. And here we are claiming to my PVC. Okay, and if we see more files, so this one is deployment to dash which one? Okay, PV. Let's open PV. This is our persistent. So this is our persistent volume, right? We have given it a name. Second, my PV. Okay, this is persistent volume, and we have given a storage class name. So here you basically define what you want to do. Okay, empty string must be explicitly set, otherwise default. So we are fine with that. We will explore this more, and here again the same thing. The storage access mode is also read write once, and persistent volume reclaim policy. So this time we are using retain, right? So here, this is not PVC, okay, this is PV file, PV. We are creating persistent volume, okay, and here we are saying where you want factual. So we want the path, MNT data. So here you actually define where you want to create. So depending on where is your actual volume, right? So if NFS or whatever, okay, check the documentation and go ahead and do accordingly. But this concept is applied to everything or everywhere, right? You have to create persistent volume, right? You have to give it a name, define storage class name, capacity, right? This one persistent volume reclaim policy. If you don't do this return, then yes, you will lose. So better it's to go this way. And we are using on Minikube, right? On local system. That's why we are providing local host path, and path is /mntdata. And it is going to be created on our NodePort. Let me go here and let me go over here and do the SSH. So again, Minikube SSH dash profile. Sorry, profile equals to DSOC3 and node equals to DSOC3 and M04, right? /mnt. So at the moment we do not have anything in /mnt, and that's why we are defining. So we should be having kind of name with the data, okay, right over here once we create it, right? And let's open one more file, and this is our two, not this one, and the PVC. So this is our persistent volume claim file, and here we have given a name to my PVC. Here I have this given a name PV, persistent volume. So you can remember PV is short form for persistent volume, PVC is short form for persistent volume claim, storage class. Okay, so yeah, it should be match, right? Otherwise it is not gonna work. You will end up with troubleshooting, but that will help you for sure. Okay, so before go ahead and change this or use this, so make sure you read the documentation carefully and accept the terms and condition, okay, because these are market risk. Okay, it's a promotion or something. I'm just kidding. Let's back over here. So again, read once, resource, and this one volume name. Here before we did not define volume name, so that was created, okay, on runtime dynamically by the Kubernetes, okay. And who has created in Kubernetes, right? So let me show you, why not. If I have anything, okay, I didn't split this screen. Okay, I will show you later on. Let me first explain this. Okay, so here important thing, okay, when you check this uh, file, okay, which is not inside this folder, okay, multi-node one, then you will not see this file over there, okay, except we just go ahead and do like this, okay, and we not like this, I'm just selecting this one, okay. So that's how we create uh, our own storage, and we are referring like this. And if you see right here, I have given a volume name which is similar to name given over here, and it must match, okay. If it is not gonna match, then you will find what happened. Play around it, okay, and do some things, make a different this name and this name, and one moment. So go ahead and create uh, and play around it, okay. That's your assignment, okay, or I would say that's your practice questions, exercise question for you, okay. But here important thing, here the same name, whatever name I have given it over here, I use the same name as a volume name, okay. And here if you see in, sorry, let's yeah, and here we define the persistent volume claim, right? So you could see over here one thing, I mean, of course, the same name to my PVC, and this is the same, right? So this claim consumes volume, and that's why we have to define what or where you want, or which volume, right? Or which, yeah, which volume you want to, are you claiming for, right? So we have to inform into Kubernetes, okay, we are claiming space of this volume, right? And here in this file we define, okay, the claim name is this one. So what happened actually here, we have completely decoupled. So let's say you, like, you have tested on this host path, right? And later on you want to change or move this volume, right, in a cloud. So what happened, you really do not have to make changes over here in claim name, right? Because claim is always, because you have moved this to somewhere else, right? Or anything happened, right? So always you're referring the claim, okay, and being an administrator, and that is more admin task, but still I'm just explaining you. So that's how you decouple, right? So whether regardless, so let's say MNT data and you mount it initially in on NFS server, and later on you mount it somewhere instead of on-prem, maybe in cloud somewhere. So you really do not have to make changes in your deployment file, okay? And that's how it works. So that's how we decouple the entire data management from the cluster. And that, isn't it amazing feature? Definitely, if you have cloud account, go ahead and try that, okay, once you are done with this thing, okay? So I really don't want to end up with paying a cloud bill, okay, except for returning. Kidding. I will definitely explore this later on, and I will show you how you can use in different um, cloud vendors as well, okay? Mostly this popular one or widely used, right? So let's go ahead. It's enough on the all this files, and if you have further questions, let me know. So I quit all, and now what I'm gonna do, okay, I'm not gonna just apply this file here. I'm going to explain you very important concept, okay, and you must pay attention, okay? So let's go back over here, kubectl apply, and sorry, not this one, to dash, sorry, again, I forgot. Clear my screen, kubectl, I will start over, fresh, kubectl apply dash f and to dash pv dot deployment dot yaml. Okay, so let's apply this, and let me also check file is correct or not. Let's do dash pvc dot deploy. Okay, so we are good, right? So this has happened, we have deployed, and yeah, again the repetition is the key of mastery. Kubectl get deploy apps, and again it's a pending, right? So we know what happened, right? What happened over here? So instead of deployment, we know we have to check pod, and of course pod is also pending. So let me quickly describe kubectl describe, not describe, describe pod, and this is the pod name. Okay, and this time we saw something different. What it says, persistent volume claim. So what difference? Of course, it was before my PVC, right? So is the same. So when you create deployment, right, it, so what is different? So the difference is what I'm going to explain now. So it is looking for, right, if I do like this, it is looking for the persistent volume claim, okay? So what it means, so it means before creating your application, your deployment, okay, or pod or whatever, your PVC must be available, right? So let's do one thing, apply our PVC. So kubectl at PVC, we do not have any PVC. Kubectl apply dash f and 2 dot pvc dot eml. Now if I see, of course we have PVC to my PVC, right? Now if I see again at pods, so it's still, it is pending. So why it is pending? Let's describe. So pod is still there, right? It is not, you could see the same pod, or if you want to, let me again do it like this, or yeah, so it's still 2 minutes 23 seconds ago, even though we created, and well, it's a 4 second or something. So even though we created PVC, but still it is saying what nodes are available, pod has unbound immediate persistent volume claim. Before it was persistent volume claim not found, but at least now it is found persistent volume claim, and the message has changed. So what happened? Let's explore in over here. So let me use this screen, kubectl, or maybe let's stick with that one. So kubectl describe. Okay. Kubectl describe PVC. Okay, and second PVC, that's we are interested in. And what happened here? So here the status, okay, or simply if I run like this, kubectl PVC. So I told you before, right, about the status. So status is pending, and here we are not getting any details what it's saying in the event, right? But it should give us some details, right? What we have done, get. Okay, so what happened actually over here? Why it is pending? So it says, of course, used by in all this event, but we did not get any of this, right? So you are not able to see the event. So where will you see the logs? I will show you later. Hang on. But here, what happened actually? It's pending. So it's pending. It means it is looking for what it is looking for. If I go over here and open the pvc.yml, so it is looking for volume. Okay, last time we did not mention, that's why we got one pv, right? And this time we do not have any pv, so it is looking for 2 or 2 dash my pv persistent volume that is not created. So what I'm gonna do now, I will get what, and let's watch this what happened when we create kubectl. And here is the pending, right? Kubectl get, not get, a y dash f 2 dash pv.eml. And now if we see kubectl get pvc, so let's watch this as well. What happened? It is pending, right? Okay, so status has changed, it is running, right? It means, and here it has changed. Let me make it like this. So before it was pending, now it is found. And where it has found, okay, it is still not showing up. Sorry, it's here, volume. Sorry, my bad. So before it was looking for this volume, and volume was not there, right? And now it has got, it says bound, and that's why we have this one. And this time, let me clear this screen and let me describe the pod. And pod is PVC. Okay, fine. And let's see it over here. And you could see, because yes, it got, right? PVC is already found, but PVC also attached with the volume, and after that it has scheduled the this one, right? Now the thing is, let's see what happened. So not this one, here, over here. So this time we got the data, right? And we do not have anything inside the data folder. So let's go ahead and quickly see. And so kubectl get pods, right? kubectl exec-it and pvc, this one, bash. Okay, and inside we should be seeing some persistent data. Yes, we do have this one. And inside I simply create a file, nothing. Okay, let's do it like this. Echo, not echo, echo. And what we want to do, test message. This time we will do only one message. Okay, and pv and not and pvc, right? All right, and this time we will give it a name, pv.txt. All right, let's see now what do we have. Still, let's go like this, cd dash docker, no, not docker, mnt inside data. And now we are not able to see it anymore. No worries. All right, so I have created, I think, wrong place. See, that's how it's better to verify. Okay, now we should see, right? Cat not city. I did not set any alias like this. So test message pv and pvc, right? And quickly exit this kubectl, delete part, and part is this one part. It is deleted. and we know it's again recreated, right? And now the pod name should be different, right? And I can write this, I mean read this echo. What was the file name? pv.txt, right? And it's still, if you see, right, it says like this, okay, and the content has not changed, right? It's still there. So let's give change the content this time just to see. Okay, it's not the same one, right? And message is second message, and this time I'm very much careful, don't want to lose any of the data, right? And kubectl delete, oops, part, this one deleted. Now I will go inside the container and we will write, not write, we will read it from over here. Command cat, and where it is this? Not over here, it is still there, but let's see, do we have this one? Of course it is updated, right? Cat pvc. Why don't we have second message? Okay. Okay, let's see. Come on, it should not be happening like this. So I think again. Oh, okay, sorry, so my bad. Verified it over here. I forgot to put the name, right? Name of the directory. Let's go ahead. I'm sorry about that. Persistent, right? And pv.txt, and here we go. Now data. Okay, now we have message. Exit and delete this pod. Done. Deleted. Then X. Okay, and then we'll run this cat and cat. I want to read this. Okay, persistent. So that's how we have this thing. Okay, so here the final point before creating your deployment, right? kubectl get all, right? pvc, all these things. So we can, so before creating deployment you must have your pvc, okay? And creating a pvc you should have pv. So of course when we want to save data, right, for example if you want to store your data in pen drive, so you first buy the pen drive, you don't think, okay, or you don't imagine I'm putting my data on that pen drive that is available in that storage, okay, 1 petabyte of external hard disk. So you don't do this, you first buy that. So similarly we have to create pv, okay, that is a volume, persistent volume, okay? Same concept, the name is different, I mean same, it means don't take it literally, volume concept, but this is the difference. So pv is actual physical location on your cluster. I mean not your cluster, in our cases it is in cluster, but in production we don't, production I'm referring, okay? So we don't use the node, right? We use external storage, right? But if you see, when I say kubectl get all, I didn't see the, I only got the information about, okay, pod and the deployments, right? And replicas. So we do not get the information about pvc and pv. No worries, kubectl. My bad again. So yeah, two things, right? And so now it is the sequence, right? First, let me put it like this here. So you should have first pv, okay, and once you have the pv, right, then create pvc. Once you have pvc, then create your deployment or pod or whatever, okay? This is the sequence, and I already explained you the sequence in very detail, right? How or what happened when you, of course the pod was pending, then we created, because it was looking for pvc, then we created this pvc, and what we didn't get, the bound, right, this one, right? So that's how you play around, right? So let me exit this one. Let me come over here and let me clear this thing, right? And yeah, so this is about the PV and persistent volume claim. So remember, don't be confused. These are very simple things. Whatever I have shown you, just go ahead and repeat it 1, 2, 3, 4, 5 times. You will definitely get a grip on this. Okay, don't think it's a confusing, okay, or it's a complicated. It's very simple. Follow steps slowly, step by step. Don't fly. Give it some time before flying. Okay. So now I'm gonna delete everything, and I mean, of course, this is one of the way, right? We can use, right? What use? Sorry, while I'm talking, I always forgot this. So I need to learn parallel processing so I can do more productive things. So I was saying about this is the volume. So this is one of the way you can, when you have so in this we have learned empty dir, host path, and persistent volume, right? And when, I mean, this is one of the way you can share the data among the containers, right? But this is not only the way, or volume is in the Kubernetes. You can use volume for other things as well. Okay, and what other things? So config map. Okay, and that is our next topic. So let me clear my screen and we head back to, not head back to, head over to. Okay, so let's move on to next topic and we will see what's config map, all this about the config map. Okay, so let's now understand config map, right? Before we create, what config map is. So config map, in as per my understanding, in very simplest way of explanation is to, this is a kind of object, or this is one of the object in Kubernetes, right, which provides a facility to decouple your configuration of the application from your code. Okay, so whatever configuration you are putting in, let's say for example Nginx web server, right? So you have to put some config, right? If you have SSH server, right, maintaining SSH server, so you have config file for SSH server itself. Similarly, application also have the configuration file, and for that, instead of putting it inside your application, and whenever you need to make any adjustment, you making that, instead you put that or decouple that out of your application code or whatever application you're using, right? So it makes management more easier. So instead of explaining you in more theory, let's go ahead and see in action. So here there are two ways, which is one of a very common way. So you use config map as environment variable, right? So when you have some use cases, right? You're, so like when we created container images, right, in our day 5. So we saw in that we can also define some of the environment variables, right? When we need, or when while we are creating a Docker image. So similarly, here you also have option. You could, instead of modifying or creating images, you could set environment variable using config map, and directly you can call those inside the box. Okay, so let's first see to config map deployment, right? So here, this is my deployment file. I mean, so in this deployment, I have just given a name env, okay, as an environment config map deployment. Rest everything is same. We have discussed so far. What is different? What's the difference in this file? So here we got new things, okay, and these are the new things. So just inside the container section, right, in spec containers, and in that we are mentioning environment, right? So environment variable name. So in order to define this, you have to put this one env colon, then here you could see this one, right? And again you have next variable, third variable, like I mean environment variable. So here you have environment variable one, env underscore var underscore one, and it says value from. So we are saying it, okay, value from config map, remember, okay, value from. So we have defined, I mean, we have mentioned over here which environment variable we want to use, env underscore var underscore one. And we also have to define or let Kubernetes knows where is the value we are referring to this, right? So value from, we use this is under this, and in under the value from you have to mention config map. Okay, and here it's saying key reference. So for this key, okay, we need a reference, so config map key reference, right? And after that we have to give it a name over here, my env config map. So whatever config map, the name you have given to your config map, same you have to provide over here. And here you could see, I mean, of course this is an environment variable name, and here is the key, right? Environment variable 1. Similarly for second, env underscore var underscore 2, value from, then config map. Okay, it just start with a small c, m and k and r. After that all three words have capital R. Okay, so always keep in mind config m capital, map key capital, key r caps, ref, config map key ref, right? And value from, might be so far notice this first letter is small letter, right? Then we have to give the name config map key reference, so we are referring this config map, right? And key is over here. And similarly for this one. Okay, so let me open the file, then dash config map dot environment, right? So here if you see we have the, I mean, this is our config map environment file, so we are going to create this very soon. But before that, let's understand this. And here we have API version v1. So in part 1, right, when we talk about YAML syntax formatting, right, in that part I explain you how you can check it. So I given you two commands, not QPI, kubectl API versions, right, and kubectl API resources. So go ahead and execute this command. So as of now we have this one v1, right? Kind is config map metadata. Here I have given a name, my env config map here. And same if I come back over here, so my env config map, right? So see, and you could see the name is same everywhere. Okay, so that's why config map eraf, so we are referring this config map, right? So, and if you see here the data, so in data it means these are the key value based thing. So here I have defined environment 1 and value 1, environment 2, I mean environment variable 2, value 2, environment variable 3, and it's a value 3. And here we set key is env underscore var1. So whatever this is environment variable, for this key is this one, and we have the value over here. So you see, you may notice over here we are not referring the values, we are referring the keys. So that's how you decouple, right, configuration of your application. So instead of hard coding the values, right, instead of these values, the Kubernetes dynamically fetches it's a value. Okay, and here we just mentioned the key, so whatever key is here, so this one is key, this one is value. Okay, when you do practice your own, just put as a key underscore env var1, and same you may put over here. So I'm sorry I put the same name over here, probably I don't know if it creates confusion, so, but I'm explaining you, right? This is the name of the variable. Okay, this is the value from, and we are referring, and we are not hard coding this value. So that's how we decouple. Not we, I mean, Kubernetes provide this facility. Okay, instead of hard coding values inside the application or container, okay, Kubernetes lets us reference keys in config map. This approach is very effectively decouple configuration from the code. Okay, so let's see, and it's very much simple. Okay, let's go ahead and deploy our deployment, or create our deployment, or apply our deployment. Open dash map dash deployment, right? So here we go. We have done, we have created deployment first, and let's see, kubectl that yeah, still got deployment. So again the same thing, and now we know, right, we would also have the replica set, right? But we see the pods, So here, instead of pending, here we get something different. Create container config error. So let me open it here. So kubectl, and we use this screen. Kubectl describe pod. And we have already this pod. So of course, see, directly we have to jump to the here, right? Here, what happened? Successfully assigned default this one to the SOC3. So this is the node. So pod has schedule, right? It was no problem at all for scheduler. But here, if you see, right, so we do not have error, we have warning, and it says failed. So reason is failed. Here it says config map env, my env config map not found. So it is looking for config map, right? And it didn't find any config map, right? So let's go ahead and use it over here. So for that we have command kubectl get config map, and as I say, we do not have any config map, right? So we have to create config map over here and clear the screen. Now it's better. So kubectl apply -f one -config map, and now config map is created, and soon it may take a little bit time. Yeah. So of course it's the application does not have so many other things. Okay, but yeah, containers are usually faster. So our now pod is running, right? And let's go ahead and see our config map. So here we have my env config map. Let me clear the screen. Kubectl describe config map. Okay, and which config map? So we want my config or my -env config map, right? If you don't give it name, it will explain everything, and that's how it looks like, right? You have the name, and namespace is default. I did not put anything over here, right? That's why it's showing none. In data, so here you could see env underscore var1 value 1, and whatever we have defined in our this file. Okay, config.yml. So you could see, maybe you could open it over here. So here we define under the data, right? Here you may notice we do not have a spec, right? Here we have data. In data we have defined, sorry, I missed that to explain you. So here in data we define the environment variable. Okay, so here we define, and here when we create it, it looks like this. Okay, here the environment variable, and it's a value. Now it's time to see whether these are available inside the container or not. kubectl exec -ip and pods. This is the pod. Okay, so bash, and I'm in, and we talk about this one, right? This command in day 5, how we can check the environment variable. So this is the way we can check the environment variable. So here you could see env1, and all these values are available inside the pod, right? There is of course if you don't want to go in this way, you could simply also execute this command. Right, here we go. We also have, so depending on your use case, okay, when you have to define some environment variables, so you could see there are predefined, right, like path, host name, home/root, whatever. Okay, we will see how you find. Okay, so one thing, these are the custom environment variables, something when you create the image, right? At that time we saw already in day 5 how we can set up our own environment variable while we create the image. Okay, so this is the way you can access the config map inside the pod as a environment variable. But one thing here I would like to show you before go ahead and see next demo about the config map, right? Edit config map and my in the config map. So you could see over here, right? It says data. So it is as it's here as is. The kind config map metadata, and in metadata we have annotation, and now you easily see this annotation, right? Last applied configuration, and you can quickly say, okay, this resource, or not this, so this object was created, right, using kubectl apply command, right? So this is one of the interview question, right? You can check the configuration was created, so simply describe it, and in annotation part you could see this one. Okay, and here you could see the name and the details as well. So this is one way to use a config map. Second way is to use as a volume, right? So we already saw how volume works, right? So same volume concept is over here, except here you are entire your config map mounting that as a file in the pod. Let's go ahead and see how we can use it. So for that, consider your configuration file, right? So environment variable is one of the way, which is simple. But when you have, like I mentioned, web server, SSH server, or any kind of other, or maybe your application has some custom configuration, right? And you're storing that in a file, right? So in that case, instead of using environment variable way, you can use the config map way as a file in a pod. So config map can be mounted as file inside your container. Okay, so which makes it very easy for apps, okay, that need a config file. So how we do this? So for that, let's first see config map file. So in this, what I have done, okay, so I'm gonna create config map, and here in metadata I have given a name, my volume config map, and in data we define our configuration, right? And here in this case, so as I say, whatever you mention over here, we will be able to see in the container. Okay, so this is the key inside the config map. Okay, so representing a file, right? And after that we have this pipe symbol, right? So the pipe symbol is used in YAML to indicate that the value will spawn multiple lines. Okay, so after that, everything after this, okay, or everything below this line is treated as the content of the file. Okay, so preserving the formatting, right? So that's why we put this line, so everything will be considered as a multiple lines string. Okay, so here I have given like this http, this one, this one, this one, and this one. So we will be able to see this output, right, when we have the deployment. So that's how we create config map for a file or from a file. So you can also use command to create config map. Go ahead and explore that. Okay, that's a direct command, right? And here the thing is, I'm explaining you via the YAML file. Okay, so we split again, and not one second config map deployment, this one, right? So if you see the deployment, right, so we have given a name, volume config map deployment, right? Rest all these things are same, no change. What is different? So we are using this config map file as a, I mean, we are mounting this file inside the container, right, using the volume. So you can mount config map of the file because this file can be bigger, right? This is one of the way. In my experience, there are more places where you could there are more ways, right, or more use cases for config map, but these are the two most frequently used, right? So whether you use config map, okay, to create config map out of the file, right? So in this which we are doing, and then we will mount this config map inside the our container. So you may see over here, right? Here volume mounts name nginx config volume mount path. Okay, till here is the same. So this is the path where we have nginx config inside the container. Okay, and we probably already know, okay, where is our configuration of the application. And in Linux Day-1 we already talk about the directories, right? So when that I explain you, etc is the directory where we have all the configuration. Okay, so very simple, etc nginx.conf and subpath custom -nginx.conf, right? here volumes, and here the name is engine x config volume, engine x config volume. Okay, and inside that, so before we are creating, I mean we are mentioning what kind of the volume it has, whether it is emptyDir, hostPath, or PVC, or whatever, right? So we were explaining, we are mentioning over here, but here in this case we have config map, right? So we are just saying, okay, this is one of the volume, okay, and which kind of volume? So config map, and we know my vol config map, my volume or vol config map. Okay, this name are same, right? Because of ultimately we are mounting this, right? And here we know this name must match with this name. Okay, and this is our path, right? And here if you see subpath, right, custom dash engine x.conf, so which is over here, right? So that's why I said this is gonna be file name. And what is subpath over here? Okay, so if you don't mention this, yeah, it's okay, still it's gonna be work. But when you have subpath, okay, so actually what we are saying over here, so when we use subpath, okay, which ensures that only this file, okay, is taken from the mounted volume, okay, then the mounting the entire config map directory, or in other words, mount a specific file instead of the entire volume. So we are informing, okay, out of this volume use only this file, okay, don't touch any other thing, consider like that. Okay, so this is how we mount the config map. So first way, environment variable, second way as a mount. So we have this location, right? And here this name, my volume config map, this should be in same. This is the file, we will see this shortly. Let's create this. So let me quit all this, or maybe why should we quit it? So let's quit cd case and the config map, right? And kubectl apply dash app, and we have file over here, right? So file, which one is 2, right? So first we create config map volume, and we will also create a deployment. So both are created. kubectl that config map. So here we go. Instead of getting, let's describe this. Describe config map, and we are interested in this one. So here you see data, and inside data we have this is the key, right? That's why this is the column. Okay, in config map, first is key and the rest of the values, and to define a value we use this pipe symbol, right? So this is the key, and this is the our data, right? So it is as is over here. Now, right now what happened, we have configured this. Okay, so when we access Kubernetes, I mean not access Kubernetes, we access the nginx, right? Then what happened, we see it's a default page. Now we have overwrite or overwritten the configuration. So instead of seeing that default message, we will be seeing this message. So what happened, how we can see that here, and let me quit all and kubectl add pods. We have this pod which is running. So let's go ahead and first see inside kubectl exec-it, right? And this is the pod. See this. Okay, so this is over here, etc nginx and nginx.com, right? This is a file over here, and you could see this file is overwritten, right? One more thing. So this is the way to see inside the container, how we will see the outside of the container, right? So for that, very simple, what we have to do, we can simply port forward, right? So how we can port forward, so there is a command kubectl. So first to do that, so far I did not tell you how you can access the pod, but we will see other ways as well. So I think it is a time to introduce you with port forwarding. Okay, and for port forwarding, what you have to do, so you have to provide ports, and our pod name is like this, and we want to access this on 8080, right? So by default nginx listens on 80 port, but we want to access it on like this. Okay, so that's why, let me clear the screen. So kubectl port forward for ports, right? And we want to put forward for this port. Okay, and on server you do not have browser, we will also see on the browser, okay, when we coming on the service part. Okay, but let's say you are doing it on server, right, where you do not have browser. You might be say, okay, I can install a text-based browser and see. Okay, but when you do not have any access, then what happens? In that we have command curl, so simple, and we have forwarded it this on localhost, right, over here. So it's local host and port I want to access 80, right? Or simple, I show you on this screen clear. So you could see the same message, right, which was over here, hello from ConfigMaps, mounted as a file in a pod, the demo in Kubernetes environment, right? So this is the way, right, we can use, okay, the configuration, I mean, mounted config map as volume. Now, so we, as I initially mentioned, we have decoupled the configuration. So it means we really do not have to make any changes in our application pod. Okay, so our pod is still there. So what we can do, we can create a, and we can update the configuration. So that's what we do in, for example, in our application configuration has changed, right? So it could be anything. So let's consider we have to change the configuration, right? And configuration, so let me open the two config my volume dash, okay, and this is our this one. So what I will do in this, let's insert, and I just put a new line character, not like this, like this, slash n, okay, and this time I save it. So now let's update our configuration. Let's apply dash f and 2.volume, right? So it says configured. Let's confirm kubectl describe config map and volume. Yes, yeah. This is our, so what we have done, we have just put a new line character, okay, and if you see over here, right, we are getting out over here, there is no new line character. Right after that our prompt was here, so we have made a change, right? And to now let's check. Okay, now configuration has updated with this one, we could see over here. And if you don't describe, instead of, if you run this command, the screen keeps here, let config map my wall config map, right? Then oh yeah, this is also the way, right? So our config map has updated, correct? Now, so we said we really do not have to make any changes, right? So let me do the local host. Okay, so our service is still forwarding, forwarded on the same port, right? kubectl procs. So this is the same one, right here. And now when I curl it again, so what happened? It's not, I mean, of course we update it, but pod doesn't pick it up. So what happened in this case, whenever you make any updates in the config map, so restart is required. Okay, so Kubernetes does not automatically update running pods, okay, mounted config map. Okay, pods I read the config map when they started. Okay, so only changes won't be any changes won't be reflected in the existing container. So what we have to do, we need to restart our pod. So restart means simple, right? We can delete this. So one kubectl delete pod, and this I already showed you, right? But this is not a recommended way. When we started to show you some of the things, I just did this manually. So let's do it in more sophisticated way, okay, or more better way. Of course, you can delete it and you can check it, right? But we have different. So we deployed this as a kubectl get, sorry, deployment, right? So here we have we deployed our application using a deployment, right? So what we can do, and we learn in our deployment section, we have option rollout. So to restart your pod, kubectl rollout restart. Okay, so thing I could do over here, let me put it like this, and instead of this we will here kubectl add paths and kubectl deploy. So, okay, we want all deployments, we want ReplicaSet, fine, and we want to watch pods. So kubectl pods wsp, a simple watch w, right? Now we are going to, yeah, using that feature, okay, kubectl rollout, and we want to restart the deployment, right? And our deployment is volume config map deployment. Let's do it. And now you see, okay, it's set completed. It means new pod is running, and you could see it right over here. And if you see, right, so now let me close it and get something else. So this one, kubectl get deployment, so you could see this name is the same as what we have before, right? But what has just changed? Kubectl get ReplicaSet, right? And now you could see here, this was the old ReplicaSet, okay? And now new, as soon as we restart, we got a new ReplicaSet, okay, where it says desire is 1, current is 1, ready is 1, and 35 seconds. So similarly, we also got new pod, you'll get pod. So when you restart, right, so deployment rollout, so it restart your pod, right, created new ReplicaSet, and ReplicaSet created new, ReplicaSet created this new pod, okay. That's, we already discussed very detailed when we talk about this deployment section, right, or deployment object. And here we have option, and how why this is nice, right? So kubectl get kubectl rollout, right, and we had this option history of the deployment and the volume. So you could see now you have revisions, right? So if some, for example, you did some updates in config map, okay, and nothing come up, so very quickly you can simply roll out undo. So instead of history, you can simply say undo deployment, and now your deployment has rolled back, right? But again, let's do it like this, okay. And now let's again check. So of course, we don't see anything, we again have to port forward the pod, right? So on this screen, let me do it again. So this pod is not anymore, and this replica set is also not anymore, but we have deployment and this pod, and now we have port forwarded. And if I run like this, so you could see the new line was applied, that config map was picked up, right, and it is, which is in effect. But if I do undo the deployment, okay, and let's see where is the history, right? So we have 4 and 5 again, okay. But if you see, so if you do undo, when you roll back and when we come over here. Here you will see empty reply from the server, right? So what happened here? So again, let me see, we do not have this, so we do undo, new port has created. So when we go back over here, so we could see, so when you do this one, I mean, when you restart the port using rollout, it really doesn't touch your config map. Okay, so don't think when you restart port or when you roll out, then config map will be changed. If you need to make any changes, you have to make it manually. Okay, and for this, there is a file, okay, which is already created, to dash volume dash one. Okay, I will update like this, less, and here I have put the slash n. Okay, so let me open this file again to config map volume, okay, and remove this one. So when you do practice, you will get the same thing. All right, so this is the way we can use the config map as well as the environment variable. I mean, config map as an environment variable and config map as a volume count, right? So these are the two most common way you will definitely get across. Okay, now next thing, so this is one thing, right? Next thing, this is about the environment variable, but sometimes we also have some sensitive information, right? We could not, or we should not directly mount like in this one. Let me open this like this one, right? Config map dot English. So here, let's say this is your username, this is your password. I mean, username, password is password, like that. So those kind of information we don't store in config map. And for that, we have another object in which is called secret. So let's go ahead and see that what is secret and how we use that. Okay. So first, let me clear everything that off. So we have this many kubectl delete deployment, okay, env and volume. So we have deleted both, and right. So we do not have anything. Everything is clear. Now let's understand the secrets. Okay. So for that we have one, right, and inside that we are going to create our secrets. I mean, it's not inside that, using the files which I have created. So first thing first, what secret is. So secret in Kubernetes are similar to config map, but are used to store sensitive data, as I said, such as password, tokens, keys, etc. So unlike config maps, secrets are base64 encoded, okay, and their content are not directly visible when inspecting them for security purposes. So if you check out the official document, I will put the link right with the resources section. Okay, so the secrets are used to put sensitive information which are not directly visible, okay, and they are encoded as base64, but these are not encrypted. Anybody who can get secret, right, can get the secret values and decode them, and they can get the information about the secret, right? So there are so many ways you can perform. So let's first see this in action, right? And as I say, secret is in Kubernetes are similar to config map, and if both are same, then we have the same way to use them. So first way is to secret as environment variable. We saw how we can use config map as environment variable, and we also saw config map as volume. Similarly, for secrets can be used in both way. But there is one more thing. There are some different type of secrets. So we are going to see which is most commonly used, and we will also see later what are others as well. Okay, so here let's see first the secret file. The first secret environment, right? This is my environment file, and this, as I said, this is base 64 encoded. So let's first understand how we, let me do a thing so we won't confuse where we are. So we are here, right? Clear the screen. So this one, it is also on this screen. We'll go right. Okay, we are at secret and less one dash secret.env. So I said these are best 64 encoded. So how best 64 actually works, right? So it's very simple. For example, let me show you what this value is. So it looks like this. Okay, instead of, why not we use Vim, right, which we have better visualization. So I have this value, right? So let me first show you how we decode this. So you simply put echo this value, right? And then s64 dash dash decode. And you could see the admin. When I have to make this as a best 64 encoded, so what I will do, admin colon best 64. And you will see I got the same value, YWRTA and W4K, right? So similarly, you this is how you decode best 64 and put this value in your YAML file, right? Similarly, when we have this one, so let's decode this one. So for that, I will say echo with this pipe symbol, and of course these are best, not best 64. So we have to use the same, and yeah. So if you see, we have decoded this. So if I want to do it again, so what can I do? Like this secret, right? And in secret just pipe it to the best 64. Okay, so I got the same value. Let's check this, C2VJCM V0CG and equals to equals. So that's how you encode and decode. So this is about the best 64. And as I said, when you have this value, you know, I mean, it's everybody knows, right? Those who are who know Kubernetes, secrets are best 64 encoded, right? So that's why. But here the purpose is when it is exposed, so it is not directly expose the value, right? When you open it, so if I close it quickly, right, so you, even though we have just decoded, still we are not able to remember the entire string, right? But we know admin and secret, these are the more, we once we read it, we can remember it. So this is the purpose of using a secret. Okay, it is not safe at all. If you, I will post the documentation, read that. Okay, but we will learn that later in our Kubernetes certification trainings, right? So this is our secret file. Next thing we have here, which is deployment file. One secret deployment. So first way, right? So here I have just given a name, environment. So I'm gonna use, and I mean this secret, okay, as an environment variable. It's very simple, same. Okay, that's why I said secrets are similar to config map. So what we are doing over here, if you see, right? And yeah, okay, so now it will be more clear. Here we are calling secrets as an environment variable. So you now see, in before I have a key value and the same key was used over here, so that was kind of confusion, but I explained that. But still here it's a different thing, right? Here, first of all, if you see here, API version, kind, metadata, name, type, opaque. Okay, so it's a more common way to create general secret. You can also create secret using a command. That is very simple, but I'm not gonna do that. Try, go ahead and explore. But here you could see the data, and after that data, it's a key and it's a value, and value is best 64 encoded. Similarly for the password, right? We have it over here, and if you see here, I have given a name, environment variable as a username, same value from, right, secret key ref. So there we had config map key ref. Here we have secret key ref, right? And name, so we know this name should be same as we have over here, my env secret. Then key, okay, and we need a key, so key is username. So this key should match, must match with this, because ultimately we are referring this value. Okay, and here the password. So here this environment variable we define for the our container, right? And you see the key is password, and that's how value from. So we are Kubernetes will dynamically fetch secret and the key ref. So it in this section we mentioned from where it has to fetch the secret, right? So my env secret and is the same as this over here. Okay, and then we have a key, and key is the password, this one, right? So now we saw this, how we can call this, where how we can create this, and we already saw this in our config map section as well, right? How we can use as environment variable. So let's quit all. So let me first create ctl apply -f secret env deployment. So we created deployment, and now kubectl get for, okay, and it is config error again, right? So now you can describe it and you can see why error. So it does not have a secret. So let's create a secret. One dash, oh, what happened? Oh, okay, I missed this one, secret env, and so now our secret has created. Let's go ahead and see this. Get, not get, describe. And if you see, before in config map we were able to see under the data the values, right? But here we are not able to see. Here instead of it's just showing the key, it's not showing the value. But what happened when I do something like this? Kubectl get secret, simple, sorry, secret is this one. Now let's see YAML. So here you could see, right? If you go or use edit command, you will see in different way. So this value, password and username, okay, both are same. Right now I can grab this and I can decode this, and if you want I can decode this like this, S64, right? And sorry, dash T, up, sorry, not 63, okay, the secret, right? And similarly we could also have like this, copy username and put it over here, so admin, right? Very easy. Okay, so this is how you use. But as I said, this is just for not exposing the secret, right, directly, and that's why we have this one over here. So we have seen this, and also one more thing. Let me show you one more place. kubectl, but because of course we created a secret, but let's confirm whether it is mounted or not properly inside the pods, right? Pod, this one, and we can simply use env, and here you go, username is admin and password, right? So there are some ways by which we can restrict. I mean, in case of course we need to, but nowadays we have so many other features as well, right? But still, in case if you need to use, then how you can restrict? So you can restrict using this one, right? So how you can restrict kubectl get secret. So nothing happened over here, but when you execute, right, kubectl, so you can restrict who can execute this command, right? So, and you can also do the encryption in rest of your etcd database. Okay, ultimately these are going to store in etcd. Okay, so those are the ways. We will see those in when we start administration training part, right? So this is the one of the way. Let me delete this one, ctl delete dash r, and one secret env deployment. So let's deployment is deleted. Now we have another thing, and another thing is secret as a volume. So let me quickly open the both of file, and we have this files, two secret volumes, and yeah, right. So this is our as a volume, right? So here what I have done here, the volume secret deployment, right? Rest everything is same except the name has changed. What other things are changed over here? So if we go all the way down, right, so we know how we mount, right? And we mount string again using the volume. This is our volume nginx secret volume, and this is my env secret. Okay, so that's why I do not if you see over here kubectl get right, so my env secret is already there. When I deploy, when I create deployment out of this YAML, right, the pod will directly come up because this secret is already there, right? So we know how we mount. Okay, so simple volume concept is over here. We know this is the nginx secret volume, which is over here, and instead of config map this time we have to mention secret, and in secret we have to mention secret name. Okay, and this is my secret name, right? So you can share the secret multiple pods as well, right? And here if you see mount path, so /etc secret, and I have provided read only true. So we just provided a value as a read only. Okay, so let's go ahead and create using this file kubectl apply -r2. Okay, so deployment is created. Kubectl get pods, pod is up and running. Kubectl what next? So let's go ahead and see over here, right? Kubectl get not get exec and here we have to give a new pod. Okay, and here we go bash. Okay, and simply here if we see /etc, okay, we have somewhere secret, and here like this. Okay, so actually these are the link, but yeah, soft link, right? But if you see these are, but these are as a file, right? So these are created as a file. So when if I want to cat etc secret password, so here these are readable inside. Okay, and ultimately of course we have mounted over here, right? And that's why this application has to use it. So secret admin, right? That's how you mounted your secret as a volume. So these are the two ways to you can use your secrets. Okay, one as a environment variable, second one as a volume. Okay, mounted inside the pod, right? So let me show you one more thing. Okay, here I have just showed you two demos, right? In two demos, one I showed you, I have shown you, right, how you can use secret. So secret as a environment variable, secret as a volume. So let's take one example. So let me first see what we have. Serial get all. So let's delete this serial delete app dash this one, and serial delete dash f, and which is here one. Right. Now we can check this still get secret. Okay, so no resources found. Okay, and kubectl get all. We do not have anything, all clear. So what I would like to show you over here is how you actually use this in your real application. So for that, I'm taking an example of Postgres database. Okay, let me show you. So for that, we have two things over here. Mim -o, then we have 3 and 4. Right, in the same secret folder, we have these two files. We open both. So what I have done, let first see. Okay, so this is our Postgres. Okay, in Postgres, right, we have metadata. Right, so let's first talk about the deployment. So here we have just given a name, right, replicas, and now I put everything as this. Okay, so which Postgres means, which means what. Here selector, right, labels, so what this means. Okay, so don't be confused with this name, right, with this one, with this one, with this one. And our container name is Postgres, and images we are using, it's the lattice. And now Postgres user, we are using this as an environment variable, value from, so we want value from secret key reference, name is Postgres secret. Okay, so and then this is the key, right, and again name, right, Postgres password, this is the next environment variable, right, and here value from secret key ref, and the name of the secret, right, and the key is Postgres password. So we need Postgres user and Postgres password, right? So don't be confused with this. Okay, I explain you, this one is different than this key. Okay, but here in secret key reference we should have name, whatever name we have given to our secret, and whatever key is mentioned over here. So in this case we have Postgres secret and Postgres user. So if I come, sorry, like this, okay, up of the file API version v1, right, then we have client secret, and this is our name, right, which we are referring, Postgres secret, right, Postgres secret, and type is opaque. So here we have defined 4 things: Postgres user, Postgres password, email address, and pgadmin password, right? So pgadmin is front end, or kind of consider GUI to access your database. Okay, so how this applications, right, when you have multiple pods, they communicate with each other. So consider this pgadmin is front end and this Postgres is back end for us, right? So we have defined this secret and 2 Postgres user and password, right, we have used over here, right? And in this, if you see, additionally what I've done, I also created, if you see over here ports is 5432, which is port of Postgres, and volumes, if you see the volumes, right, so here we are using empty directory, right, we know we can change this. Okay, and so this is an exercise question for you: make this different kind of empty directory, remove this empty directory and use path and pv and pvc. Okay, and here important thing, var lib Postgres data. Okay, so we know this path is inside the container, right? So this is our volume, is this name and this name, it's same, so these are same, and this volume is being mounted inside the container. Okay, in the container name is also Postgres. And if we come over here, right, in pgadmin, very shortly we are going to deploy this and everything will be clear. If it is not clear, I will explain this more. Same thing, right, pgadmin, right, basically we just replace Postgres over here, right, as a pgadmin, you will get the same file, but here we use a different image, of course, because it's a pgadmin, we need this. And here environment variable, right, pgadmin default email, and if we come over here, you could see the same thing. Okay, pgadmin default email. So, but this is the name. You can mention any of the environment variable, whatever you want. This is this, and both are different. Okay, but this environment variable, so this will be mounted or where we define, right? How we see this environment variable. So this environment variable, we'll quickly go on that. Show you how you know which environment variables you should use. Okay, so basically you define this in when you create your Docker image, right? But how I identified, okay, I did not create this image. This is not my image, right? So we'll come on that part shortly. So, but first, again, here we are also using environment variable to fetch the values. Okay, so here we mention, let's see now here pg admin email, right? So this pg admin email is as is, right? This is the key over here, but here it says pg admin default email, right? So I could simply also put email. Why should I taken this long one? We'll talk. Then we have pg admin default password, default email, and now value from secret key ref, right? So name is this one, Postgres secret. So here is Postgres secret. You can also define dedicated or separate secret for this as well if you want. I didn't do that. If you want to, go ahead and do the practice, right? And port, and pg admin works at port 80. And in this, as it's a front end, we really don't want anything, or we didn't use any of the volume part. Okay, so that's how these two deployment files. And now let's go ahead and see those in action when we create then what happens. So let me quit all. Let me kubectl apply -fp Postgres. So let's go ahead and create first Postgres, and let's say kubectl get pods container creating watching. So it's Postgres database. So just to, okay, it is in 15 seconds. So Postgres is there. Now we have to kubectl apply -f, and this time I will go ahead and pgadmin container is also getting created. Okay, so Postgres and both here, both containers are running, right? So as I said, pg admin is front end. So if I do port forward like we saw before, kubectl port forward, and we want to port forward for pod pg admin, right? And we want to access it on port 80. Its port is 80, which is we define in the YAML, right? So I take like this, and now if I do curl localhost, so you should be redirected automatically to target URL and all these things, right? So what we need in this case, we have forwarded the port, but we are not able to. So now we want to access it on our local system. So how we can access it? So first thing, we can see this in the browser, right? On the system, wherever, if it is possible. So for us it's possible, but let me show you first another way how you can access this on your local system. Okay, so SSH, then I would say 8080, right? And local, oh sorry, I'm wrong. I'm wrong, but instead I will say exit. Okay, so I'm back now. So what I will do is this one SSH L, right? Then add zero, where I want to access localhost. So localhost means that I'm here, right? So here basically what I'm doing the tunneling, SSH tunneling, so I can access this exposed port application at my on local system. So ssh-l 8080 localhost, and because we have forwarded this port like this, so we are providing like this, and we want to access it like this. Okay, so these are three at the rate k8s use dash n. Okay, cosmic password, and yeah, so tunnel has established. Let's go ahead in the browser and see whether we can are we able to access pgadmin or not. So local host localhost 8080, and we are not able to. So open failed. Okay, temporary failure in name resolution. All right, so let me go ahead, clear the screen first. So okay, let's do like this, and to access this one I will do like this, and let's see if right local host, sorry, focus on this. Here we go. Right, so what I have done, let me explain you. Okay, if you are accessing on your own system, so do simply forwarding, okay, 8080, right? So on this port you want to access your pgadmin, and pgadmin runs on 80. So I have forwarded this 840, I mean port 82 8080. So if you are following along on GUI server, go ahead in your browser and copy this and paste it over there. You will be able to access. Okay, what I have done, I have taken, so for me, consider it's a server scenario where we really do not have any access. So here I have created a SSH tunnel, right? So let me like this. That's what I wanted to show you. So you know what exactly happening, right? So our actual application port, right? pgadmin is listening on this port. We have forwarded on this port. So first, that's why we have defined the first 8080, right? And here this 8080 which we have forwarded on here, right? Maybe more simplicity, let me put like 8181, sorry, 8181. Okay, and here is the port number 8. Sorry, what I've done. Oh, let's clear the screen. Right, so now I forwarded this port to 8181, and now this 8181. Let's make it clear so it won't create any confusion, right? Like, right, and I provided the password, so I just set a local host, and here is the username, and in your case you have to provide the IP address of your remote server. Okay, here you could leave as is, right? Localhost or 127. Okay, that IP is also fine. I better use this thing, right? Localhost. So now I would be able to access on 8282 localhost. So if I reload it, it's gone, right? So 828, and now it's working. So what I have done, actually it's working on port 80. I have forwarded on this system, resoc3 at the rate cats 8181. If you are on system with GUI, go ahead and 127.0.0.1 8181. You will be able to see the pgadmin. Okay, but I make it one step further. So I'm now creating a tunnel for my local system, right? So I can access it from my local laptop. So for that, I have provide ssh-l, okay, creating tunnel, then port 8282 where I want to access. Okay, and if you see 8282, I'm accessing on my local system. So you have to check which port is free for you. Okay, when you're working with multiple, debugging or testing multiple ports, and if you have done or you forgot, right? So you could simply use netstat, okay, and by which you can see which port is available. So I wanted to show you, that's why 8282 localhost 8181, right? And if you don't put a dash n, then what happens? So that's exercise for you. Okay, do it, and then you will realize. Okay, and I have told you the command netstat, right? Use that command, that will let you know what happens, which port is available. So we are set, we are able to access it over here. Right now I'm in, so kubectl that secret dash o. So if I run like this, I will not get anything even in the describe, right? But in YAML I will able to find. So pg admin email. So what I need pg admin email. So how do I get this? Oh, echo and best 63 best 64 dash dash d code, and we got admin at the rate example.com. So let's put this over here and echo what we need: Postgres password, no, pg admin password, right? And here echo, right, best 64 dash dash d code and password, right? So password is simple password. Let's copy and paste and put it over, and we are in, right? We are able to access. So now what we will be doing, we will be adding a server. So let's give it a name. So to give it a name, let me check what is the pod name. kubectl pods. Okay, so this Postgres, yeah, this Postgres pod. So let's give this name as is. And if you go to connection, it needs host name, right? So we, or how we have this command void, right, by which we can see the IP, and we know this IPs are, right. This pod can communicate with each other with IP. So I will simply put it over here. Come on, today, right? And then username is admin. So let's see, is it really admin? Postgres user here. I can simply copy it, not this one. Echo best 64 equal and Postgres. Okay, this is my username. Admin is not my username. Okay, so I changed it. Similarly, I will do it for the password. Password and password. I need Postgres password. Right. So I put it over here. So we got secret. Right, secret is the password. So I will put it over here, and I save it, and we are in. Right. We could see like login tables space. So you know, right, we are in. We are able to see this, right? Postgres class and yep, schemas, right? Public schema, right? Aggregation, and of course tables are also here. Simple, go here, right? We can see the state configuration, and PID is this one, right? This is the IP, and application is pg admin like this, and configuration over here, right? We don't see any logs system, all good. Properties we could, and now you can play around it. Okay, I'm not gonna execute any query over here, but just I wanted to show you how, okay, how you could access this thing, right? And so we are in already, right? We could see all details of this one, right? So this is how we connect. Now what? So if you see, there is one thing. Let me do it like this. kubectl get port. Okay, so we are able to access pg admin, right? So all good with that. But Postgres, right? What happened with the Postgres? So let's see. First, let me and these three it is. Sorry, okay, I forgot. SSH. Yep. Come on. I think I'm tired now. Still let's go ahead and see this. So let's yeah, secrets. Yeah, this one is our mm, third one is right, and here we see, yeah. So we use volume, but volume is a emptyDir. So whatever data you're gonna create, this is gonna be deleted in, right? So that's it. That's completely fine. Okay, to show you, see this, we saw that. Now let's go ahead and over here, kubectl delete pod and pg. Sorry, not pg admin. Otherwise, how would we access this Postgres? So let me delete it now. Postgres, right? And we have new pod. If we go back and see over here, leave the page, reload it, and then let's now see what if you see in the servers. Click on this. So our connection has lost, right? So what can I do now? One second, maybe let's go over here. Okay, so no properties, SQL, statistic dependencies. Yeah, we don't have anything at all, right? We lost because the pod was gone and everything is gone, right? So now what we can do again this way. Now I will copy this pod and white WI provide like this connection, and this time it about Postgres has different IP than before. We to use this, and in this case we have the username as a Postgres. Yeah, and secret is the sure. Let's check it. So, okay, so now you see this was the pod before. Oh, sorry, now this was the before, right? And if I see in the properties, right? So we don't have, or maybe dashboard, we do not have anything. We lost the connectivity, right? And that's why it is not able to connect. So what it says, you have to provide the password. So let's say secret the password, but still it will not able to find out. Okay, and if you see over here in the configuration, yeah, right, it is also asking for us, right? It is asking for this one, but connection timeout expires. So of course there is no pod and it is not able to establish a connection, right? Because there is no such pod at all. So we have created again, right, new pod, and we have the same. So if you are using volume, right, then you will be able to see the data, right? But every time you have to, if you go here, right, properties, so we have to provide the IP. And if we go over here, we had this IP, and now this IP is not available anymore, right? You could see the connection history like this, and of course these are the configuration details. And if we come over here, so of course it's live, that's why we are able to see this, right? So we know for preventing the loss of data, we have option volumes, right? So we need something because every time when pod get restarted, right, we also have this rollout, right? We could use restart rollout of the deployment because we have done this as a deployment, right? Deploy. So pod can be restarted with that, but when it is always whenever you restart, right, rollout, restart deployment, then pod will be restarted, new replica set will be created, and whenever new pod created, they get the pod gets a new IP, and you have to all the time go ahead and configure new IP again and again and again. So it's not a feasible way, right? And so we need something which is persistent, right? And for that we have a full-fledged object in Kubernetes, which is service. Okay, and that is our next topic. So let's go ahead and see that, and we continue our this example with the service. Okay, let's clear the screen first. So previously we have seen, right, the pods dies, and all the time whenever pods spin up again, a new pod spin up, and each and every pod gets a new IP. And when we were configuring pgadmin, so add here, you could see, I mean, of course we do not have configuration, right? But when we have this pod, we did the configuration for this pod. When we had this pod, so IP was different, right? And we have to do the configuration again and again, and the IP was not static, right? So that's not kind of cool way, right? We cannot rely on the IP. So it's a similar thing. I mean, the concept is same, right? It's nothing new. So instead of like, if you want to access any of the website, you access it via URL, right? Instead of typing or remembering the IP address. So for example, this local host, right? So of course, if you type every day the same IP, then you will be used to with this, but we are human and we are more flexible with the language we know or we are familiar with, right? And here this Latin letters, we are very used to with this, right? So that's why we need something in we need something in Kubernetes which is kind of persistent, right? So when pod dies, which is still available, and but that facilitates the communication, right, among the pods. So for that, and that thing is service, right? So let's create and see we in action what service means is, I mean, what service means I told you, but how does it work, right? We have several different kind of services, right? So we have cluster IP, headless services, NodePort, load balancers, right? So let's see one by one everything in action, and what we also see where to use what. Okay, so for that, SAM repository, and this time I will go in service, right? So here I have taken two files. Okay, let me open this for you. 3 and 4, right? Both are same, no change at all. Okay, we already saw this previously, right? When we use the secret, I mean, when we saw the demo for secret, and here we use the Postgres secret, right? Password and all these things. And in this, right, so this is deployment of Postgres, right, database, and this is deployment of pgadmin. So here again the same thing, environment name is as is, right? We will also see how we how I find out, right? How I find out, right? Which environment variable should I use or should I not use? So one way we saw in our day 5 containerization, when we created our own Docker images, right? So we know which environment variable being our application required, right? So similarly, but for this image, but how I find which environment variable should I use? So we will go ahead and see that as well. But let's first see the important, I mean, important the focus of the section. So service, right? So there is no changes at all. We discussed this all both the YAML files. Okay, so we will get two deployments, Postgres and pgadmin, and we are going to access Postgres with pgadmin, right? So for this time, let's keep it replicas as a 2. Okay, let's not 2, not 3, I mean 2. Here we also change replica, Postgres replicas to 2, right? Save, wait, all right. So now it's time to deploy this application. Okay, so kubectl apply dash 3 and 4, right? I'm sorry, same mistake again. Yeah, so we have to provide this f, find them again and again, and now you see secret is created, and we got two deployments, right? So one is for Postgres, one is for pgadmin, and now kubectl get all simple. So we got two container creating Okay, it will come up soon, right? And so before we access, right, using the port forwarding, right, so I could also show you once again if you want. So simple, let's go ahead and quickly see this one. And for that, do like this, kubectl port forward, and I want to port forward of this port, and I want to access it on 8181, and this simple. Okay, and to access this, okay, now I can again open SSH externally, right, which I could do probably over here, and 8181, right? So on this machine, cats, I'm accessing 8181, but on my Mac, I want to access this on 82. Provide the password. Okay, so yep, we are done. And right, so we are able to access it, and provide admin. Sorry, here admin right, and password I believe password, and we are in, right. So of course we lost everything before. Okay, and that's why it's not showing anything anymore over here, right? So it's a new one, new port, right? This time we will see, or we will use these services, okay, instead of. So what basically happened over here, this is good for only testing purpose, okay, and we are forwarding the pod. And if I see over here kubectl get pod dash wide, right, like this, clear the screen and show you. So what basically happened over here, this is good for only testing purpose, okay, and we are forwarding the pod. And if I see over here kubectl get pod dash wide, right, like this, clear the screen and show you. See, so pods are, okay, when I delete this pgadmin pod, right, and this one, sorry, this one, let's say v2c6g, right, when I delete this, kubectl delete pod, okay, and which pod, pgadmin dash this one, and we want this one. Okay, so now we have deleted this pod, and as soon as we delete, we are not able to see the service anymore, right? It's gone because this pod has gone, and now we got a new pod, and this pod, according to time, we can filter it out. 50 second, 15 second here, this one, you see, and it got a new IP. All right, and before it has a 4.2, now it has a 4.3. So every time configuring and relying on the IP address of the pod, it's not good, right? So we need something, and that something is service. So there are multiple ways to define the service. Okay, the simplest way is to, okay, we don't want pod at the moment, kubectl get deploy. Okay, and we are talking about pgadmin. So what we will do, kubectl, and we just have to expose, okay, deployment, which one, pgadmin. Okay, and if we see, okay, so kubectl get, so SVC is short form for service, right? We do not have any of the service. So what here, I have just used this command, right, kubectl expose, and I'm exposing deployment, and which deployment, this deployment, right? So now I'm gonna, sorry, not this one, yeah, so sorry, not a w, let's see what happens. So kubectl expose deployment, and this deployment is this one, I just given a name, and I hit enter. Now what happened, so as I hit enter, there is a service, right, is created, pgadmin, okay, which is same name as of deployment. All right, and type is ClusterIP. Now I got the ClusterIP, right, we have some IP address. And now what happened, and here we also have port, right, 80. So this time, let me do like this. So if you see in this command, and what I have done before, kubectl port forward pg, and here we also have port, right, 80. So this time let me do like this. So if you see in this command, and what I have done before, kubectl port forward pg admin the pod. This time what I will do, kubectl, again I will do the port forwarding, but this time I will put forward the service pg admin, and let's say 8383 in port 80, right? So just to show you the I have used a different port. Okay, let's keep it the same so you don't think. So this time we are forwarding. Okay, so on this local machine we can access this service using this port, right? So it's right over here. Okay, now if I go on my local system, okay, so I will also go that and show you, but before that, here, okay, we didn't lost, but it's an open connection failed. Let's see if we still can access this, right? 282, yes, 8282, reload it. All right, so again, admin @example.com, your email address is the domain, and the password is the very secure password, is the password. Oh my god, admin example.com, admin@example.com. Let me see, EASSWORD, and we are in. All right, now as we say, service doesn't affect if port got deleted. kubectl get, or not kubectl get input forwarding, kubectl get and ports. So these are our pg admin ports, right? So let me delete one by one. kubectl delete this. Yes, I know we have rollback, right? Let's use that, why not, instead of doing this. So automatically all port will be restarted. Sorry, not this one. Output white. Okay, so this is our output, like this, and again in this one kubectl, and I will do kubectl roll out restart. It's a recommended way. Let's go ahead and use this and roll out of the deployment. And which deployment? pgadmin. Okay, it's restarted. Then let's see what happened. Give it some time. If we see again, right, so now we got a pg admin new ports, right? And these are just 9 and 11 seconds again ahead, again, I mean before that, right? And before that, right, and their ips are changed, right? So we, and still, right, we have forwarded the service. And if we see kubectl get svc, so still our service is there, and 4 minutes 13 seconds, right? So service didn't affected at all. So let's see if we can see this as well. I just refresh it and it's gone. All right, so what happened? Let me see. So we connection lost, right? So but still our service not affected. So let me forward it again, no worries, and reload it again, and admin@example.com, password and the password, right? So still it's there, service is still there. If you see again, so it's 5 minutes, and ip is not changed at all, right? So this is one of the way to access your pod via the cluster IP. Okay, but if you see, I mean, you already realize when we restart the pod, we lost connection, right? And we don't want that, right? When we do port forwarding, we should not be lose the connection. So we will go ahead and see what is the solution for that. But before that, I would like to show you something else, right? And that something else is service. So in this case, what happened? We exposed, right, and service is created. We did not check what happened. So kubectl describe, and that svc is pg admin. So what we get over here, So this is the name, default namespace. We did not put any of the labels, right? We have selector app equals to pg admin, right? Here we have a type ClusterIP, and the sorry, this is the family, and here you could see the IP address, and here you see one thing, endpoints, right? And it has this two endpoints. Okay, so and if we see the, let's get over here, go ahead. Right, so these are pg admin spot. Okay, and if you see the IP of 4.4, which is over here, and 2.4, so which is over here, right? And when we restart, right, so let me do it again. Okay, now restart it. So let me do it again. Okay, now restart it. So simply when we restart, we know our pod will be restarted, and when pod get restarted, they get a new IP address, right? So I can again describe my service, and you could see now before it was 4.4, 2.4, right? 2.4, right here in the endpoint here in this, and now we have the endpoints are different. Okay, so whenever you have a new pods, right, so all the times those pods information get updated in the service, and that's how we constantly getting the access of the service. Okay, next thing, but here we do not have anything in the events. Okay, and but if you have some issues, you could see over here, right? So this is very simplest way to expose the service, right? And now we are able to see the our pg admin. Okay, we will fix this, but let's stick with that because our this IP. Okay, but if you notice this one, okay, these are getting changed, but the IP, this is the service IP, right, which is 10.96.186.109. If you see over here, okay, which is the same. If I do like this, so I have 8 places where the IP is same, right? And IP is same since when it has created. So until and unless you delete the service, right, you're not gonna lose the IP of the service. Okay, so that's how service provide, right? So service enable communication. And when we have more pods, so before we were doing a forwarding of the pods, right? And now if we have, like, we have 2 pods for this. So in this case, what I mean, service knows, okay, which pod it has to send the traffic. Okay, we really do not have to do, and this is the preferable way. Okay, let me show you another thing. Okay, so this is our cluster. So this is one of the type, way or kind of service type. So you maybe realize when I expose, right? So let me find this. Okay, when this command, let me clear the screen so you could see here. Okay, when we expose the deployment, right, after deployment we did kubectl get svc, and here the service is, it says type is cluster IP. Okay, so by default, when you expose a deployment, okay, or Kubernetes by default creates a service, and which that service is a type of cluster IP. Okay, so what is the use case? Of course, it's a default one. So, but we have more as well. So default is created, and what is the use case? So when you have internal communication, okay, when you want to, or when you want pods, or not the pods, when you want, when you have a use case where you want communication within the cluster. Okay, so let's say database connections or microservices talking to each other, right? This is best for that. Okay, but if you have something where traffic or request will go outside of your cluster, then it is not well suited. Okay, and it assigns a triple internal IP, right, to the service. Okay, and which is accessible only from within the cluster. You cannot access it outside the cluster. Okay, and that's why I forwarded this service on my local, right? So this is the cluster IP when you have use case like this. Okay, when, for example, you have front-end application which is communicating with the database, so front-end pod, right? Or you have microservices. So in front-end, right, your front-end application or front-end application pod wants to communicate, right, internally um, with the database, right, for example. So in that case, you can enable the cluster IP, right? So this is the next we have. If you see, we have kubectl kubectl get deploy, right? So we have another deployment is Postgres. So we have exposed the service for pgadmin and we are fine with that cluster IP. Okay, now we are going to create a service for Postgres, right? And for that, what I can do, simply in the same directory, I have files created for you. Okay, and so as it's a database, right? So we will create service. Okay, and we will create a service using a file, right? So let me open this. So for this, right, you could see for the database I have provided a name ClusterIP none, right? So why is so, we'll come on that in a while, shortly, not in a while. So let's put it is a none, right? Then we have this part selector, then here we have option ports. So selector, it means it's kind of we have the levels in a pod, right? Similarly in service we have to provide for the service the selector, and based on that service do the selection, okay, which pod is it has to handle. Similarly, like for the replica set, we said okay, mesh level selectors, here simply we have selector. So based on that, whichever pod, okay, if you have multiple selectors, okay, you have to put everything over here, everything in the level. Then Kubernetes know, okay, or Kubernetes, this service knows which pod it has to send the traffic to. Okay, but here the important thing, or very confusing thing. So here we have two things: target port and port. So I have both are same, right? So target port here, it means the actual port of your container. Okay, where your port, okay, I mean your container has exposed port, or where your container is listening to. So Postgres container is listening to. So Postgres port is 5432 by default. Okay, and here the port. So this port is for service. So your service port is this one. Okay, and your container port is this one. Okay, so you, if you want, you may change it. Okay, this one, but this must match with your whatever you have. So yes, if you create your own image, you have option, right? You may go to the make a changes in the you can create a config map, right? And in that you can mention the port of the container itself. Then whatever port you change, you must provide over here, and this port is for service. Okay, so service is listening to this one, so I just put a same, no changes at all. If you want to play around it, change this port. Okay, so don't mess up with this. Okay, until unless you have customized your own image. So we are using official image, and official image listens on 5432, completely fine. We are using this port. So here target port, it simply, so let's consider you in service. So simply port is port, simple port, when you say, so it means this port belongs to this service. Okay, target means you're referring somewhere else. What is your target, where you want to send the traffic? Okay, so service say when you need to communicate, so you will communicate using this to the service. But when you send traffic to service, service knows where it has to route the traffic, so it does with this port. Let me create this first and give you more information about this. Okay, so API version kind is service. Similarly, rest of the other YAML files, there is no different, except here we are creating service using a file. And metadata, we know we can also provide levels, but I'm fine with this. And in spec, right, in spec we have cluster IP none, because we don't want any IP for this. Okay, so why we are putting that, we will also see that shortly. And we have selectors, we have ports, and protocol is this one, and 5432 target port, this is the port of the container, right? So let me create first service, kubectl apply -f, and then headless postgres.yml. Now let's see kubectl get svc. Let's click here, and our Postgres, right? Our Postgres got a service, and I describe it kubectl describe svc. So here, sorry, I have to give it name Postgres, this one. So we don't want to describe everything, right, or all services. And here, right, we have Postgres service, right? Here we have namespace, here we have selectors, right? And we mentioned cluster IP. And now, right, and target port you could see, right? And when you see this, right, so here is also 80, and when I make like this, so you could see here the PG admin which listens on port 80. So when we did this forwarding, so that's why I told you, okay, this is the port number, right? Similarly, if you want to access port forwarding, we can do the port forwarding with this port, right? And but what is the difference? In PG admin we got a cluster IP, right? And here we did not get any cluster IP. So now how this PG admin communicates with this one? Because now what I want to do, let's see if we still have, okay, it's connected. Admin @sample.com, password is password. If we still have, okay, it's connected. Admin @sample.com, password is password. We are in, and now I want to add a server, and add a server Postgres, right? Postgres. Okay, this is my server. So let's say this is the first configuration, and in connection, right, we have to host name or address. So either we can communicate with the IP, but we do not have IP. So should we directly put the name of the service in this? Yes, that's correct. But we don't do this directly. Okay, so as I said, we even don't want, right, we don't want to express in production. You don't expose even on the cluster wide, right, your database. If you're, or some of the service, you don't need it all to expose even for the cluster wide. Okay, we want only PG admin can communicate with that, this part, right? So for that, how you can use this, or how you can, so here the point is headless. Okay, so headless, it, I mean, when you do not have IP, right, it means you are creating a headless service. Okay, or maybe consider instead of using headless, it's a IP-less service. Okay, but in Kubernetes world, it is called headless service. Okay, so now we want only because as I said, when we restart the pod, right, so pod gets new IP, but we want to come, that's why we needed a service. But this is a special service where we really don't want this to expose even the cluster wide as well. So that's why we said cluster IP none. Now how PG admin will communicate? So yes, it will communicate with this one. So let's see, right? And admin, here we have host grace, and the password is secret. And let's save this. And what happened? And it says unable to connect to the server. Did I make any change, mistakes in copy while copying? Its connection is okay. Okay, we are accessing on 8.1. Of course, why 8.1? Ah, okay. Yep, yep, yep. So here we go. Okay, so we are still able to, we can access simply, right? But in connection, it says try again. Okay, we can try again, but unable to connect the server. So access simply, right? But in connection, it says try again. Okay, we can try again, but unable to connect the server. So service is not resolvable, right? So let's troubleshoot, because it is not able to communicate, right? So how we can do the troubleshooting for the service, right? Here we could say all good, right? kubectl cat kubectl cat pods are also fine. Okay, so let's describe. So describe SVC Postgres headless. Okay, so here we see Postgres and PG admin. So Postgres, here is a PG admin. So let me show you the difference. Okay, so here, if you see this one and this one, right? Here we have IP families, and we said IP, I mean, of course, it's a type like this, but without any IP. That's why it is called headless. Okay, and here one thing, the endpoint. And if you see ports, right, and if you see over here endpoints, so here we have endpoints, and these IPs belong to the pod, but here we did not get any IP endpoints, right? So how it means we are not able to connect with this service. So there is a short command as well. Okay, for this, if I clear kubectl that ev, oh sorry, not ev, ep endpoints. So simply when you want to see, okay, of course you can describe, that is a first, that should be first step. Okay, describe and see what it's showing over there, right? So we did not get any endpoints, that's why it says unable to connect to a server, because it is not able to send a traffic, right? And where it should send. All right, then here it means, and we do not have endpoints. So what we need to do, so very simple thing over here. Let me do one thing. So this is our headless, right? Let me open this file first, postgres.yml, and our PostgreSQL, right? That's fine. Dash o. Okay, both files are open. So actually this was planned to show you what is the importance of selector. Okay, so that's why I put in this way, and that's why a service is not able to connect. So what you need to do to fix this? So here, right, in deployment we put labels and we set app equals to Postgres, right? Which should, I mean, not that one, talking about this one in template, right? Match label app Postgres. This should match. Similarly, here we have the same thing, right? App equals to my app. Okay, so app equals to my app, this okay. But if we see the labels, app equals to Postgres, and here we have app equals to my app. So it is trying to find, the service is trying to route a traffic to a pod, right? And it was not able to find any of the pods which has label app equals to, sorry, my app, right? So match labels are app equals to Postgres. Okay, so we need to change this selector. Okay, so this service knows, okay, which pod it has to communicate, okay, or send the traffic to, and this match level selector for pod template and this one. Okay, so if you put more selectors over here, you have to put all this over here. Okay, so in our case we have put, so just play around it. I just put a just, I wanted to make it simple, not make it very complicated. Okay, that's why I have it. So either I change this selector, okay, over here, or instead I will put it over here, or because I don't want to make this labels everywhere, so it's easy to update the service. Okay, and in service we will put this labels which is in the pod. Okay, so of course these are the same. Maybe you could use the can it be anything over here as a label, and you can also select the in this part, like, okay, selector, put the can it be anything, and yes, and that will work for you, right? So let me exit all and show you the file which is fixed version of this. Okay, and we have the app Postgres, right? Let's deploy this or apply this, I would say. And here, let me stop this first. kubectl get svcs, right? I want to watch this, right? Like this. Maybe let's clear the screen and do it now. And here I'm applying this file, kubectl apply -f and headless service, and this. Now you change, I mean, now you see, right, there are some changes and it says configured, right? And now if we do something like this, kubectl get endpoints, we can also describe service and see, right? But let's see the endpoints. And now if you see this one, right, headless service, it got the IP address of the pod, right? And another IP address of the pod. If you want, let's make it zoom. kubectl, sorry, kubectl get pods dash o and a y, and the same IP of the Postgres, okay, 3.2, 2.3. And same we have over here 2.3 and 3.2, and the IP address 5, I mean not IP address, port is the same, 5432 5432. Okay, so why I showed you the this endpoints, right? So this is very quick way when you are deploying lots of microservices. Okay, one of my senior told me this when I was working in Refresh with Kubernetes. Okay, we were in hurry. We had to leave for a party, and I had a deployment. And I deployed, and then he showed me this command kubectl get endpoints, and we quickly figure out. Okay, we figured out that there is an issue with the this one, right? The selector. Okay, so always remember this is one of the very important, and that's why I showed you like this, right? So selector is for service, okay, and mesh level selector is for yeah, that's for the deployment, the selector. Okay, so always remember this is one of the very important, and that's why I showed you like this, right? So selector is for service, okay, and mesh level selector is for deployment, where you mention, and that must be matched, or that any of one of them from the label should be matched with that. But here in the case of service, you must have all the selector. Okay, so that's, I mean, whatever you define over here. So that's why I have put it in this way. Let me show you once again, and then we will move on to the next topic. And this one, then Postgres, not this one, 3. Okay, so you could see here the mesh levels. Okay, and here in level I have only put one. Okay, because I had only one over here. Okay, if you have multiple, you have to put all this thing over here. So play around it. Okay, when you play your own, you will learn more what I explained, right? So that's how it worked. But now let's see whether it is really configured, right? So let's go ahead over here. Now it's the same thing, and let me put like this. Let me reset. Yes, I want to reset it. Okay, put name, so Postgres or simple post or PG. Okay, and go to connection. Now we have endpoints now, so it must be able to see. Okay, I'm able to see, it means able to connect. And if I save, so let's see. So connect to PG admin server has lost. Okay, all right, no worries. So what we have done, so here we have done like this. We forwarded PG admin, okay, just to show you that. And now let's go ahead and redo it. So reset, yes, reset, Postgres connection, and user is Postgres, and okay, this value from the was secret. Let's see, and we are in, right? You can see now, and now as many time as I want, I can delete the my pod. Okay, and you could see how you can see in the properties. The property, I don't know, somewhere we are able to see this one moment. Yeah, here we go. Right here you could see we have given a TP name post. Sorry, it's not here. Host. Yeah, this one, right? When we see in this string, okay, this is the connection string. This host and this Postgres headless service. This is the name. Okay, so now the name of the service is still there. We are not going to remove that, and usually ideally we don't do that. Okay, but again, roll out and restart, not PG admin. Okay, because we want to check the connection, right? Because we have connected with the Postgres. Okay, so restart it, and now of course we know we will definitely get a new pod, right? Kubectl that, not this one, right? And if you see Postgres, just 9 seconds and 12 seconds ago, and O and white, right? And these are the IP. But if you see kubectl get SVC and this one, so which is still there, right, without any IP. And now when I refresh this, right, I will reload it, and if you go into the server, expand this, and yes, we have, boom, we are still there, right? So this is the way you can have, or you could use, right, the headless service, right? So this is one of the use case where you really don't want to expose your pod to communicate even within the cluster. You want some only specific communication, right? In that case, you could use or leverage these headless services, right? And which does not have cluster IP, unlike regular services. Okay, and another thing, what are the key characteristics? It does not have any cluster IP, so service becomes, that's why service becomes headless. Direct pod access, right? So application interact directly with individual pods. So how interact? So here in the pod of PG admin, we have given the service name, right? So we are communicating, right, with this one, and it also create. So second reason, so I mean, of course, headless service is like this, but another reason, when you don't want to rely, okay, you don't want to create IP, you only create, or you only want to have a DNS records for your pod. Okay, so Kubernetes creates DNS entry for each pod in the service and enabling service discovery. Okay, so this is on this one, right? And last thing, when will you use it? So if you remember, uh, this one, less. So you remember we have created this service name, my first, and it mentioned the headless service recommended, right? So I commented that out. So it's for your practice, enable it, okay, and see what happens. Okay, so when you have stateful application, okay, so use for like database, maybe Cassandra, Kafka, or other things, okay, where each pod has a unique identity and require direct communication, right? So in that case, we don't want they communicate via the service, okay, they can communicate directly. Okay, so in that case we use headless service. Okay, so that's why I have given you this example before, right? So try it, do the practice. So I think it's enough on the headless service. Next, okay, so next, what we have, okay, next to service we will see, which is NodePort. Okay, so let me clear the screen first. Do we need anything? Okay, let's clean this as well. Go over here. Okay, so for that, what is NodePort service? So instead of explaining you in theory, let me show you exactly what is the NodePort, and then I will explain. So for that, we have already a file, okay, kubectl, kubectl, get all. So we have PG admin, it's a services, it's a replicas, it's a deployment. Okay, so we will create now a NodePort. So for that, before, let me show you the NodePort. Okay, so NodePort is already there. I have created a file, and now it will make more sense for you. Okay, so parent is service, PG admin NodePort service, and here the type. So before we have type is cluster IP, here we have type NodePort. Okay, and selector is the same. Okay, and this must be matched in your levels, right, in the template of the pods. Here we have a next item for ports, and here we have protocol as HTTP. So port 80. So port 80 means simple, this is the port of the service. That's why when we forwarded 8080:80, right? So this is the port of the service. So you could see the target port in the container. Sorry about this one. Okay, so this port for the service, this target port, okay, port exposed by the PG admin container. Okay, so this is actually a container port, right? I'm sorry about this. Let me remove this, otherwise I will forget, and I will check this in the there. Okay, so yep, and target port exposed by the PG admin container, right? And here node port. Okay, we are not making any changes in Postgres, right? We are here, the service we are exposing for same service. Okay, So now we are creating another service for PG admin to be accessed as a node port, right? And here you see the node port. So this port accessible on all the nodes of the cluster. What do you mean node port? Okay, hold on for a second. Okay, I'll show you demo what I mean. But here there is a thing node port, right? So in ClusterIP, it's straightforward, right? You could understand, you could sense it on. Okay, node port, ClusterIP, it means the communication within the cluster. Okay, node port, it means it enables the service to communicate outside of the cluster. This is very shortest definition. I will elaborate it more and explore. I will give you more information on this. Okay, so to access the service outside from the cluster, we need something, and that something is node port, first thing. And node port has like this, and port accessible on the node, right? So this node port, if you don't provide, it will be randomly created or generated for you from the Kubernetes, right? And this has some if you can define a port, you cannot define any of the ports. These are predefined, right? 3000002 32767. Yeah, so this is the range. Okay, so all the ports you should have within this range. Okay, simple, this one, right? 30,000 to 32,767, right? So this is the node port limit. Okay, from here to here you can define any of the port. All right, usually you don't define, I just put this, and we are okay with the default one. It's completely fine, right? So but just to show you what is the difference. Okay, and now you know target, it means the actual container port. Okay, this port, it means only remember one thing, target, it means where you are going to shoot. Okay, and you will get gold medal, of course, in imagination. You could also get in reality as well, right? No doubt, if you want to. But our target, we want to shoot 80, and this is our location. Okay, so for our location is also same, and that is our target. And here again, this port is for service IT, target port, node port. So let's create a service out of it, and then we will explore it more. kubectl fly-f node port, this one. Okay, so kubectl, first thing we will check is before the service endpoint, right? Node port. So here, okay, completely fine. We are able to see the endpoints. It means our service is correct. Now we describe kubectl this, not describe, first we get the service as we see. Yeah, why not? And now you see, we before, I mean, when we had this cluster IP, right? So we had only 80. Now we have 30080. Okay, all right. Now, as I said, node port is outside of the cluster. Okay, but what happened basically, we know, okay, I can access this by port, and which port? This port. Okay, 30,080. And when you create this kind of service, okay, you define a type define a node port, then what happened? Kubernetes open the same port on each and every node of the cluster, regardless where is your pod is executing, right? So let's see, kubectl get pods -o -wide. So our Postgres, sorry, PG admin, okay, these pods are I mean, they have this one, but both are on different, and in total we have total number of nodes are 4, right? And I said node port, and it opens a port on each and every node. And how many nodes do we have? kubectl get nodes -o and wide. So we have 1 2 3 4 5. I mean, not 3 4 5, 2 3 4. These are 3, and this is 1, so total 4. And they have this IP address 2 3 4 5, right? So when you create a node port service, okay, so this port is available or is open on all these nodes. Okay, in our case, so if you go ahead with this IP and put this port 30 or 380, you will be able to access your service. Okay, so let me copy this and and let's see if we able to see, right? This time we didn't make any of the changes, so I will go to a machine where I did a port forwarding already, and I have passed this IP 192.168.49 like this. Of course I cannot, but what I need this IP address. So instead of typing, okay, let's copy this. No big deal, no harm if we copy paste, and you see we are able to access the PG admin over here, right? But I said we can access it on every, right? So 2, then 3 on port, right? Then here we have 2, and now if we go to 3, we already used 4, okay, and we also have 5, right? So if I go on 5, right, like this, so same I can access. I mean, if I can access it means I can log in as well, right? This is on 2, this is on 3, this is on 4, this is on 5, right? So all these are the nodes available for us. I could also simply run this command kubectl get nodes dash and wide over here. All right, so 2, 3, 4, 5, and same when we see in this. So this is 2, this is 3, this is 4, this is 5, and kubectl get scc. And I told you in when you expose service outside, right? So let's say these nodes are accessible from the internet, right? Maybe if you are, instead of doing this local on your local, maybe this machine, okay, you are using in the cloud, right? So if the IP is publicly accessible, go to the browser, and after that put this whatever port you will be able to see, okay, in valid range, then you will be able to access, right? So that's how this NodePort services work. Okay, so now you understood, okay, why do we need NodePort? We need NodePort, right, to expose a service to communicate outside of the cluster, okay, and using the nodes IP. So we use the node IP and of course the port to communicate, okay. And we also saw this port is open on each and every node of the cluster, regardless where we have only two ports. And we can also see like few here that ports dash o and y, right? So basically our Postgres, oh sorry, PGAdmin, right, machine 4 and 2, right? So machine 4 and 2 means 3 and 5, but these are not on, I mean this ports are not scheduled on this machine, this of 3 and 03, I mean 49.2 and 49.4, but still we are able to access it over here, right? So that's how the node port works. So where it best suits to expose application without an ingress controller, right? So we will see what ingress controller is, okay. It's a really amazing thing, but first understand the services. If you know the services, you will be manage the ingress and ingress controller very easily, okay. But it also had some downtime, limited security, and cannot use domain based routing, right? Because for example, you have to create a DNS name for your service, right? So what will you do? In DNS server, you will put all these IPs, okay, 49.2, 49.3, 49.4, 49.5. And what happen when you have multiple application? So for each and every application, you are going to do the same? No, right? We want, and that's why we would love to connect via DNS name instead of the IP address, right? So this is the limitation, and for that, right, we have next service, which is load balancer. Okay, that is our next thing. Yes, we will see the load balancer on our local system. You may be thinking how we will see. So no ways. Right now I'm gonna explain you, and we'll create a load balancer in Minikube cluster, and we will see how load balancer works. But before that, kubectl, one more thing on the service itself, right? Kubectl, say edit s3c pg admin, and what is the name of the service? NodePort, right? When we open this service, right, you could see again some annotations. Okay, name we already talked about, namespace is default, and you could see the cluster IP is also assigned, right, 127. Then if you see the ports details, right, here is the port detail and we have selected. So services are also perform kind of the load balancing, but lightweight. Okay, not full-fledged load balancer, but because we have two ports and service decide or manages, okay, to forward the traffic and receive the traffic back. Okay, so this is how its YAML looks like once you deploy it, and many of the things is managed by the Kubernetes, right? And you know the annotation part, right? We talked this before as well. I would like to show you one more thing, SCC, and that is PG admin, right? I, oh, by default it will open in the this one. So here you could see again the same thing, resources and the cluster type, right? And type is cluster type and selector is PG. Remember this, okay? And here you have actual the IP. If you want, you can open. So here the main question, interview main question is based on this one, selector. Okay, so interview will not directly ask you, tell me the what is selector. Might be to ask you what is the purpose of selector. It could be straightforward question. Other way around, it could be asked like this, okay, how you forwarded traffic, uh, if you have kind of service, so how you make sure the traffic is routed to the pod you want. So this is the answer. Okay, you should have selector. Okay, and based on that, service knows which pod it has to send the traffic and which this selector must match with the labels in pod template. Okay, so this is about the third kind of service. So first we saw, so first we created cluster IP that we did not create. This one we created, right, by the imperative command. That we created headless. Headless simply means there is no IP. So we ask Kubernetes, don't assign any of the IP, just give it a name. We want to access it via name, right? Then, and this is useful when you have microservices or only one microservice is exposed, right, or responsible to communicate. And then we created NodePort, and now we are going to create load balancer as a service. Okay, let's see load balancer as a service. And for that, I already created a file that is load balancer LOAD, which is not over here. Let me go back here. So let me clear the screen and load balancer.eml. So no, nothing new. API version v1, right? It's not apps v1, it's a v1. Kind is service as usual, metadata and name is pg admin. But here we want to create load balancer. And here we have type load balancer, selector is app, pgadmin, ports like this. And again, now we know the port, so it means the service port. Okay, so this is, we are going to access our service on 909090 or 00. It's okay. And target port again, port exposed by the pg admin container, right? Nothing new, only you have to change the type, right? And now let's create this and see what other things we will get. Now it is becoming boring. Initially I have lot of things to explain you, but now you know everything what we will get inside the YAML. So for me it's nothing to explain. Kubectl get SCC. All right, so our service is created, we got the cluster IP, okay, but external IP is pending. So of course in production workload, when you have your workload in the cloud, right, and so you really don't want to end up with lots of services opening on NodePort and making those into your putting their IPs into the DNS server. Instead, you will create a load balancer, and load balancer perform rest of the things for you. Okay, and there is also thing which or which application you should expose as a load balancer. So yes, I will create one dedicated session or video or tutorial for ingress controller, which is one of the crucial thing right inside Kubernetes cluster, by which you can save lots of money. And ideally you should do that. Okay, so since beginning, I'm telling you, don't give a bill to your manager, give a saving, and in return you get appraisal. Ask, okay, if you give saving, must ask, I saved this much money. Okay, and we waited a long and still it's pending. So in cloud, of course, it may take more time as well, right? Because creating a load balancer, it may take some time, and it has a lot of functionality as well. Okay, and what functionality it has? When you need high availability, right? So load balancers also provide you the facility, right, from the various attacks or something. So whichever cloud you have configured your server on, I mean cluster on, read about that, read about the load balancer. Okay, load balancer provides very amazing thing, right? So I think we have waited enough. How long we wait? Of course, no, it is taking too much long on the local system. Let's give it some more time, and meanwhile we see something different. Okay, if real, describe what we want to describe service. Yes, we see the load balance. What service we want to see for pg admin, and load balancers. Okay, so kubectl get endpoints. I mean, of course, we already saw that. So this load balancer also got the endpoint, right? Because it is also running. I mean, pg admin is running on the same pod, right? And here, if we see, so, and we got the endpoint, it means our selectors are fine, right? That's why this pods get entries in endpoints. Okay, that's why we are able to see these details over here in 3 minutes 8 seconds ago. All good. Here, if we say a node port, okay, we did not ask for the node port. This is the our port, right? So I told you the port, it means the port of the service, and in our case the service is load balancer service pg admin, and which has the type is the load balancer. So if it is node port, then this is the, I mean, of course we know the range, right? What is the range of the node port? But I'm just telling you, whatever you define in a port, that is for your service. Okay, so let's see, and hopefully we get the kubectl get svc, the external IP. Come on, it is not coming. So why is so? So there is a catch over here, and the catch is on Minikube. Okay, what you need to do. Let me see if we have. Okay. So kubectl get svc. But we are pg admin load balancer. We don't want to watch everything. We want to watch this. Let me clear the screen. Okay, so it's pending. So what you need to do, right? So you have to perform Minikube, and which is not over here, of course. So what I have to do, I have to do SSH. I want to direct SSH, clear the screen. Minikube. First, you have to type Minikube and create a tunnel. TUNNE. Minikube tunnel. Okay, dash profile. If you did not have a custom name of your cluster, okay, you don't need to provide this. But in my case, okay, these are free. Okay, and how? Let me tell you again. I said you many times. Minikube profile. When you execute this command, you could see this is the profile. Okay, and when you don't give a profile, you will, but still you will be able to execute this command, and you will be able to see by default Minikube. Okay, so in our case, this of 3 is the profile. Okay, let me remove this. I created a tunnel, and now what? Ask me for the password. Okay, let's take a password, and now simple, we got a external IP, right? Before it was not here, right? So basically it's a we open a tunnel. It's a kind of, not kind of, it is a way to create a load balancer. So when you create in your cloud, you will get one external IP. And as I said, when you have external IP, right? So in NodePort, you have to give an provide a node IP of the node port, right? And which is like this: kubectl, sorry, kubectl at nodes dash o dash wide. Okay, so you have to use, and you really, in case, and yes, we don't want to expose this as well, right? Instead we want to expose the IP of the load balancer, and that's why we create a load balancer. So when you create a load balancer, you will get a different IP, okay, not like this, okay. But ideally we have created a load balancer, and we will be able to use access the service uses using this external IP, and this is the port of this service, and this service type is load balancer, and we have external IP of the load balancer. Let's go ahead and access it over here. Control T, sorry, not yeah, it's a Control T but different one. And 9090, if I still remember the port, yeah, right. So this is the port 9090. I'm not accessing it on NodePort. Okay, maybe if you want to try with this NodePort, right? So you could see over here, I can log in admin @example.com, okay, and the password is password. Oh, and it says CSRF token do not match. Yes, because it is redirecting. Okay, but we are able to access in your, when you create in cloud environment, I'm sure you are able to access your load balancer, I mean your Postgres over there, right? And after that, what? So this is how, and what actually happened over here, right? I have created only, if I do it like this, kubectl get svc, okay, and get pods. So you see my same pods, right? And for the same pod, I have created different kind of service for different kind of purposes. So yes, this is possible in Kubernetes. You can do this, right, and perform. Now I would like to show one more thing about this. So let's go ahead and describe this. kubectl describe svc. So now you see, of course, these are nothing but, and now we know the labels. That's why we got these endpoints, right? Because this pods has this selector as a label. And here you could see load balancer increase VIP, and the port is this one, but it also got a node port like this. So let's go ahead and see is this edit. And here we got ClusterIP, okay, which is the same, right, in our case, because we have used a Minikube. We created a tunnel, right? So Minikube is providing that. And if you see NodePort, right, we did not define this NodePort, but when you expose or when you create a load balancer service, there is a port. And now we know when we have NodePort on each and every, I mean, when we have service like this, so this port is open on each and every node. So let's start as the command, go ahead and validate whether the port is open or not, or listening or not. But this is the important thing, port 9090. And here you could see we are using, okay, 9090, right? And target port, of course, 80, right? And selector, if you see in this, so before it was kind of flower braces over here, right? If, but now if we have here load balancer, ingress IP, okay, and the mode is VIP. That's how you create services in your Kubernetes cluster, right? So as I said, yes, this is also kind of ingress, but for a moment, okay, this is enough on the service part. Okay, I've showed you all kind of services except ingress, but ingress is next level when you have multiple services and you want to control how or where to route requests from one thing to another thing. Okay, so ingress plays a very amazing role, and you really do not create ingress itself. You create ingress controller, you create ingress rule for those of your services, and then okay, let me tell you which service you can expose, right? So your ingress controller should be, okay, yes, I won't say must be because it's your choice, but I always did this. So your ingress controller should be exposed as a load balancer, because ingress controller is the entry point, right, of your cluster. Okay, so it's very confusing, so that's why I said it's now, yeah, only explaining this topic took a lot of time. So make yourself familiar, right, and do the practice. And for this you have another practice exercise. So I showed you this pgadmin and uh, Postgres, right? So you use ConfigMap secret volumes all together and create this deployment. Okay, I didn't use volume at all, right? I only use secret. So put configuration somewhere in a config map, right, of the database, or use the volume, reload, okay, and simulate all the steps which I have shown you over here. Last thing I would like to show you over here, and then I would wrap up the session. It means the, yeah, then we see service is our last topic, right? So vim dash o. So here we created headless service. Oops, sorry, not in this. Let's first go into a directory, gets service dash o, headless dash one. Then we created NodePort. Then we created load balancer. So we opened all these three, and you could see everywhere the service is same. Of course, we need a different name. That's why we have given a different name. And here cluster IP none, right? NodePort. And here, why not? We should open this as well. We split less. Okay, so not this one. So that, for that we expose the deployment directly as a command, right? So, but if, as I said, if you don't use this one, okay, so when you do practice, just comment like this one, right, and then apply, and then you will be able to see automatically Kubernetes Pro created, I mean, yeah, created and provide a cluster IP. Okay, change its type, right? So here it's a headless, so don't be afraid of thinking what is headless it means. So headless, it means consider without IP, that's it, cluster IP, right? Then we have selector. So you see, and again, emphasize on this part, this is important. And but I told you how you can check if you're uh, as soon as you deployed, before describing a service, check the endpoints. Okay, if you get endpoints, then it means your service is good. Okay, it's stick with the, or discover the ports, right? Then you have port spot, and in that you have TCP, but first one is port, which is for service port, right? So here 5432, right here 80, and here in load balancer we access the load service, right, using the 9090, right? And target port is, of course, so I told you don't rely on these comments. I will maybe later on update this. I will make a better version and then upload in the repository. Okay, and target port, so we know the target port. In case of Postgres, we have 5432. In case of pgadmin, this one, nginx is also works on 80, Jenkins works on 8080, right? Tomcat works on again 8080, so different. And in NodePort, 30,000, I mean 380 was the port, and we access on 2 3 4 5 all the nodes. Okay, so this is about the service. When you don't want any I mean everything, all the ports communicate inside the cluster, or if you don't want any communication at all inside the cluster, you want to restrict that. Okay, especially for database or it's StatefulSet, use this one, right? If you want only services communicate inside the cluster, use cluster IP. So don't mention, you don't need to mention anything, right? That will be automatically created by you. Okay, but here in no case of NodePort and type load balancer, you have to define the type. Okay, and when we created load balancer, you could see here we did not mention any of the NodePort, but we saw this configuration is automatically added by the Kubernetes, right? So that's it from my side. Clear the screen and let's go back to our presentation. Yeah, one thing I forget to mention, right? It's a namespace. right? So to create a namespace, it's very simple. Okay, so maybe I really do not need to explain it, but still I will explain you. Kubectl, there are some commands, right? Kubectl get namespace, and this is how we see the namespaces. Okay, and that's why this is the default. So whatever we have done so far, right, that could be, okay, that everything we have defined, or we created all the objects in default namespace. Okay, and this is your, so for example, if I want to see cube, not cube, kubectl get all dash n, what do we have in this namespace? So we do not have anything. If I change this namespace to, let's say, public, even though nothing in the public, and cube system, when I, so if you see in cube system we have many pods. Okay, DNS etc, that's we already discussed, right? And why these are in different namespace, not in the default namespace. So here the namespace in Kubernetes, it's a logical partition, like on your hard drive, right, on your pen drive. I don't know you make a partition on your pen drive or not, but I did, that's why I'm using it. So when you make a logical partition, but I believe, yes, we all install the operating system once in our lifetime at least. So we create one primary and rest of the logical. So similarly, namespace concept in Kubernetes is also a logical partition within a cluster, right? That helps to organize and isolate the resources. So for example, if you have, for example, you are providing Kubernetes as a service to your clients. So you can use, okay, kubectl or simple K, I have set alias, create namespace, client 1, client 2, client 3, and kubectl get namespaces, and inside that, right, you can deploy the application. Where did I use the application? Right, in one of our project, it's a SaaS based application. Okay, so for each and every user, right, they have a dedicated a namespace. Okay, so for user it means the client. So for whenever, for example, uh, let's say you are using any of the service SaaS based, and when you sign up, right, you pay to the company, so they have kind of a plan, right? I'm not selling you anything over here, just giving you the idea. So when you have cheaper plan, it means the cost effective plan, so you have to share the resources, right? And when you have um enterprise level plan, you want to your own tenant. So if you have cluster like this, okay, so that is just one of the example. But when you have a really big application, so let's say Jira, right, it's they really very big, right, and many people use that. So for, or I just give it an example. So whatever application you're using in a cloud, right, so depending on what kind of application, what kind of service they provide, so you can have, instead of creating multiple clusters of the Kubernetes, right, just giving example, you can create multiple different namespace, and inside that you can deploy the your application and provide it to the user or your client. Okay, that is one of the use case. Second case, if this is not the case, okay, in another, I'll give you the my real life experience. So for different department, okay, or different accounts, we used to call that as account. So for that we use our namespaces like that. Okay, so maybe the namespace like client 1 or team 1, right, and we give access to the teammates. Okay, those team they actually wants to use, so though they can deploy their workload into only the namespace. Okay, and yeah, that's how you use the namespace. I mean, create the namespace. If you want to, right, if you want to create any of the deployment, so cd cats, and let's go to the pods. So here, kubectl create apply dash f, my second pod, right? So in this file, right, we did not mention anything, but I could say namespace equals to, let's say, client 1. And you could see if I say kubectl get pods, and here I don't get any pods at all. So let me first delete this kubectl delete -f and services. So everything will be deleted. All good. And now if I see get pods, so no resources in the pod. So I have to provide client one. So, and now my pod is running over here. Right. So this is one of the way. Second way, right? You can also, right? If you already fixed, okay. So I mean, like when I deployed it over here or create it over here, I have given a name in the namespace of this. So this is exercise for you, right? My second polyml. So here you have to put namespace, okay? And every resources we have created in default namespace, you can create also in any of the namespace. Except one thing I would like to mention: when you create a volume, and in volume when we talk this PV and PVC, okay? So try to create those with the namespace and observe what happens. Okay, so those I have given you enough information on the objects. I have given you enough information on the how you use and also the practice questions, right? So now I have covered the every topics which we have seen in our agenda, right? Kubectl, that all. And before we go to our switch back to our presentation screen, I would like to tell you one thing. Minikube delete delete all, and it won't work like this. Okay, it works like this. Okay, minikube delete all, and it should delete the everything for us. Okay, and I will not be able to see the cluster at all. Okay, and if I see like this kubectl, not kubectl, of course kubectl, and we know to check connectivity with the cluster, we don't have, right? And delete all these things, machine, everything, all trace of this cluster, so nobody can trace me on this system what I have done. Okay, so we have cleared everything, and we can also see not like this. Okay, minikube status. Okay, when you do practice, remove everything, okay, and keep the resource utilization under control. Otherwise, when you keep on creating everything, your system may, or you may feel a performance issue of the system. That's it on this one. Okay, so we are done with, okay, understanding the concept. Let's go back and see what do we have next. All right, so in the Kubernetes object section, right, deep dive section, I would say this part, we started to creating our cluster, then understand about the nodes, pods, replica set, deployment, stateful set, right, DaemonSet, ConfigMaps Secret, volume, namespace, services, in this. And we also understand, I mean, everything we have seen using a YAML, right? All the YAMLs will be provided you. Okay, I will update better version on the GitHub repository. So that's so those are the very, very important objects. Okay, I tried to explain you. Okay, please provide your feedback to improve this further. And this, with that said, we are done, right, with this section. So what do we have next? So next we have to see a project. We have to do a project, right? And as promised, we are going to deploy one application using all this technology, right? So for that, okay, we are going to deploy this application, which is very popular, okay, which is available over here. All right, so let's finger crossed our spaceship, our rocket is ready, and we cross the finger, it will deploy it successfully. Okay, so let's enforce our understanding, whatever we have learned so far. Okay, so we'll deploy, we will use each and every concept in this section. Yeah, in this section, project one. And let's see how actually we deploy the application, right? So for that, I will go over here, and you could see this is the we remove this, it's not relevant anymore, right? Docker samples example voting app, right? I will put this, of course, in resource section of the description, okay, when we upload this. And in this, right, so simply it's really amazing, right? We saw this in our Docker as well, right? And here, so it's a public one, right? We could copy this. It's really amazing app, right? These genius people, they have created it. But before we go ahead and show you something over here, right? This is the architecture, and here we have a front end web app in Python. Okay, so this is front end, which is in Python, then which lets you, if you see on this, right? So front end is a web app which is in Python, which lets you vote between the two options. Okay, and we have a Redis which collects a new vote here. Okay, whenever user give any vote, okay, so which is in stored in Redis, and worker which consumes vote and is store them in the database. So via this worker, right, it's stored in the database, and then Node.js web app which shows the result. Okay, so this is the very simple architecture of the application. Okay, I have copied the URL, and now let's go ahead and see this. Okay, and in excitement I have Minikube start, okay, profile. So I have deleted the cluster file cluster D3. Okay, so I'm not gonna create again multi-node cluster, or should I create, what do you say? All right, let's create a multi-node, not single node cluster. You know how to create multi-node cluster. Okay, so this time I'm not even gonna give a profile. Let's see with the default option. Minikube start. Okay, while cluster will be created, let's go ahead and see it's a what do we have. So git clone and this repository example voting app. Let's come in over here, and here you could see the option k at s specification. Go to this folder, right, and here we have all the files. If you want, you can open these files on your favorite editor. Okay, I really don't mind, it's up to you. I'm very comfortable. I mean, of course, that editor is more, I mean, no fun in editor, right? But if you have a plan to write exam, you are what you want to feel, because when you work on using VM, because server, you really do not have this option or this luxury, right? So for that, it's your choice, right? So here, let's go ahead and see my one. Oh, sorry, let's see, and by the time, so you could see the deployment service, Redis deployment, Redis service, result deployment, result service. So let's understand them one by one, right? And meanwhile, our cluster will also set up, and then we will deploy the application. So vim dash o, capital O, db deployment and db service, right? So API version apps v1, deployment is this one, metadata, and here you see the label. Okay, so app db name db spec, right, and spec we say replicas1, right, then we set selector, and we know what this selector means. Okay, very good. Then we have template, right, and then we have labels, and if we come over here spec, then we have a container, right, in this containers, and we have Postgres 15 Alpine, the name, right, of the container, and environment we have used Postgres user. This is the value, right, and again this is the Postgres password, this is the value, and ports, container port 5432 we know, and here we have given a name as well to the port, right. Of course you could give, and here we have defined a volume, and now we know emptyDir, right. So yes, the genius people put it emptyDir because just for, I mean, now if you want to, you know how to make, okay, adjustment, but they give you idea how to use, right. So first we mount volume inside the pod, and then we have mounted that volume inside the container, and mount path is this one, varlib postgres data, and name is db data, right. And similarly in the service, right, we have labels, this one, and spec is this one, and ports is the db service, right, the name, port you have 5431, target is again the same, and selector is app db, right. So yeah, you can also define the selector over here as well. Okay, this sequence really doesn't matter, but the position matter, okay, where you are defining. We already discussed this, right? Now, with all, what do we have next to open? Alias dash, not Alias, Alias dash. So now see the Redis. Okay, so Redis deployment and Redis service. Okay, so here is the same. Let's see the service. It's a small file selector, right, by which it finds the where it has to send the traffic. Okay, and which is over here, right? Where, yeah. So that's why it has label like this. Okay, so selector for service target port 6379, which is port for this, and it has given a name of port Redis service. You could do that, and it's a type is cluster IP. Yeah, it's a cluster IP, and DB was also a cluster IP service, right? And yes, selector labels kind is service, and here is the same, right? Deployment kind metadata labels Redis name Redis spec one. So now I told you, right? When you get internet, you get this kind of examples. So now you know which labels means what. So if you see here the name, right, labels over here, right, or mesh labels over here, and labels in template over here. So now you can very easily explain levels of each level, levels of each level. Okay, so very simple, right? Nothing crazy here, right? Everything we have discussed in very detail. And now if you see image, name is this one, port is again 67, name is this one, and this is the volume mounts. So we are mounting the volume inside this, and slash data mount path name is this one, and this name must match with this one. And this is again an empty directory with all fine. And let's open the another one. This is the Redis. Let's see the result. The result deployment, the result service. So here is again the same story, right? Levels, name, replicas, mesh levels, right? The important thing, again, repeating you, why I'm repeating, repetition is a key, right? So template, metadata, levels, app result, and spec container. So here, this is the image name, right? And this is the name, okay? And this name is name of the container, okay? And container port is 80. Name again, the port name here, this name for port. Okay, so port is result. And again, this service, right? This is a type NodePort. Okay, rest we already discussed. Here the kind is service metadata labels, right? Here the type is NodePort. It is not cluster IP. And now we know when we have type NodePort, it means this port 31001 will be open on each and every node, right? And this port is for container port. And now you can see this port and this port is match or match. If you customize this image, not emoji, image, and if you change the port, yes, you could do that. So make sure it should be also updated accordingly. And we know now this port means the port of this service, and this service is name result, and which is node port, right? So node port is straightforward. Port is the port of the service target. So only you need to remember one thing. There is a name. Let me give you a mnemonic so you could remember, because it's initially very confusing. Always remember the target. That's it. So target, it means it is outside. Okay, I mean outside, not the cluster, but it has to send somewhere. It has to send traffic. Okay, and this should match over here container port, right? And node port is node port, no big deal, right? And port is always the port of the service, right? With all, and now let's see dash vim dash o, and after result we have port deployment and port service, right? So again the same thing, container port 80. That's why here we have target port 80, but service port is 8080, right? And node port is 31,000, and type is node port, right? Again the levels So this levels for the service, right? And where is selector, right? This selector is not from here, right? This selector is from here, what we have over here, right? So that's how this is the deployment. So API version here, apps v1 v1. I also told you how you can check here the kind deployment, here the kind service, here metadata, labels, app spec type. Of course, it's a service, right? It's a selector. So in deployment, this must match with, I mean, whatever you put over here, it must be over here, and whatever you put in this, it should come from here. Okay, so that's how this is our deployment of the bot application with all. So last we have worker and worker deployment, right? Let's see. So we have worker deployment like this, and here name is this one, right? Label is this one. But what we didn't see here, we do not have any worker service at all, but still we have worker, right? So let's go ahead and deploy this, and hopefully our cluster is up and running. Minikube status. Okay, come on, it's still again. See? So I must need a practice, right? Because practice is the key. So we are good with this. kubectl cluster info, right? So we are connected, right? And kubectl get node. So if you have multi-node cluster, please don't delete the cluster, okay, and deploy it, because here you have many pods. So but I already given you idea, right? So explore, describe, do everything. So how I can deploy kubectl apply -f example voting app in cats manifest. Simple, very easy. Just put like this, and deployment, right? Service DB deployment Redis, service Redis deployment result, service result deployment vote, service vote, but deployment worker, right? We do not have deployment service for the worker, right? But we know if you want, we can do that. But yeah, genius people, they created, they know what, right? So go ahead and read more about the link. I will put that. So here, kubectl at all, and here we go. We see a lot. What we are interested in kubectl get SVCs, okay, and kubectl. Okay, come on, I'm done with kubectl. Instead of that, I will write a short form. I told you for practice you use. So that's what happened, right? When you set alias. God. Okay, kubectl or simple k get endpoints, right? So we do not, I mean, we have endpoints everywhere, and you could see it over here. So now the result and port and kubectl get nodes dash o. Come on. I forgot to put white. I'm literally tired. It's really long session so far. And yes, this is our IP. If I do like this, go and vote app, right? And vote app is listening NodePort, and we know, right, on the same machine we can access it. Like, so it says couldn't connect to the server. What happened? So again, the same thing happened as usual, and we saw some result, right? So in order to see this, okay, or for better experience, I will go back. I told you how you can do the port forwarding, right? But for this, I will go back to uh, Linux machine, and we will see over there. So let's go back and see this over there. So I'm here, kubectl at nodes, show wide right. And this is my node, right? So I must be able to access it over here. I'm sorry, next command doesn't work. Control Shift C. So let me clean this. And what is code 31,000? Okay, so now we could see the app, right? That we have given a vote. We could give only a one vote. Okay, and okay, so let me copy this. Okay, I have copy. So now we have voted. You could vote whatever you want. I just show you. Let's see the result. To see the result, here we go. Our where is the service, right? It's sitting at SVC. You get SVC, right? So this is the our result service, which is also on NodePort and which is on 31001. Sorry, okay, 31001 here, right? This is the NodePort. So we go over here. Let me copy this one. Okay, so control is different. Test is also different. So 3 for support over here, 31001. 31001. Okay, so 100%, right? Play around it. If you're a cat person, you hit vote to cat. If you're a dog person, but notice you could give a name to only one. Okay, you cannot give a two different names. I mean, not names. The two different words like this. If we see, okay, what has changed? You see what has changed, right? So that's how this is the project. Okay, this is the sample application which we deployed. Play around it, and don't think I didn't spend time. Okay, I spent a really lot amount or enough amount of time to explain you the concept, and now I strongly believe you could do more, right? And let's go to a terminal, and if you see over here, right, example and okay, so for you the example, I mean, these are the files, right? If you see, let's say db file, right? The example, not example, the deploy. So similarly you can play around it right here. Let's see, instead of putting this environment variable, okay, you maybe use a config, I mean, use the config map, right? Or maybe use, and if you see, it's a simple environment variable, so these are already defined in the image. Okay, and if you want to really play around it, okay, do the customization with this. And how do you find which this environment variable you should decide, right? So how would you find what to do, which environment variable you should use? So for that, very simple, um let's go hub.docker.com. Let me clear this, and here is the Postgres. And let's see, so this is the application, I mean, this is a Docker image, and if you see, okay, environment variables, right? So all these environment variables are defined over here, and these are waiting. And how to use this as well, so that's why initially I told container understanding Kubernetes. Okay, I mean, first you really, I mean, if you really want to have a good command on Kubernetes, you must have a very good understanding about the containerization. Okay, and that's why we put this topic for the Kubernetes. So that's why that is our day 6 and this is our day 7, right? You could also see how you can use, right, the environment variable. So go ahead, explore this in more. Next image we use was the pg admin, right? Pg admin. Let me see what we get. PGI, what was the name? PG admin. Okay. DP. Yeah, D page. This one. PG admin 4. Yeah, right. All right. So you could see how many people, I mean, how many downloads are there. And here is the latest release. It's a nightly sponsored build. So click on this link. And here it's a container deploy. Okay. And here you have somewhere environment variables. Okay. So all environment variable. So default email, PG admin default password, right? These are mentioned over here, even though how to use this, right? It's already mentioned in over here. And if you are doing it with the, yeah, with the TLS, all instructions are mentioned over here. Okay, so read about it. Okay, and like I was telling you, right? Kubernetes.io, right? When we open this and go to the documentation, right? So if I, let's say, pause, right? So you could see you have so many documentation over here, right? If I say config map, right? So again for the config map. So that's why I will put the resource link. Okay, there will be a dedicated a section for resources and links. I will put all exactly which documentation you should do, but feel free to explore, okay, and make yourself much more familiar. Uh, if you have a plan to write CKD exam and whatever I have shown you so far, if you done this very amazingly, okay, you will be able to write your CKD. I mean, of course, it is not. I just explain some of the things, but who wants 100%? Okay, so with that said, I will wrap up and I will shut down my machine now. So let's prepare and clean sudo overall now. So we have successfully deployed our project. Okay, go ahead and get your hands dirty. If you have any questions, right, you know where to contact. Our email address. Feel free to contact if you have something. And a big thanks for your love and your support, which is really inspiring. Okay, and this time it inspired us a lot. And if you want to learn more about Kubernetes, we have planned to start our training for all this certification. Okay, so don't miss out. Okay, enrollment is free. This training will be live and free. Okay, but we have limited spots for it. Go ahead and register yourself for this training. And again, additionally, if you are signing up, we would love to hear from you in the comment section below. Okay, so you can write something like this, hashtag DSOC3K8S or hashtag DSOC3CDE or sign up. Okay, so sharing your experience is optional, but can inspire others to join and get the advantage of this free training. So feel free to do that, and we look forward to, and this is our social media links. We would love to stay in touch with you, and big thanks. It's really amazing session. So thank you very much for making it more amazing. See you next time. And yeah, one more thing, in next session we will be having the monitoring topic. Okay, so we have completed so far day 1 to day 7, and we are going to start with monitoring, right? So yeah, that's a quick update, and see you. Bye bye.